So good evening all of you. Please type in the chat box, is the audio and video fine? Hi Himanshu, just confirm the audio and video once. I hope it's fine, right? Yep. Okay. Hi, welcome back all of you. So I hope it's audible. Good evening. एक बार फटाफट कंफर्म कीजिए ऑडियो एंड वीडियो दोनों ठीक किया नहीं. गुड इवनिंग राहुल शॉर्ट्स. यस ओके ठीक है. सो आज ये सेशन है. सो ये सेशन बहुत इंपॉर्टेंट होने वाला सेशन है क्योंकि जो एक्स्ट्रा टॉपिक्स है एक्सी में, मतलब ऑर्डिनरी डिफरेंशियल इक्वेशंस में, लेकिन पार्शियल डिफरेंशियल इक्वेशंस में, एंड ऑल्सो जो if you talk about numerical methods, okay, so we have certain interpolating techniques, okay, so ये सब चीज़ आज ही सेशन में हो जाएगा. एंड इस सेशन में मैंने थोड़ा सा प्रॉब्लम्स ओरिएंटेड सेशन ही बनाया था क्योंकि मैंने कल देखा था, मतलब उतना ज़्यादा थियरी पढ़ा तो आप लोगों को भी थोड़ा सा बोरिंग लगता है. सो व्हाट वी आर डूइंग इज वील ट्राई टू कीप आई हैव केप्ट मेजॉरिटी ऑफ द प्रॉब्लम्स इन दिस सेशन टुडे. सो जब हम प्रॉब्लम सॉल्व करते हैं उस टाइम पे कॉन्सेप्ट्स को ही रिवाइज कर सकते हैं, ठीक है. लेकिन अगर जो एक्स्ट्रा टॉपिक्स होते हैं सो मैं मतलब मैं अलग से पढ़ता हूँ. फाइन. सर जी एक्सेस सॉलिड का भी स्टार्ट होगा. हाँ, आई थिंक इट्स इन प्लान योगेश. सो डेफिनेटली सेकंडिंग 55 मार्क्स इन गेट एमई. हाउ मच रैंक एक्सपेक्ट? रैंक के बारे में मत सोचना, ठीक है. मार्क्स 55 अच्छा मार्क्स है. सो अगर IITs में लेकिन NITs में चाहिए तो एडमिशन मिलेगा पक्का, ठीक है. सो चलो आज ये सेशन हम स्टार्ट करेंगे. सो मैं सेशन का प्लान पढ़ाता हूँ पहले. सो इफ यू सी, या एज यूजुअल वी हैव दिस डिफरेंशियल इक्वेशंस. सो डिफरेंशियल इक्वेशंस में मैं दो चीज़, ऑर्डिनरी एंड ऑल्सो पार्शियल इक्वेशंस, पार्शियल डिफरेंशियल इक्वेशंस दोनों पढ़ाता हूँ, ठीक है. सो पार्शियल डिफरेंशियल इक्वेशंस में हम नॉर्मली फ्यू टेक्निक्स विल सी एंड देन आफ्टर विल ऑल्सो गो फॉर solutions of heat equations, wave equations, and also Laplace equations, okay, because identifying the solutions and their stability is a bit important in case of classification of PDEs is also very important. So we will go for this, and in complex calculus we'll see differentiation, some basic complex variables, and then complex differentiation is also what we will look at. And then this completely a new chapter for XC which is sequences and series. लगभग हर बार एक क्वेश्चन आता है इससे. So इसमें हम थोड़ा सा convergence tests basically for the positive terms, okay, non-negative series actually. So convergence tests, basically 𝐂𝐬𝐴 test, integral test, okay, D'Alembert ratio test. We'll talk about all these tests, and also we'll talk about Fourier series in detail because Fourier series is also in the syllabus. So we will talk about this Fourier series, okay. So and in probability and statistics, of course, like we'll talk about all series and basically this random variables in detail. Of course, we'll also talk about normal probability, basic probability, and Bayes theorem. But apart from that, we'll also talk about random variables, distributions, normal distribution, Poisson, okay. All these things we will look at, and then we'll also see some important things like mechanical में एक question आया था, okay. If x is uniformly distributed, then y equal to minus log x plus 1. ये question सबने solve किया था एग्जाम में. बहुत आसानी question है, लेकिन उतना frequently asking topics नहीं है. So we will see all that also, okay. So we'll see joint distributions, or basically we'll see functions of random variables, functions of random variables actually. So I'll solve that example, and finally, but the most lovable chapter of maths, as per my favorite chapter actually, numerical methods, okay. So in numerical methods we'll see different techniques for solving linear equations, then non-linear, Newton-Raphson, secant, all these things, and we'll also see differentiation and integration, and also we'll talk about interpolation, okay. Interpolation is actually one very nice technique which if you are doing experimentation, this interpolation is highly needed, okay. So interpolation is what we'll discuss. Basically I'll try to discuss Newton's and Lagrange's interpolations, okay. So PDF Telegram group में मैंने upload किया था ना आज, ठीक है. I have uploaded the PDF of the first session in my Telegram group. So this is my Telegram ID, so you can get the PDF here, okay. So t.me/pw. This is my Telegram group ID, so no spaces, of course, you can just type it. So there I have uploaded the notes already, okay, for of yesterday's lecture. Even after the class today, I'll upload the notes in that Telegram group, okay. So is this clear? So this is the sequence that we are going to flow so that we don't leave any topics, okay. So we will cover all things. Normally sequences and series जो completely new chapter है, and हर topic में मतलब differential equations, probability and stat, numerical methods में थोड़ा सा changes है when compared to maths. So definitely we'll try to cover all these things. Clear? Yes or no? Nice explanation. Thank you, Farid. Sorry, Farhan Ahmad. Where will you get PDF? I've answered. Yeah. Okay. So we will start solving these things. Okay. So starting with the first differential equations. Again, I'm telling you again, I'm not going to discuss, like for example, I don't want to say question number 1, solve dy by dx is equal to x square y, y of 1 is equal to 0. I don't want to solve this kind of questions because you know you have solved them enough number of times in your life. So these kind of questions, you know, I'm just skipping up. But जो questions थोड़ा सा hard लगता है लेकिन जो conceptually थोड़ा सा strong होते हैं, so वही questions मैं इस sessions में discuss करता हूँ, ठीक है? So let's see differential equations. So if you talk about differential equations, you know, equations which involve differential coefficients like d by dx का terms भी मिलते हैं. Hi Devesh. So see here we define first thing something called order. So which is order of the highest order derivative. The highest order derivative in a degree, in a differential equation, okay, in a differential equation. And degree is nothing but degree of highest order derivative, degree of highest order derivative, when this line is very important, when dE is free from radical powers, okay, or radical, or basically these are nothing but fractional powers, okay, radical or fractional powers, okay, powers. Like for example, if I ask you something like you know, if I ask you a differential equation, okay, d square y by dx square is equal to, in Huygens Poiseuille flow, if you neglect that, yeah, d square y by dx square is equal to square root of x square y, for example, whole power or cube root of x power cube root of x square y, for example, okay. So let's say if I ask you what is the order and degree of this differential equation, then you all know that order is 2 because in this differential equation we have the second order derivative, and even if I have the first order terms, then definitely the highest order is 2, so order is 2. Now what about degree? I cannot say, since the top power is 1, I cannot say that degree is 1, okay, because to say degree is 1, this equation is still in fractional powers. So if I want to say degree, पहले मैं इस fractional powers को eliminate करना चाहिए. So let's see, this implies your d square y by dx square whole cube is equal to x square y, correct? So अब इस equation radical power से free है, so we will say that the degree of this highest order derivative is actually the degree of the differential equation, ठीक है? Yeah, order is 2 मैंने लिखा था, so degree is actually 3 in this case, ठीक है? So degree is basically 3 in this case, ठीक है? So इस line को याद रखना बहुत important है. So whenever you're trying to define degree, then definitely that equation should be free from radical powers, ठीक है? And then we'll classify these differential equations based on, you know, we have plenty n number of calculations, but we will see differential equations will be classified based on ordinary differential equations and also partial differential equations, okay? And majority, if you see in ordinary differential equations, in GATE syllabus point of view, and also in normally at your undergraduate level, the majority of the differential equations what you study is ordinary differential equations, okay? Why? Because they are easy to solve. Majority of the things in nature deals with partial differential equations, okay? Like for example, आपने fluid flow देखा तो Navier-Stokes partial differential equations, okay? Heat equation, okay? Conduction equation, partial differential equations. Similarly, you talk about divergence of stress tensor plus body force, okay, rho times body force is equal to 0. This is the equation in case of equilibrium of bodies, okay, normally in case of stresses and all, then that's also a partial differential equations, okay? So like this, if you keep doing, majority 95% of the equations that you deal in world are partial differential equations. Now just to ease the things, we make certain assumptions and we convert partial to ordinary so that things are solvable little, okay? Now in ordinary differential equations, we will first of all look at first order equations, then we'll also eventually look at higher order, okay? In higher order, we'll also see Wronskians and power series solutions, because they all are in XC syllabus, okay? So power series solutions, and we'll also look at eigenvalue problems actually, okay? Last year एक question आया था eigenvalue problems से, okay? So this is the eigenvalue problems actually. So these things are important actually. Of course, normally first order you might have seen plenty of times again. Of course, I'll have a quick brush up, but majorly this focus is on higher order, and also in higher order also not like writing particular integrals, all this stuff, you know how to do that, but main importance is on Wronskians, okay? How to calculate 𝐂𝐚𝐿, okay, and how 𝐂𝐚𝐿s are used in solving differential equations, okay. So we'll use the techniques, and then we'll look at power series solutions and also eigenvalues problems. Of course, in GATE you don't have legend of polynomials, especially some special functions, but your idea is only to know a few things about this power series solutions, okay. That's what clear. So these are the things, and in partial we'll forward, okay. So firstly, if you take first order equations, of course forming or differential equations I'm not framing up, because you know, forming, normally if they give you a solution, you all know, like if there are two arbitrary constants in the solution, then you have to differentiate the function twice, and then you have to eliminate the constants, arbitrary constants, so that you'll get a relation between x, y, y dash, y double dash, these things, okay. So like for example, you know, if you have an equation f of x, y double dash or x, y, y dash, y double dash is equal to 0, maybe some equation like this, let's say, okay. Now when you are solving these equations, one thing that you get is you'll get two arbitrary constants, okay. So two arbitrary constants, as this is a second order differential equation. On solving, this gives you two arbitrary constants, okay. So when solution is given, you have to eliminate the arbitrary constants by differentiating it twice, okay. This number of times you have to differentiate to form a solution depends on number of arbitrary constants in the solution, because obviously order is equal to number of arbitrary constants, okay. Now coming to first order equations, the equations maybe generally of the form dy by dx is equal to some function f of x comma y equation, okay. And of course these equations can be non-linear also sometimes, okay, but right now I'm just focusing on the you know, this is the general form dy by dx is equal to f of some function of x comma y actually, okay. Now if you want to solve, then you have certain techniques, which is variable separable, which you all know, right? We can basically, you can split this function f of x into two separate parts. One is only function of x, other is only function of y. Then you adjust them and integrate, you'll get the solution. Done? Yes or no? This variable separable is known to you, to all. Like for example, if you see, if you have your dy by dx is equal to some function f of x comma y, at times you will be able to split this as two functions, phi of x into maybe some psi of y actually. So dy by dx. Now you shift this here, this becomes 1 by psi of y dy is equal to phi of x dx. That's all, okay. So once you have these functions, then just integrate them, the things are solved. This is basically the variable separable form, right? That's all. You might have seen this, right? All of you might have done this, correct? Yes, all of you have done this now, correct? Yes or no? Normally doing in mechanics, in fluid mechanics, of course fluid mechanics is also some part of mechanics, so you might have done this kind of questions, okay. Like you can see, if you want I can give you some example. Let's say you have dy by dx is equal to 3x square y, okay. Then definitely what you can do, 1x square dx is equal to 3x square dx is equal to 1 by y dy. So if you integrate this, then this gives you x cube is equal to log y plus constant, so y is equal to constant into x cube. This is the solution of this, okay. So all these things you might have done, and normally if they give you one boundary condition, then just put the value of x and y, then if you simplify you'll get the constants. That's all, okay. So let's see, let's get into the next stuff. We also might have solved about homogeneous equations, homogeneous first order actually, okay. So homogeneous first order. So if you see, dy by dx is equal to some function of x comma y divided by some function of x comma y. But here if you see, if these two are functions of x comma y, then definitely ratio is also some other function, maybe h of x comma y, okay. So that's also a first order differential equation. But one thing is, when you call it homogeneous, in yesterday's class I have given you the definition of a homogeneous function. If f of x comma y is homogeneous function of degree n, then f of kx comma f of ky, f of kx comma ky will be k power n times of f of x comma y, correct? I have given you. So these two functions should be homogeneous of same degree. Both are homogeneous of same degree actually, okay. So both are homogeneous of same degree. Then basically we might have studied some classical techniques, like put y is equal to vx, then this implies y equal to vx, then this turns out the homogeneous dE to variable separable form. On making this substitution, variable separable form actually, okay. So variable separable form. So once it's in variable separable form, you guys have plenty of techniques to solve how to do that. Now let's see, in this homogeneous dE, Like I would like to again give one example, maybe say 2x plus y dx plus, okay, x plus 2y, okay, so x plus 2y, yeah, dx is dy actually is equal to 0, for example. Okay, so let's say this is the equation, okay, 2x plus y dx plus x plus 2y dy is equal to 0. If I want to solve, I can solve this, but I just want to show you this technique. Just a minute. So dy by dx will actually give you minus 2x plus y divided by x plus 2y. Then you put y equal to vx. If you put y is equal to vx, y equal to vx. If you differentiate this with respect to x, dy by dx is equal to v plus x into dv by dx actually. So this is what you get. If you substitute, then instead of this dy by dx, instead of this dy by dx, you replace this v plus x into dv by dx is equal to, let's say I'm taking x common in both the terms, then I have minus 2 plus v divided by 1 plus 2v. That's all. Okay, then what happens? You throw this v here, simplify. This is completely function of f. X into dv by dx is equal to maybe some function of v. Okay, you do the algebra, you'll get it. So 1 by h of v dv is equal to 1 by x dx. That's it. Okay, and this guy is in variable separable form. Clear? So this is basically in variable separable form actually. Clear? So this is in variable separable form, and depending on the see, if you simplify, if you put this, take LCM, multiply that, and bring all these terms, you can adjust that this is basically a function which is going to be in terms of v actually. Anyway, here I just want to show you, because I want to show you the advantage of knowing a few things later. So I'll solve this completely. Look, h of v. So what is h of v actually? Come on, minus 2 plus v minus v plus minus v minus 2v square divided by 1 plus 2v actually. Okay, then definitely this and this gets cancelled. If you pull out minus 2, you have 1 plus v square divided by 1 plus 2v actually. Okay, so x dv by dx. Now if you bring these terms here, you leave the minus 2 there, 1 plus 2v divided by 1 plus v square, okay, 1 plus v square into dv is equal to minus 2 times 1 by x dx. This is what we have. Now let's do certain things to, because it's not the direct derivative, it's actually we can split this as 1 by 1 plus v square plus 2v by 1 plus v square dv. Okay, and you integrate dv is equal to minus 2 ln x plus constant actually. Okay, this is nothing but tan inverse v. This is log of 1 plus v square. So if you simplify, you'll get the answers. Okay, so this is nothing but tan inverse of v equal to y by x. Again, you put tan inverse of y by x plus log mod 1 plus v square. So log mod 1 plus y square by x square is equal to minus 2 ln x plus constant. Okay, this is how basically you can solve. The main thing is when you substitute this, it converts homogeneous differential equations to variable separable and things go fine. Got it? Yes or no? These techniques also you might have seen. Yes? Come on, we'll solve fast. Okay, once we start going into higher order, we'll start some numericals also. Okay, let's see if I have got any numericals of first order. Majority I think no. This is second order, then second order, partial differential equation. This is second order, this is partial differential equations. Okay, fine. Anyway, it's okay, no issue. We might have we day in and day out solve first order differential equations always. Okay, no issues. Yeah, so sorry, but please solve it one time. This one. Okay, I'll solve. Shorts Wheels has requested me to solve it. Fine, if you want me to solve, then integration 1 by 1 plus v square. So tan inverse v. So tan inverse y by x plus then log mod 1 plus v square. So log x square plus y square minus ln x square is equal to then minus 2. So if you put this 2 onto the top, then this is minus ln x square plus constant. Okay, so then these guys gets cancelled, and basically tan inverse of y by x plus ln x square plus y square is equal to constant. This is the solution. Okay, yeah, I've solved it. Okay, clear? I've solved it once. Fine, so this is the solution of this. Okay, because we can be replaced with y by x. So if you replace y by x here, then definitely this, initially this is tan inverse v. So tan inverse of y by x plus log 1 plus x square by y, 1 plus y square by x square. So if you take LCM, ln x square plus y square by x square, so log a by b can be written as log a minus log b. So that's how I got these two terms basically. And here that 2, if you throw it onto the top of x, then it becomes minus ln x square. That's all. Okay, fine. Yeah, so this is the solution. Okay, so this is one case. And then you have non-homogeneous equations also, like for example, you might have seen these forms. dy by dx is equal to ax plus by plus c divided by bx a dash x plus b dash y plus c dash. Okay, then you have these things basically. Okay, when you do this, then there are two cases in this, which of course not come in gate generally, but I just want to quickly go through. You know, ax, if a by a dash, okay, so let's say if these are proportional to each other, a by a dash is equal to b by b dash, then obviously you will make the substitution a dash x plus b dash y is equal to some t, variable t. Okay, and if you make this as if you can make this as some 1 by k, something like that, then you can replace this ax plus by as a dash x plus b dash y into some constant plus c. Okay, so by substituting this, by this substitution, this dg, you call this 1, this guy 1 turns to variable separable form actually. Okay, so 1 turns up to variable separable form, which you can directly solve again. Okay, so 1 turns up to variable separable form directly. So because when we'll start solid mechanics, I think in the next 2 days. Tomorrow we have, I think I won't be available because I have some other live on EC channel. I'm teaching maths there. We have fluid mechanics, I think not fluid, not fluid, I think thermodynamics. Shivam sir and Sandeep sir are going to take at 2 p.m. 2 p.m. or 12 p.m. You please check the timings. Okay, so I'm not pretty much sure of the timings, but again, Sandeep sir and Shivam Dikshit sir are going to take thermodynamics, and in evening I'll take fluid mechanics Maha for the extra topics, and also most the topics which are frequently asked in XC but not in mechanical, but they in both the syllabus. Okay, so we will put special focus on most repeating topics of XC and also extra topics. Okay, we'll talk about the Reynolds transport theorem, potential flows in complex numbers, of course. Okay, whatever the basics you need for potential flows in complex numbers, I'll teach you today when I'm teaching complex numbers, so that things will be very easy for you. Okay, in superpositions and all, you need not remember the formulas then. Clear? So that's what. And then on Thursday, me, Shivam sir, Sandeep sir, all 3 of us are going to take some FM Abhyas, Maha Abhyas. Okay, so that would be helpful. Clear? So this is the lineup till Thursday. Friday maybe you can relax a bit. Saturday is the exam day. But anyway, maths you can get some 10 marks to 12 marks confidently. It would boost your rank in hundreds, to be honest. Okay, so that's why. Clear? So this is the case. And case 2 is if dy by dx is equal to ax plus by plus c divided by a dash x plus b dash y plus c dash. Okay, and the condition is basically this a by a dash is not equal to b by b dash. Okay, so these terms are not proportional to each other. A by a dash and b by b dash are not same. Chemical branch is the syllabus different. Maths, I think not this much has to be studied, because whenever there's an extra topics for XA, I'm mentioning it. Okay, so please go through the syllabus. Okay, or a detailed view of the syllabus actually. But anyway, for XC, the maths questions you might have seen, they are slightly slightly complicated, but again conceptual. Okay, so see here, if this is not the case, what you're gonna do is you put x is equal to x plus h and y is equal to y plus k, such that ah plus bk plus c is equal to 0, a dash h plus b dash k plus c dash is equal to 0. Now you have 2 equations and 2 unknowns, h comma k are unknowns. If you replace that, then this equation, if you call this equation 2 for example, then 2 gets again converted to variable separable form. So these are the pretty much techniques which you can just go do in day in and day out to get the solving of first order differential equations actually here. So a dash h plus b dash k plus c dash, because when you are choosing 2 variables, choice of this h and k is arbitrary. So we will choose in such a way that when you substitute these two, when you substitute small x comma small y in these equations, then definitely this is the term which comes out, a into capital X plus b into capital Y plus this term will come. So if you can choose h comma k in such a way that this equation is 0, then that equation converts to homogeneous by putting capital Y is equal to capital Vx v into capital X, again that gets converted to variable separable form finally. Okay, so that's what I'll better write it here. So 2 implies homogeneous equation, then by putting y is equal to vx, you'll get converted to variable separable form actually. Okay, so this gets converted to variable separable form. You can follow this loop, you can solve, but generally questions don't come from this because it's a bit lengthy, but questions can generally come up to this level. Okay, because it's a simple substitutions. Clear? Now let's get into one more thing, exact differential equations. These are a bit of important stuff. Exact differential equations. So what is an exact differential equations? Obviously, so you all might have seen this condition, right? M dx plus n dy. Let me write it a bit. M of x comma y, this is function of x comma y, dx plus n is also function of x comma y, dy is equal to 0. So let's say this is a first order differential equation. Okay, because any first order differential equation can be written in this form. So m dx plus n dy is equal to 0. For this to be exact, then the condition that you have is dou m by dou y should be equal to dou n by dou x actually. Okay, so dou m by dou y should be equal to dou n by dou x. Then सिविल की क्लास कितने बजे से होती है सर? सिविल गेट इज फिनिश्ड नो ऑलरेडी, लेकिन पता नहीं, लेकिन civil XC chemical, see whoever is writing XC, you are from mechanical, civil or chemical, anything, syllabus is same. Okay, this syllabus is same, XC syllabus is same to all branches. Clear? It doesn't matter from which branch you are writing XC, as long as you are writing XC, syllabus remains same. Clear? Now come back to the situation. Have you all seen this? Yeah, Netflix. I have told you many times actually. So just to remember this, you will remember the word Netflix, because I forgot actually, but yeah, some of you remember Netflix. So keep this n and x combination together so that you write this n and x correctly. If you know n and x stay together, then definitely m and y stay together. Okay, that's it. Because many of the students, when you're framing this equation, you don't understand this. Okay, you generally confused a bit, and options will be given in such a way that dou n by dou y is equal to dou m by dou x. They'll try to confuse you. Okay, so just remember this word, remember this n and x combination, so that you automatically remember the other thing. Okay, and do anyone of you know, can anyone of you seen why this condition has to be 2? Yes or no? Can anyone of you tell me why this condition has to be there? Let's say for example, if that's a differential equation, why it's called exact differential equation, and if something is exact, why this happens? Just 2 lines. Okay, so let's see. The meaning of exact differential equation is 0 implies, for exactness, exact differential equation means this term whatever is written here, that's actually exact differentiation of some function. That's all. Okay, so the solution is simply f of x comma y is equal to constant. That's all. Clear? So it's called exact differential equation because this part which is on the LHS is actually exact derivative of some function. Like for example, if there is a 2 variable function, if you want to differentiate this, how do you differentiate? Dou f by dou x dx plus dou f by dou y dy. Correct? This is what you write actually. Okay, so this is what you write, and here we are calling this as m and we are calling this as n, so that m dx plus n dy is equal to 0. Okay, yeah, it's a point function. We deal a lot of the times in thermodynamics and all. So exact derivatives. So if this left hand side whatever I have written is perfect differentiation of some function f of x comma y, then we call that exact. It's exact derivative, so that's why it's called the exact differential equation, of course. Now in partial differentiations, we know one thing. If you see dou square f by dou x dou y, or dou square f by dou y dou x, these 2 things has to be equal as long as the function is smooth, of course. Okay, so you can write this as dou by dou x of dou f by dou y. In partial differentials, in multivariable calculus, I have given you some basics about this, dou f by dou x. Okay, and here this guy dou f by dou x, if you compare, dou f by dou x is taken as m, and this dou f by dou y here is taken as n. So this talks about dou n by dou x should be same as dou m by dou y. Okay, in thermodynamics, whenever they give you certain function, if you want to check whether it's a property or not, you will actually check using this. Okay, dou m by dou y is equal to dou n by dou x actually. Clear? Is this clear to all of you? Did you understand how this equation actually arises? Basically from this. Okay, the meaning of exact differential equation is the function or basically the equation. This equation, if you exclude 0, this expression is actually the exact derivative of some function, and if it's an exact derivative, then definitely this should hold. So that's why we check whether the equation is exact or not by checking this condition. If this is valid, then the equation is exact. If it's not valid, then the equation is not exact. Okay, now what is the advantage of having exact differential equations? Okay, simple. You know, if you just integrate this, f of x comma y is equal to constant, that's all. It's solvable. Okay, in a single line it can be solved. If you know that this is derivative of some function, then the only and only thing is you calculate what is this function f of x comma y. F of x comma y is equal to constant is nothing but the solution of this equation. Okay, so let's see what we can do. If m dx plus n dy is equal to 0 is exact. Okay, so let's say if this is exact, if this equation is exact, okay, if this equation is exact, then we see solution is integral m dx treating y as constant plus integral terms not containing x in y, sorry, in n, terms not containing x in n dy is equal to some constant. Okay, so this is equal to some constant. This is the solution directly. Okay, to make exact, please clear concept confused. Yeah, I'll tell you. Okay, what is the integrating factor and what is the advantage of making integrating factors, I'll explain you. Okay, so just a minute. So if you know something is exact, then this is the direct solution. This is nothing but same thing again. Okay, if you do that integration of that, you will end up with this. Now let us see why this is very easy to do. Let us visit this equation back again. So we have done a lot of stuff to understand the solution, which is this. Even after writing this, many of you felt I have written direct steps. Okay, so let's try to understand something here. If you see this equation, okay, so consider 2x plus y dx plus x plus 2y dy is equal to 0. This is the same equation as this. Okay, so whatever is this equation, so ये भी same equation है, ठीक है? So this is also the same equation. So let's see. If you see this is m and obviously this is n. If you calculate dou m by dou y, which is 1 clearly. Okay, dou n by dou x, if you calculate, this is also 1, of course. Okay, so clearly these two are equal, so definitely the equation is exact. So if this is exact, we can write solution in single line. Let's see. Integral m dx 2x plus y dx treating y as constant, okay, plus integral terms not containing x in n. Okay, terms not containing x is basically 2y actually. Okay, so integral 2y actually into dy is equal to some constant actually. So if you integrate this, if y is actually constant, integration of 2x is x square plus y dx actually. Okay, so integration of y dx, so this is yx of course. Okay, because y is constant, plus this gives you y square by 2 is equal to, sorry, y square is equal to constant. Okay, so this is y square is equal to constant. That's it. So this is basically the solution of this equation. X square plus xy plus y square is equal to constant is actually the solution of this equation. Let's see. I think here we made some calculation mistake or what? Let us check. Did we commit any calculation mistake here? Because both should actually match. Okay, that's why. So let's see. Dy by dx is equal to dy by dx is equal to minus of 2x minus y. Now this is minus y, it's not plus. Okay, because when you shift this term completely, it should be 2 minus 2x minus y. Okay, so if you make this minus 2x minus y, then make this minus, then these two are not eliminated. You have minus 2v. Minus 2v is what you have. Okay, let's solve it again, because I just want to show you that both gives you the same solutions. Okay, so anyway, let us solve this carefully. X into dv by dx is equal to minus 2 minus v minus 2v square divided by 1 plus 2v actually. Okay, so if you take minus 2 common, you have 1 plus 2v plus 2v square. Okay, so if you take 1 plus v plus v square, 1 plus v plus v square divided by 1 plus 2v. This is what you would have got actually. Okay, so if you leave that minus 2 on that side, then here you're gonna get 1 plus 2v divided by 1 plus v plus v square. Okay, and clearly if you integrate this, so this step is not of need now. So if you integrate this, okay, so if you integrate this, then it is nothing but this numerator is exactly the derivative of denominator. So ln 1 plus v square is equal to minus 2 ln x plus constant actually. Okay, then what you can do, you just eliminate this 2 and put it on the top of x. Okay, and if you simplify this expression, let's see what you would have got. Ln, these two guys are wrong, then see, because of 1 minus, completely solution is changing. Okay, so this implies, let's see here, ln of 1 plus y by x, ln of, see, this is log a and this is minus log b, so you put it here. So this complete expression is nothing but 1 plus v square by x square is equal to some constant. Okay, and if you put y is equal to vx actually, okay, so this is plus, no, so if it comes here, this is plus, so it's not divided by, it is multiplication, x square times of this. Okay, so if you put y is equal to vx, then you get x square plus xy plus y square is equal to constant. That's it. So this is the solution, correct? Because if you see 1 plus y by x plus y square by x square, if you take LCM, x square in the denominator and numerator cancels, and these terms will have x square plus 1x and this. Okay, see, here you have done a lot of things, lot of algebra to get this solution actually. Okay, but here by knowing this equation is exact, you see within 1-2 steps you are able to get the complete answer. So converting any equation into exact form will reduce the will actually, you know, make you write the solution very easily. Okay, so that's why what we'll do is converting non-exact to exact forms. Okay, this is very much important because you have just seen the advantage of having this. So that's why this is basically very important thing. Okay, now how do you convert? Okay, so to convert, we have something called integrating factors. Okay, so what are these integrating factors? What are these integrating factors? Let's see. Normally, if you have a non-exact differential equation, if you multiply with this factor, the equation turns out to be exact differential equation. Okay, like for example, you see, I just want to show you the factor which, when we multiply, the factor that we multiply, you better write this, the factor that to a non-exact DE to make it exact. Okay, this is very important, and sometimes they can ask you what is the integrating factors. Okay, so let's see, because some of you has a doubt. Let's see here. What is the advantage of converting to exact? We know we can write the solution in a simple way. Like you can see x dy minus y dx is equal to 0. For example, you take this equation. Of course, you know, this can be directly solved using variable separables, but I just want to explain you one simple thing here. Okay, so for example, instead of solving it using variable separable form, if you want to solve it, okay, using some exact form, let's see. First of all, if you see this is m, then this minus y is actually n. Okay, because the equation should be always m dx plus n dy form. So if there is a minus, you throw the minus inside and put a plus. If you calculate dou m by dou y, this is 0. Okay, and if you calculate, I think here it is coming out to be exact. Yeah, this is exact actually, but you know, normally if you can see, okay, so yeah, x into e power y dy minus e power y dx, for example. Okay, so let's say you have this equation, this is equal to 0. Okay, so let's say this equation is equal to 0, for example. Then you can see, if you can see, this is m and with a minus sign, then this minus e power y is n actually. So if you clearly calculate dou n by dou x, this is 0. Okay, and if you calculate dou m by dou y, this is x into e power y obviously. Okay, so dou m by dou y gives you x into e power y, because x is a constant actually. Okay, to make exact, please clear the concept. Yeah, see, dou m n by dou x, if you calculate this with respect to x partially, this is 0 because there is only a single term in y. But if you calculate dou m by dou y, you'll get x into e power y actually. So this equation is clearly non-exact equation because these two terms are not equal. Okay, but now if you multiply this factor, integrating factor, which is equal to 1 by x square, for example. Okay, so let's say if you have integrating factor 1 by x square, how to get this integrating factor? I'll give you a hint, I'll give you some standard rules, but right now let's say if 1 by x square is an integrating factor, then if you multiply this equation, let's see what happens. X into e power y dy divided by x square plus minus e power y divided by x square dx is equal to 0 actually. Okay, so this is what you have, and clearly this x can end up this minus x. Okay, so this x can actually eliminate this x, of course. Okay, now this is m and this is n. M is equal to e power y by x. N is equal to minus e power y by x square actually, correct? So this is what you have. Yes or no? M and n are taken. Waiting, sir. Sorry, sir. M and n interchanged. Yeah, sorry. M and n interchanged. Okay, fine. Yeah, m and n interchanged. Yeah, okay. So just a minute. I'll show you. Yeah, m and n interchanged, right? Yeah. So let's see. This is m and this is n. Okay. So this is m and this is n, for example. Then if you calculate, this is n. Okay, let me write it again. No issue. So m is equal to minus e power y and n is equal to x e power y, of course. Okay, so n is equal to x into e power y. Now if you calculate dou n by dou x, or if you calculate first dou m by dou y, dou m by dou y is m dx. Okay, so plus minus e power y. So minus e power y is what you have. If you calculate dou m by dou y, this gives you minus e power y. And if you calculate dou n by dou x, this is equal to e power y, of course. Okay, now clearly these two things are not equal. Okay, so when these two things are not equal, what we are doing, we are multiplying it with a factor 1 by x square actually. This equation is actually non-exact equation. Okay, so this is a non-exact equation. Now when you multiply this with 1 by x square, let us see, this equation turns up to be e power y by x dy plus minus e power y divided by x square dx is equal to 0. Okay, now you got a new set of m comma n. So let's say this is m now and this is n. Now if you calculate dou n by dou x, e power y is constant, so minus e power y divided by x square. Okay, and if you calculate dou m by dou y, then definitely what happens, this minus 1 by x square is constant and differentiation of e power y is e power y itself. Now you see these two terms got into equality sign, so definitely then now this equation is actually exact. Okay, so if this equation is exact, then we can again write the solution using this form. So basically the power of integrating factors, of course here I have taken a simple example, but normally if you have any integrating factor, it converts the complete non-exact differential equation into exact, of course. Clear? Yes or no? Did you understand this? By multiplying this 1 by x square, but we'll see how to get this 1 by x square actually by multiplying this 1 by x square to this equation which is non-exact initially, which you can see this minus sign is not there, but now it has got converted to integrating. So how you decided the integrating factor for this equation? That's what the next step I'll tell you that, but right now is it clear to all of you? Yes. Basically here I decided based on experience. Okay, you know, stunts performed by professionals. Okay, so I'll tell you, see how I have performed, because when I am forming this question, I know I am interested to write this. That's it. Okay, so if you expand this, first derivative into derivative of second function minus second function into derivative of first divided by x square. So that x square, excuse me, sorry. So here one x square is missing, so if I multiply with x square, that turns to exact. This is how I decided 1 by x square. Okay, but anyway, this is not the way to write the integrating factors. I'll give you some standard rules actually. Okay, because if I differentiate this, one x square is missing now in the denominator. If I put that x square, this equation becomes exact. That's the logic behind it. Okay, clear? Yeah. सॉरी समथिंग वाज रिटन डेमो में था एक क्वेश्चन 2022 के पेपर में. If you have, we can discuss, no issue. Okay, I'll discuss. See, you can ask me anything related maths, fluids, thermal. Okay, and maybe solid mechanics, but not vibrations and theory of machines. I'm not much comfortable there. Solids, fluids, and thermal and maths, you can always ask me anything. Okay, heat transfer, of course heat transfer is not in XE, but normally in mechanical, if you're studying and if you have any doubts in heat transfer, you can turn up in that Telegram group. Okay, I'll be helpful to you. Clear? So let's see. Yeah, so how to identify the integrating factors, that's the main job actually. So see here, identifying integrating factors. Identifying integrating factors. First one, as you know, by inspection. y inspection. So clearly, if you just observe this equation and you feel something is there, then definitely you can multiply that. Okay, like for example, you can see if I have something like x dy plus y dx, then definitely I can put it as derivative of xy. Okay, similarly, if I have derivative of x dy minus y dx by x square, then definitely I can write it as derivative of y by x, things like this. Okay, similarly, derivative of x dy plus y dx by xy, if you have this, you can write this as derivative of log xy to the base c. Okay, so like this, depending on observations, you can just write the terms. Okay, but anyway, it's not possible for us every time just by looking at the equation and just writing the things. But so we have to know certain classical procedures to identify if equation is homogeneous, then if, normally I'm denoting integrating factor with if, please don't get confused with these two. Okay, so if is actually equal to 1 by mx plus ny actually, such that your mx plus ny is not equal to 0, of course. Okay, so this mx plus ny is not equal to 0. Don't get confused, this is m dx plus n dy, this is mx plus ny. Okay, so mx plus ny should not be equal to 0 actually. Clear? So revision classes, so XE 10 marks score. Yeah, definitely you can score XE around 10 marks if you follow thoroughly. Okay, but also you have to apply correctly. These points are just knowledgeable points. Okay, you have to apply this carefully to the this what I would say, you should apply this carefully to the exam. Okay, now let's see one more thing. Then integrating factor is equal to 1 by mx plus ny comma mx plus ny. So second, if dE is y into some function of xy dx plus x into some function of xy dy is equal to 0. Okay, and you call this as m and this product as n. Like for example, what happens, sometimes you have these terms like x into tan xy product of this term, some function involving product of this x and y. Okay, so if you have that terms, then your equation is going to be then integrating factor is 1 by mx minus ny actually, and of course the condition is mx minus ny is term 0 नहीं होना चाहिए. Okay, so अगर 0 है तो then definitely division with 0 is not defined. So इसलिए हमें एक चीज ध्यान से देखना है कि mx plus ny and mx minus ny, these terms are not zeros actually. Clear? Now third thing, if 1 by n times of dou m by dou y minus dou n by dou x is purely a function of x. Let's say आपके पास m dx plus n dy equal to 0 इक्वेशन है. So उस इक्वेशन में if you have this combination, okay, so 1 by n into dou m by dou y minus dou n by dou x is equal to some function of x actually. Okay, then integrating factor e power integral f of x dx. That's it. Okay, so then this is the integrating factor. See, basically I'm habituated to do these things day in and day out, so I can write them, but when you are applying, please take care of the minus signs. Okay, and I'm not proving this, actually all these results can be shown to you. Okay, like we can properly start from m dx plus n dy equal to 0, then you will see when you multiply this equation with that, of course that's one way to show that if you multiply this factor to that, then obviously the new m and n which forms will satisfy the dou m by dou y equal to dou n by dou x. But you can actually generate this, okay, depending on basically by slightly adjusting the equation, you can actually by adding few terms and subtracting few terms from this equation and doing bit of shifting the terms, you can eventually end up with this is the integrating factor. Okay, so right now I'm not doing all those things because time is short and we have to go a long way today. Okay, chalo, let's and also one more important thing, fourth point, if 1 by m times of dou n by dou x minus dou m by dou y is equal to some function g of y, then integrating factor is equal to e power integral g of y dy. That's it. Okay, so this is basically the integrating factor in that case. So these are the four techniques, and normally within the syllabus of GATE and your undergraduate syllabus, things fall in one of these four categories, so you will easily end up with calculating the integrating factor. Clear? The only thing you have to be little cautious is this second one. Okay, y into this should have some product of some function involving product of xy. That's it. Okay, so this is how you calculate the integrating factors. Clear? And if you know the integrating factor and if you multiply the equation, then getting solution is like a cakewalk. I have just shown you. Okay, fine. So you're Devata of math. Okay, sorry. I read it like Devata because recently I have watched Salah movie, so I felt like you're telling me I'm Salah of maths. Fine, anyway, funny. Good. What we are talking? Yeah, integrating factors. Okay, so once this integrating factors are thoroughly done, having integrating factors is always helpful because they, very much they pull down they cut the steps algebra involved in finding the solution. You can directly get the solutions. Okay. Now, once this is done, we'll look at one important stuff, which is the linear equations. First order linear equations. So, basically, when you call equation linear, basically when the equations are not involving non-linear terms. Okay. So, means you cannot see in this equations, equations doesn't involve higher powers of derivatives and dependent variables and also y into y dash terms. Okay, so this kind of y dash double dash, so these terms also should not be there. Okay, so basically it should not be a double differential equations. Clear? Okay, so let's see if this is the differential equation. Okay, so normally there are questions in mechanical, not in XC much, because in XC these questions are very easy questions actually. If you see, they will give you some 3-4 equations and they'll ask you which of them is linear and which of them is non-linear. Okay, so you have to pick carefully depending on these conditions. So integrating factor case second condition is 2 for all cases. Yeah, for what all I have given you, all are clear. Okay, I mean all are applicable to all the equations. Clear? Okay, so let's see. So one equation which I would like to say very important, or rather than important, it's like more frequent actually. Leibniz linear equation. Okay, so what is this Leibniz linear equation? Let us have a stretch. So in the Leibniz linear equation, if you see carefully, the equation is of this form: dy by dx plus p into y is equal to q, where p comma q are functions of x actually. Okay, are functions of x alone. Okay, so they are functions of x alone. Then when they are functions of x alone, clearly we could have actually this is a linear differential equations. Okay, sorry, कोई तो बता दो solid mechanics का revision कब होगा? Will tell you. Okay, hopefully in the next couple of days it can come sometime, but stay tuned in this channel, so definitely you can find the day. Okay, so chalo, if you want to solve this equation, so I'll just give you certain things. Integrating factor is equal to e power integral p dx. Okay, so where p is this function. Like you can see clearly, if you swap this equation, okay, you can end up with py minus q dx plus py minus q dx plus dy is equal to 0 actually. Okay, so you can understand clearly m is equal to py minus q, n is equal to 1 of course. Okay, now if you consider 1 by n times of dou m by dou y minus dou n by dou x actually. Okay, so if you consider this, then 1 by n value is 1, dou m by dou y is p, because this is only a function of x. If you are differentiating partially with respect to y, this function will give 0, minus dou n by dou x 0, and this is p of course, and p is only a function of x. So when p is only a function of x, then integrating factor is e power integral p dx, because this is in sync with this third point. Okay, so you can see with this third point, this point is in sync. So this way Leibniz linear equation have the integrating factor as e power integral p dx. Clear? Many of you might have studied how this actually happens. So this is how it happens. Okay, e power integral pdx is basically from this equation. Okay, so basically from this third point we could get e power integral pdx. Okay, and if you multiply e power integral pdx to this equation, it turns out to be the exact derivative of the solution is y into e power integral pdx is equal to integral of q into e power integral pdx dx plus constant. So this is one thing that you can have actually. Okay, now I'll solve one example basically to make you understand how this happens. Okay, so let's see. I would like to solve an example 4t square plus 1. Today I was solving for ECE people actually, notably I guess, dy by dt plus 2t y. Okay, so I think 2t or 8t I think. Okay, so this is 8t y is equal to t. I think this is what you have basically. I think 2t. Okay, so anyway we can adjust if something is wrong, no issue. So this is also a differential equation which is f of 1 is equal to 0 maybe. Okay, so let's see, this is an equation. Then they are asking you f of y of infinity. Okay, so as t tends to infinity, what is y? This is what they are asking you in that question. Okay, so this is a differential equation and it's a Leibniz linear equation. Okay, so this is a Leibniz linear equation. If you calculate this, if you try to bring this into that form, you can see t by 4t square plus 1. This is the equation actually. Okay, now if this is the equation, then let's see. Yeah, better put 2 here, things would get simplified. 2 and 2. Okay, then let's see. Yeah, if you want to calculate integrating factor, this value is e power integral 8t by 4t square plus 1 dt. Okay, because e power integral pdx is what you have, so e power integral of that into dt. So ME में इस टॉपिक से क्वेश्चन आया, अच्छा आया, उतना याद नहीं है, fine. Let's see. So let's see, because all, I think as far as I remember, mechanical में 9 questions आया था, so I have given key for all the 9 questions that day itself in that document. You all got a document, whoever is from mechanical or civil. Correspondingly, you might have, based on memory based questions, we have released their documents. Have you all got that? We have taken a lot of pain in generating that documents. Okay, because typing has to be done. We were working till night 2 AM 3 AM and all for getting you that documents. I hope all of you have got and checked those documents, right? Because after, as soon as exam gets finished, looking for the answer key is the main important thing that all of you do, and I think all of you got that documents, correct? In that mechanical we have 9 questions. I gave you answers for all the 9 questions. Okay, civil में थोड़ा सा I think a few questions were not yet. I think I have solved 5-6 questions in live that day in both slots and that. Okay, yeah, so let's see. Fine. Okay, so shall we continue? Good so far? मिल गया था ना, ठीक है. So let's solve these questions. So if you see, e power integration of this is nothing but ln 4t square plus 1, and this is nothing but 4t square plus 1, because e power logarithm gives you the same term. Okay, so e power log gives you this 4t square plus 1. Now let's see, solution is y times of integrating factor is equal to integral q into integrating factor again. Okay, so integrating factor is 4t square plus 1 dt plus constant actually. Okay, so then you can see these two terms gets cancelled and integration is t square plus constant. Okay, so y times of 4t square plus 1 is equal to t square plus constant. This is the equation. So if you put that boundary condition here at y equal to 1, t equal to 0, so c becomes minus 1 actually. So this will be the solution. Okay, so t square minus 1 will be the solution. So your y is going to be t square minus 1 by 4t square plus 1 actually in this case. Okay, so when you put limit t tends to infinity, when you put t tends to infinity, these two powers are same. In yesterday's class I was talking in limits. So this implies limit time tends to infinity, at infinite time this y value will get stabilized to a value of 1 by 4, which is 0.25. Okay, so that's what. Clear? Yeah, 1 by 4 basically 0.25 is the answer. So in this way, this is the basic technique to solve all the Leibniz linear equations. Okay, so हमारे पास जो नॉन linear equations होता है उसको भी हम Leibniz linear equation form में shift करते हैं. Okay, so let's see, I'll talk about one equation which you can see, converting non-linear to linear. This is also a bit important. Converting non-linear to linear. Okay, so if you convert non-linear to linear, like the first case, Bernoulli's equation. Bernoulli's is not, of course the person is same, but the equation is not the same what we see in fluid mechanics. Bernoulli's equation, you have dy by dx plus p into y is equal to q into y power n actually. Okay, so let's say this is the equation. So clearly n is not equal to 1, because if n equal to 1, this can be straight away solved. It's a variable separable form, of course. Okay, so for n, if n is equal to 1, then definitely things are very easy. If n equal to 1, dy by dx plus p minus q times of y is equal to 0, then you can just convert this to variable separable form. But let's say if n is some 2, 3 things like that, okay, then clearly this equation is non-linear. Then let's see what we can do. Y power minus n into dy by dx plus p into y power 1 minus n is equal to q. Yes or no? This is what we will get. Now what we'll do is, we'll make one substitution. Let y to the power 1 minus n is equal to z. If you differentiate this, 1 minus n, y power minus n, dy by dx is equal to dz by dx actually. Okay, so I hope you understood. Now why I should say n not equal to 1, we'll put n not equal to 1, of course, in this case. If n equal to 1, just you shift it here, it will turn to variable separable. So if n is not equal to 1, then this can be written as 1 by 1 minus n into dz by dx, of course. Okay, and when n is some number, this is just a constant, that's it. Okay, so this is just a constant. I can replace this complete combination which is here with this dz by dx. So the equation turns out to be minus 1 by 1 minus n times dz by dx plus, now you see this y power 1 minus n can be written as z plus p is a function of x into z is equal to q. Now you can clearly see this is just a number. Okay, so this is some constant value. So this is again in Leibniz linear form. Leibniz linear form actually. Okay, so this is in Leibniz linear form. So whenever things are non-linear, you can just make them linear by making simple substitutions. Clear to all of you? Yes or no? So type in the chat box, is this clear to all of you? This is one standard example which is given, because people feel that they don't have non-linear in the syllabus, but when they see non-linear, they'll get confused and they start getting panicked. Okay, but that need not be there, because you can just, by making simple substitutions, you can convert non-linear to linear equations. Okay, got it? Clear to all of you? Just a minute, let me have some water and get back. Yes or no? Is this clear to each and everyone? Please type in the chat box. Multiply with 1 minus n. Yeah, if you want, you can multiply with 1 minus n also. That doesn't make any difference, because that's just a constant. Okay. Clear? So I will have some questions on this. Yeah. Okay. So let's see. Okay, if you want for happiness, you can, as you told, you multiply 1 minus n to this equation. That's it. Okay. On both sides, you can multiply 1 minus n. Then definitely on this side, this 1 minus n gets eliminated. You have 1 minus n, a p term, and also the qth term. Okay. So all this is basic stuff which you have seen in mechanical syllabus also. We have done a lot of questions and all based on this. You want me to solve some example? This is the example. Okay. So you can see I have just solved an example for that. Then, so we'll move to higher order equations. Higher order equations. Higher order equations. Okay. So what is this higher order equations? Let's see. The equations of the form generally p naught x, this n minus 1th derivative, maybe this. Okay, so Pn of x, let's say, is equal to q of x actually. Okay, so this is the equation, the generalized higher order equation, and of course it's linear equation. Okay, so this is linear higher order. This equation is linear because you can see we don't have any multiplication of derivatives or higher powers of derivatives. Okay, I don't have the terms like dy by dx whole square, things like that. Okay, so this is a linear differential equation. Now practically, to get the general solution of this equation, it's not possible. Okay, like even till today there is no technique which you can like they'll give you some formula so that you can just apply and get the equation. Okay, but one important thing here is, if of course even if you divide completely with p naught of x, let's say this is the equation. Okay, because even if you divide with p naught of x, then p1 of x by p naught of x will be some other function of x again. So this is the equation. If p1 of x, p2 of x, and so on, pn of x are constants, let's say are constants for example. So let's say k1, k2, k3, things like that. Okay, so if these are constants, then we have got certain techniques to calculate the solution of this differential equation. Okay, so if these are constants, okay, so constant coefficients, then maybe say this implies plus maybe some constant k1 times n minus 1th derivative and so on, kn on y is equal to q of x actually. Okay, then you know basically if you want to, this is a non-homogeneous equation. See, the definition for homogeneity and non-homogeneity in first order and higher order is something different. Okay, first order equations mein agar dy by dx is equal to f of x comma y by g of x comma y, if those are two functions, then वो फर्स्ट ऑर्डर इक्वेशन होमोजेनियस होने के लिए ये दोनों फंक्शंस f of x comma y and g of x comma y they should be homogeneous of same degree. लेकिन यहाँ homogeneous होना है तो this q of x has to be 0. Okay, you should have terms only involving y. This q of x has to be 0 if you want to call it as homogeneous. Okay, so we'll call this as homogeneous if q of x is equal to 0. Now how do we write the solution of this differential equation? That's the main story. So the solution of this differential equation is split into two parts. Solution y is equal to yc plus yp actually. Okay, so yc plus yp is the solution. Yc is called the complementary function, which is basically the solution of homogeneous equation. Means this is the actual equation which I have to solve, but if I make this q of x is equal to 0, then this is a homogeneous equation. This yc is the solution of this homogeneous equation actually. Okay, and also this yp is basically the equation of this differential operator on this function. So if you add these two, you'll get the total solution. Okay, so this yc is called complementary function. Yc is called complementary function, and this yp is called particular integral. Okay, now we'll see how to calculate the roots, how to calculate the solutions. Do you all know how to calculate this yc and yp? Yes, if you all know, then I won't get into much details, but normally forming auxiliary equation, then solving. Okay, is that clear? Like all of you know how to do this? Let's say for example, if I given you d square y by dx square minus 5 times of dy by dx plus 6y is equal to some function, then how to get the solution of that function? If you know, then I can just skip it for you. Otherwise, I'll take some time and discuss it. Come on, type in the chat box. What shall we do? Shall we discuss or shall we skip? You all know how to do this. Skip or discuss? Everyone who is on live, please type in the chat box. Yes means like, can I skip? You might have done in mechanical, no? All of you might have done in skip it, right? Yeah, I'll skip it because majority of you might have done in mechanical. Like if you have this linear equation, then generate the auxiliary equation. Discuss briefly, sir. Okay, discuss, sir. Kari to ek bar. Fine, I'll discuss then. Okay, so see here, I'll just talk about this. If you have just a minute, sorry. Yeah, if you have this equation, for example, we generate something called auxiliary equation. Auxiliary equation. So this equation is nothing but m power n plus k1 m power n minus 1 plus k2 m power n minus 2. This complete thing kn is equal to 0. This is the auxiliary equation. Basically this equation can be written as, so if you see this equation can be written as, if I call this operator d is the differential operator, for example, d is actually a derivative, d is the differential operator. If I put d square, then it's a second order derivative. Okay, in general I would like to write Okay, so this. Now let's see, this equation can be written as d power n plus k1 d power n minus 1 plus and so on kn operating on y is equal to q of x. Okay, so auxiliary equation is basically equating this part to 0 because we are yc is actually the solution of only the homogeneous equation. Okay, so if yc is the solution of homogeneous equation, there is no q of x. Okay, so if you put this as, of course this is equal to q of x actually. For yp, for calculating yc, yc is the solution of the homogeneous equation. If q of x is equal to 0, that means this operator should also have a 0 when you operate on y. Okay, so that actually gives you this function. Now it's a polynomial equation, you can just solve and you will get roots. Like for example, I'll show you example. If you have d cube y by dx cube minus 6 d square y by dx square plus 11 dy by dx minus 5 plus 11, so minus 6y is equal to some 0. Let's say if you have this equation, this equation implies d cube minus 6 d square plus 11 d minus 6 operating on y is equal to 0 actually. And if you work out with the auxiliary equations, let's see what you have. Auxiliary equations gives you m cube minus 6m square plus 11m minus 6 is equal to 0. So if you solve this, you will get the roots as 1, 2 and 3 of course. Okay, so normally this is the equation which has the roots 1, 2 and 3. So depending on the nature of the roots, we write the complex we actually write the complementary functions actually. Okay, so let's see, because this again I'll use in some portions later when I'm discussing the Wronskian method. So you can see, if this is the equation, like if you solve the equation, if the roots are real, okay, so if m is equal to alpha comma beta, for example, let's say you're talking second order equations. So if you have these roots, okay, then yc is equal to c1 e power alpha x plus c2 e to the power beta x actually. Okay, so this is the case, c1 e power alpha x plus c2 e power beta x. And if you have this repetition of roots alpha beta alpha beta, then your yc is equal to, let's say if a real root is getting repeated, then we write c1x plus c2 e power alpha x plus c3x plus c4 e power beta x actually here. Okay, so that's beta x. Then let's see, if you have, for example, complex roots, okay, if you have alpha plus I beta and alpha minus I beta actually, okay, then you will end up with yc is equal to c1 cos e power alpha x into c1 cos x cos beta x, c1 cos beta x plus c2 sin beta x actually here. Okay, basically if you see, this is not a special format to remember, this is same as this actually. Okay, I'll just show you by taking a minute. You can understand c1 e power alpha plus I beta into x plus c2 e power alpha minus I beta into x. This is what you want me to write actually, yes or no? Because if m1 and m2 are the roots, c1 e power m1x plus c2 e power m2x is what I am supposed to write. Okay, many people feel that this is just a separate formula and you have to mug up all these things. No, actually you need not mug up. The only thing you have to remember is y is equal to c1. Let's say for example, if this equation has n roots, okay, c1 e power m1x plus c2 e power m2x and so on, cn e power mnx. That's all. This is what you have to write. Okay, it doesn't matter the roots are real, imaginary, or what do you say, irrational, nothing happens. Okay, basically this is what you have. If you simplify this, then tell me what you will get. E power function can be split up at this points. Okay, it can be written as e power alpha x into e power I beta x. Okay, similarly here this can be split up as alpha x into e power minus I beta x. Okay, then if you take e power alpha x common, you will have c1 times e power I beta x, so cos beta x plus I sin beta x. Okay, this is what we have, plus c2 into e power alpha x is already taken out, we have cos beta x minus I sin beta x. Okay, so this is what we get actually. Okay, you have e power alpha x into c1 cos beta x plus c2 sin beta x. Sorry, I is not there, so e power, yeah, I is there of course. Okay, e power ix is equal to e power I alpha is equal to cos alpha plus I sin alpha. Then you can observe this c1 plus c2 is actually e power alpha x into, for cos beta x, c1 plus c2 could be some other constant. Let's say for example c3, okay, cos beta x plus C1 into I is some constant, C2 into I is again some constant. So this constant summation is written as some other constant, sin beta x. That's all. That's how you basically have this. Of course, without doing this directly, we'll generally replace cos beta x and sin beta x. Similarly, if you have irrational roots, alpha plus root beta, alpha minus root beta, these things, when you split this, you will try to get hyperbolic functions. Okay, because cos hx is e power x plus e power minus x by 2, and sin hyperbolic x is e power x minus x by 2. So depending on that, we can actually generate all these results. Okay, and if a root is getting repeated, then you will see x can be getting as multiplication. Okay, clear to all of you? Yes or no? So basically this is the complementary function part actually. Okay, so if you know this, then whatever the roots are, maybe imaginary, real, irrational. Okay, so you can always write this. Okay, yeah, fine. Yes or no? Clear to all? Please type in the chat box. All of you are busy in writing notes. Anyhow, I'll upload the PDF now. Today I have uploaded. Immediately after the lecture, I'll upload this in Telegram channel, no issue. So clear? So basically this is the way to generate this YC. What is this YC? Is depend on this. Okay. Now let's see writing particular integrals. Pi. So particular integrals is basically you have yp is equal to, let's say if I were, for example, your differential equation is some function of d operating on y is equal to q of x. Okay, then your yp is 1 by f of d operating on q of x actually here. Okay, now depending on this q of x, we have certain results again. Okay, so we have certain results like the first case. Okay, so it's clear. So the first case is if q of x is equal to e power mx, or m I won't use because again you'll get confused, maybe e power ax actually. This implies yp is equal to 1 by f of a into e power ax. That's it. Okay, if f of a not equal to 0, then this value is implies yp is equal to, if f of a is equal to 0, for example. Okay, so let's say for example if f of a is 0, then in this, let's say for example if I give you this expression d square y by dx square plus minus 5 dy by dx plus 6y is equal to e power 2x, for example. Okay, so let's say if I give you e power 2x. Okay, now when I give e power 2x, what you get is, if you do this calculation, okay, so complementary function is anyhow clear, e power 2x plus c2 e power 3x. Okay, this is known to you because the auxiliary equation is m square minus 5m plus 6, so m equal to 2 comma 3 is what you have here. Okay, fine. So this is what you have, c1 e power 2x plus c2 e power 3x actually here. So if this is yp, and let's say if your a is a sitting on the top of e is in such a way, this is actually one of the root, means here whatever is there, that's one of the root of this auxiliary equation. Then the technique is x into 1 by f dash of a into e power ax. This is what you have the technique. Normally from L'Hospital rule you can generate this. So let's see c1 e power 2x plus c2 sorry, c2 e power 3x actually. Okay, so yp is equal to 1 by d square minus 5d plus 6 operating on e power 2x. Now clearly when you put 2, this turns out to be 0, so we have x into 1 by 2d minus 5 is the derivative of this function with respect to d, e power 2x. So again here you have exponential, so if you put 2 here, this turns out to be minus 1, so e power 2x by minus 1. So this function is minus x into e power 2x actually. So that's the particular integral of this case, and it goes on. Okay, if this f dash of a is also 0, we have x square into 1 by f double dash of a into e power ax again. Okay, so like that we have the things. Clear? Rohit, is this clear to all of you? Did you understand this? Okay, now let's see if the function is sine function. If f of x is equal to sine of ax plus b, maybe, or cos ax plus b. The procedure is same for both the cases, cos ax plus b actually. Okay, so when you have this cos ax plus b, of course calculating complementary function is same, but particular integral calculation when you have y by f of d. Okay, let's not write this q of x, p f of x, maybe q of x. Okay, q of x. Okay, so let's see, if q of x is equal to this, then f of d operating on sine ax plus b actually. Okay, so this is sine ax plus b. Now how do we get the particular integral in this case? Replace d square by minus a square. Okay guys, here one mistake that people commit is, this is not minus a whole square. Okay, if that is minus a whole square, I would have written just as a square. Okay, but it's minus of a square. Clear? Now if you replace this, let's see for example and simplify. Like for example, let me give you some hint. Like let's see, if you have this equation, d square y by dx square plus, or maybe 5 times of dy by dx, let's say 5 times of dy by dx plus 5 times of dy by dx plus 6y is equal to sine 2x plus 3. Let's take any simple values. So sine 2x plus 3. So complementary function is pretty much easy. c1 e power 2x plus c3 e power 2x, c2 e power 3x actually. Okay, so then coming to particular integral, 1 by d square minus 5d plus 6 operating on sine 2x plus 3 actually. Okay, so when you have this sine 2x plus 3, first of all the thing that you have to do is replace this d square with minus a square. Okay, so जो d square है, so उसको minus a square से replace करना पड़ेगा. So d square is to be replaced with minus 2 square, which is minus 4. So if you keep d square is equal to minus 4 in this, 1 by minus 4 minus 5d plus 6 operating on sine 2x plus 3. So once you have this, 1 by 2 minus 5d sine 2x plus 3. Okay, so this is what you get. Now how do you get this function? Let's see. You can do rationalization. If you do rationalization, you have 2 plus 5d divided by 4 minus 25d square. This is what you can write. Yes or no? Because if you multiply 2 plus 5d and 2 plus 5d on numerator and denominator, you will end up with this. So again, replace, whenever you see d square, you put that with minus a square, then this turns out to be 2 plus 5d divided by 4 minus 25 of minus 4 sine 2x plus 3. So this value now in the denominator, there is no more operations, it's just a constant. 25 times of 4 gives you 100. So this is 1 by 104 times of 2 operating on sine. 2 is just a multiplication. So 2 sine 2x plus 3 plus 5 times of d sine 2x plus 3. D is nothing but differential operator. So if you operate this sine 2x plus 3 using this d, it turns out to be cos 2x plus 3 into 2, because 2 is a differential, so in a differentiation of sine, so this becomes 10. That's all. Okay, so this is how you calculate the particular integral if you have a sine or cosine functions. Clear? Yes or no? So please type in the chat box. Yes or no? So please type in the chat box. Clear? So similarly, if you have different types of functions, again if you have polynomial functions, okay, x power m of that order, what you'll do, you'll use binomial expansions and you can simplify. You might have seen all these things. Okay, now let's go to the method of Wronskians. Before going for method of Wronskians, let's go to method of Wronskians first to understand certain things. Okay, after method of Wronskians, the complete mechanical and XC common surface part will be completed. Then we will eventually move on to solving these questions. Okay, because it's a Euler-Cauchy equations and all, they are there. So we will move there, but before that we have to finish off the basic things. Method of variation of parameters. Okay, since this is not a detailed course, I'm just giving the complete idea on how to solve the questions. Otherwise we would have got some intuitive things and all. So one time explain how constant a is equal to, sorry, didn't get this. One time explain how constant a is equal to d. Where? In which step constant a is equal to d? I didn't get you. D square has to be replaced with minus a square. Okay, that's what. Clear? Any issue at this point? It's correct, right? Yeah. Explain how constant a is equal to d. Where constant a? A is not equal to d actually. Okay, so please don't get confused. A is a real number. Yeah, we have just replaced it. Okay, a is basically a real number and d is the operator actually. Okay, so basically if you follow the solving procedure, that happens because of this d square is equal to minus a square actually. Okay, Why this happens and all, normally using 𝐂𝐚𝐿 and all we can check it, okay, which we are not doing it now because it's just a revision kind of thing. So I'm just showing you this. Okay, yeah, I hope that's clear. Okay, yeah, so let's see what is this 𝐂𝐚𝐿. Now when you have these equations, like see d square y by dx square plus maybe some constant, actually p of x into dy by dx plus q of x into y is equal to maybe some r of x actually. Okay, so when you have these kind of functions, okay, so when you have these kind of functions, actually we actually, as I told you, you cannot solve this solution directly, but under, you know, somehow if you got the solution, okay, let complementary function is equal to c1 y1 plus c2 y2. This is c1 basically y1 of x, like for example e power 2x plus c2 e power 3x, like that we have got some solutions now. So this is some function of x and this is some other function of x actually, and these two are linearly independent functions. Okay, means for example you cannot express y2 as linear combination of y1. Okay, y1 and y2 are linearly independent. Okay, independent, clear? Y1 and y2 are linearly independent. Now you can understand Wronskian is actually defined by y1 y1 dash y2 y2 dash, of course. Okay, so this is basically again some function of x, so this is given by the determinant actually. Okay, so Wronskian is actually given by this function, and the solution to the dE, to that differential equation, solution is y is equal to minus y1 integral y2 into r of x divided by Wronskian dx plus y2 times integral y1 into r of x by Wronskian dx. Okay, so by Wronskian dx actually. Okay, so this y1 into r of x divided by w dx. Busy to write notes. Okay, so see, so anyway this is the solution. See, basically you cannot always get this c1 y1 and c2 y2 very easily for this. Even if you make the r of x 0, this c1 y1 and c2 y2 are not directly solvable actually. Okay, so if they give you one solution, you can generate the other by substituting, but normally in our case, in our gate examination syllabus and all, we have only p of x and q of x as constants. Okay, so that the job is easy for us. So this is a solution actually using Wronskians, where w is given by this. This is called Wronskian of y1 and y2 actually. Okay, so let's see, we got some questions to solve on this. So basically this is how you solve the equations. Okay, so let's see the questions now. So let us solve this question now. Okay, this is Euler-Cauchy again, so I think we have to move a little forward. Fine, I think I have kept majority of the Euler-Cauchy questions, but anyway, so solve this question. Okay, before solving, I would like to give you one type of equations actually. So this is the Wronskian actually, where we'll actually get the solution for this equations. Okay, I would like to show you using an example. We have solved an example now. D square y by dx square minus 5 times of dy by dx plus 6 times of y is equal to, what is the constant, what is the function I have taken here? This is e power 2x. Okay, so we got this. So here the solution is y is equal to c1 e power 2x plus c2 e power 3x minus x into e power 2x. This is the solution actually. Okay, so this is actually the solution. Let's apply the method of variation of parameters and let's see whether we get the same solution or not. Okay, so let us see here, is equal to e power 2x is what I have taken. Okay, is equal to e power 2x. Now let's see, your complementary function is c1 e power 2x plus c2 e power 3x. This is known to you, no issues. Okay, now you can take one of these two as y1 and another as y2. So let's say for example this I am taking as y1 and this I am taking as y2. Even if you want, you can take y2 and y1 in the in other sense. Okay, now let's see, Wronskian w is equal to y1 into y1 dash x1, this is not into, just a row, and second function into derivative of second function. Okay, now if you calculate these functions, e power 2x into e power 3x, e power 5x, 3 times of e power 5x minus 2 times of e power 5x. So you have total e power 5x. The reason why I told you that these two functions y1 and y2 are linearly independent is because if they are linearly dependent, then definitely this row and this row will be proportional to each other. Okay, so this should not be linearly dependent, because if they are linearly dependent, then these two rows of the matrix will become of the determinant will become proportional, and Wronskian value goes to 0. Then you cannot do divisions with 0. Finally, you cannot evaluate the solutions. Okay, so since Wronskian concept is defined on determinant, so that determinant should not be equal to 0, which means these two rows has to be linearly independent, which means undoubtedly these two functions has to be linearly independent. Clear? Yes or no? Type it in the chat box. Clear? Yeah. So now let's see if this is the Wronskian. So what is solution now? Solution is y is equal to minus y1. Now you have to follow a caution here. If for example you take this as y1, you should use the same y1 because you have calculated Wronskian by taking this as y1. Okay, so minus y1 into e power integral y2 into r of x divided by Wronskian dx plus y2 integral y1 into Wronskian divided by e power 5x dx. Okay, so this is the solution actually. Okay, so if you see this, then clearly this e power 5x, no, Wronskian is e power 5x, sorry, so this is 5x. Then clearly this e power 5x and e power 5x gets cancelled. This actually ends up with a e power minus x actually here. Okay, so if you solve this, y is equal to yp actually. Okay, so this is yp of course. So I think I have given a solution is yp. Okay, so this is yp. yc plus yp gives you the answer. Okay, so yp is equal to minus e power 2x minus e power 2x integration of 1 dx is x plus e power 3x into integration of e power minus x. E power minus x by minus 1 is what you have. So this gives you minus x e power 2x minus e power minus x and e power 3x. If you simplify, this gives you e power 2x. Okay, so minus e power 2x is what you have. This equation is the particular integral. You may feel that here the particular integral is something different, here the particular integral is something different, it's minus x e power x. But if you take the total solution of the differential equation, okay, that is constant, that is same, because see, therefore y is equal to c1 e power 2x plus c2 e power 3x plus you have the particular integral is minus x e power 2x minus e power 2x. Okay, so this is what we have. Now can I tell one thing? This is c1 e power 2x, this is minus 1 e power 2x. So c1 minus 1 times e power 2x plus c2 e power 3x minus x e power 2x actually. Okay, and if c1 is arbitrary constant, then definitely this c1 minus 1 is also some arbitrary constant, which is maybe c1 dash you can say. So this solution is same as the previous solution. Clear? So that's why. And here you have the standard technique. Okay, it can be sine function, cosine function, whatever, you're always supposed to use this technique. So therefore no need to mug up individual ways of solving the question actually. Okay, so this is the Wronskian, and normally from this concept of Wronskian and determinants you will actually get this replacements, this derivatives, all these things. Okay, so anyway, this I'm confining as of now. Clear? Did you all understand how to work out the Wronskian method of various parameters to solve the higher order differential equations? Okay, this method can even be used for solving even when these are functions of x, but when these are functions of x, the problem is we cannot generate y1 and y2 more generally. So that's why in our case of gate syllabus we have only for the constant syllabus, constant coefficients case. Okay, yes or no? Type in the chat box. Clear? Fine. Okay, yes or no? Is it clear or not? So please type in the chat box. Yes. So let's see one last thing before we go for the special topics actually. Okay, solving these equations. Okay, Euler-Cauchy equations. Euler-Cauchy equations. Okay, so this is just move to slide you have written. Just move to slide you have written. I'm not noting. Acha, you're noting. I felt like nothing. This is what. Just applied this method of variation to this one. That's all. Okay, nothing big. Fine. So let's see this Euler-Cauchy equations. Basically, you cannot directly solve functions, but you can actually convert them to constant coefficient functions if you use this. Okay, so if you see, the equation is of the form x power n into nth derivative plus k1 x power n minus 1 into n minus 1th derivative. Guys, please don't cancel this x power minus 1 and this x power minus 1. Okay, this is, it denotes its nth derivative. Okay, like for example n minus 1th derivative, this denotes the multiplication. Okay, plus k2 times x power n minus 2 kn on y is equal to maybe some function of x again. Okay, so q of x, let's say. So this is q of x. So normally I told you, when you have the coefficients as powers of x, or basically if you have done it, yeah. So if you see, normally I told you when you have functions of x directly here, you cannot solve the equation. Okay, but now if you still have these functions in this special form, then you can actually solve this by making the substitution. Let x is equal to e power z actually. Okay, or z is equal to log x to the base e. So we define a differential operator d is equal to d by dz. Okay, so d is equal to d by dz actually. So that's the differential operator that we get, and this gives you x into d by dx is nothing but d by dz, which is actually d is what you get. Okay, similarly if you have x square d square by dx square, this actually gives you d times of d minus 1 actually. Okay, so it can be adjusted to d square minus d, where d is this differential operator which is derivative with respect to z, of course. Okay, so like this, if you can see x cube d cube by dx cube, if you see, this turns out to be d minus 1 into d minus 2, of course. Okay, so this is how basically you can get. See here I can write this as x into d by dx into x into d by dx of e power z. So if you take z is this function x is equal to e power z, and if you start differentiating, because if I want to differentiate x equal to e power z, I can write this as dx by dz is equal to e power z, of course. Okay, and if I have to write y, I can also write this as dy by dx into, or if I have dy by dx, for example. Okay, if I have dy by dx, I can write this as dy by dz into dz by dx. Okay, and if z is equal to log x, this dz by dx gives you 1 by x actually. Okay, so this gives you 1 by x. Clear? So if you shift this x here, this term comes out to be x into dy by dx is equal to dy by dz. Normally if you take this as operators, then this x into d by dx operation is same as this d by dz operation. That's why this gets converted to capital D actually. Okay, similarly you can work out for these things as well. So if you work out, if you go for the higher order derivatives, you'll see d into d minus 1, d into d minus 1 into d minus 2. So this loop actually goes on. Okay, so I hope you have understood this. I'm just erasing. Okay, now let's see, if you have this equation for example, then once you replace these terms in this equation, this x power n into d power n minus 1 into y plus k1 something, if you see, you will finally end up with some function of d operating on y is equal to q of x actually. So that will be some function in terms of r of z. Like for example, you say here you have x square plus 2x. Okay, this x square plus 2x can be written as e power 2z plus e power z. Okay, so that's how we can write. So r of z. Now this equation is again the standard with constant coefficients. Okay, dE of higher order in x and z with constant coefficients. With constant coefficients actually. Clear? Fine, guys. I want to just tell you one thing, guys. don't feel that majority of your friends are not in this video and all these things, okay? Because just stay focused, and if you are getting rank, only it's your rank, okay? So definitely after writing the exam in the next 4 or 5 days when people write the exam, I'm promising one thing, definitely you will feel some difference between people who are not attending the sessions and you, okay? Pakka. You yourself will feel it, okay? Definitely you will feel at few points you have heard them in last 3-4 days and you will apply them correctly. Clear? So get 30 marks में IIT या NIT मिल जाएगा, depends on category also, but I think 30 is not very comfortable score to be honest, but better IN you can work out with 𝐂𝐸, and after that many PSUs which are not equating to get, okay? So just keep your preparation, okay? Your preparation, see, I'm telling you, don't be exam specific. Let's say for example if your GATE exam didn't go fine, okay, then what will you do? Will you wait for next year GATE exam? No, no, because एक साल में बहुत सारे PSUs equipment करते हैं, okay, and majority of the equipment is based on non-GATE also, okay? Like for example जब मैंने BARC exam clear किया था, मैंने separate exam से ही clear किया, okay? So that's why I'm telling you, don't be depressed or something. Preparation is a process, okay? So once you start preparing, then definitely as you keep moving, okay, in the 6-7 months, if your efforts are sincere, you will land up in some PSU or something like that, okay? X score 544 क्या मिल गया last year? क्या मिलेगा sir last year? Last year I think 544 पे I think some very new IITs में some interdisciplinary branches I think they got at last, okay? MTech Dharmal in IITM versus IISc, which is better, sir, in my point of view. If you ask me, if you have very strong and tough mathematical background, IISc, undoubtedly. Okay? Yeah. I'll tell you the reason why it happens. Normally in IITs, the core courses for MTech students, okay? Like let's say for example, if I got admitted to MTech IIT Madras, okay, in the first semester. In the first semester, what are the compulsory courses that I have? These courses are also electives for final year BTech students, okay, final year or 5th year dual degree students. These are the same courses. So basically the course curriculum is designed in such a way that even the final year undergrads or the first year grads can actually take it, okay? But if you go to IISc, in IISc you don't have undergraduation for engineering streams at least, okay? So the curriculum which is designed is exclusively for master level and beyond that. So definitely you'll have to have certain mathematical rigor with you, then you can do the things, okay? So XC में कौन से topics करवाएंगे आप? I'll give the list, okay? Basically we'll talk about the list at the end of the class, okay? So at the end of the class I'll give you the list of topics because I cannot cover complete FM, like it will be like completing complete maths here in this case. So complete FM we cannot cover, but we'll put emphasis on those topics where questions are being asked frequently and also this extra syllabus. So do we have applied computational mechanics course other than IIT Madras? Yeah, you have in IIT Delhi, I guess. Bombay don't have exact department, but yeah, Madras computational mechanics is very good actually, okay? It has 3 specializations, solid, fluid and biomechanics, which have very good placement record, and also like they have good placement record, and also the connections they have across the globe is vast, okay? Chalo. So you got this, so this can be solvable because you know the techniques to solve these type of equations. So finally you will end up with y is equal to some function of z, put z is equal to log x, you can understand that. Like master specific in CFD course in IITs or NITs with MTech. CFD, like if you are into thermal, in every project you will end up with CFD, okay? You have to do a lot of CFD, computational fluid dynamics. After certain things, things go beyond your hand, so you need a machine to solve. That's what you call CFD, okay? Computational fluid dynamics. The same fluid dynamics you'll do with computers, but of course in a much mathematically rigorous way. That's CFD, okay? So chalo, let's solve this question. So let's go to the first question of today's class. The general solution of the differential equation x cube d cube y by dx cube plus x square d square y by dx square plus x into dy by dx minus y is equal to 0, x more than 0, okay? X is greater than 0 is dash. So I'm conducting a poll actually, and I'll also give you some time, single choice, maybe 150 seconds I'll give you. So solve this question. It's an Euler-Cauchy equation, so please solve this. This is also a previous x equation, so please solve everyone. I'm moving aside, you can see the options, okay? the general solution of this differential equation, x cube d cube y by dx cube plus x square d square y by dx square plus x into dy by dx minus y is equal to 0. Without get xc IITs नहीं मिल सकता है sir. Why not? The normally your mechanical score can be used na to get your mechanical admissions. See, I'm telling you, just people, I don't say the word hype, but you know, people just create certain fear in aspirants, okay, but that's not be there. Clear? See, just see, I'll tell you one important thing. Let us solve this question, then I'll tell you one thing. Chalo, the time is getting up fast. B is the correct answer. Okay, maybe only first answer will be considered. Okay, fine. Okay, so poll ended. Let's solve this question. Okay, I'll try to solve this question. How to eliminate silly mistakes. Memo is good, but due to silly mistakes I made around 7.2 marks wrong. Okay, we'll see. Iron, no issue. 72 marks wrong. Okay, fine. Oh my god, fine. Anyway, let's see. B is the correct answer. Okay, let's work it out. If you want to solve this, I'll tell you some small story after this question. Okay, because I know for 2 hours, almost like 7:48, so 7:50, almost for 2 hours we are continuously, you know, discussing the concepts. But anyway, we'll take some time and yeah. So let's see. You have this general solution of the differential equation. Okay, so x cube d cube y by dx cube. So this is an Euler-Cauchy plus x dy by dx minus y is equal to 0. So if you make this substitution, x is equal to e power z, and if you take the differential operator as d by dz, of course, this equation turns out like d into d minus 1 into d minus 2 plus d into d minus 1 plus d minus 1 operating on y is equal to 0 actually. Okay, so if you want to solve this equation, for example, if I take d into d minus 1 common in these two terms, you have d minus 2 plus 1, which is d minus 1. So this gives you d into d minus 1 whole square plus d minus 1 operating on y is equal to 0, of course. Okay, so if you take d common, then d square plus 2d minus d square minus 2d plus 1, that plus 1 and minus 1 gets cancelled in this equations. Okay, so if you take, for example, if you take d into d minus 1 common, then you have d minus 2 plus 1, so plus d minus 1 actually. So if you take d minus 1 out, okay, then we have d minus 1 out, then d into d minus 1, which is d square minus d plus 1 actually. Okay, instead of doing this, let us just, you have to simplify this. Okay, so what we'll do is, you take d common. So if you take d common, d square minus 2d plus 1 plus 1, so this is plus 2 actually. Okay, plus 2 minus 1 operating on y is equal to 0. So this equation turns out to be d cube minus 2d square, d cube minus 2d square plus 2d minus 1 operating on y is equal to 0. Okay, so this is the equation. Now clearly, if you form the auxiliary equation for this, you will end up with the auxiliary equation. Auxiliary equation is something like m cube minus 2m square plus 2m minus 1 is equal to 0 actually. Okay, now if you just go one step forward here, you can see something like d minus 1 if you take common, okay, so which means m minus 1 you can take common here. So if you take m minus 1 common from this term, then you have m into m minus 1 plus 1, m into m minus 1 plus 1 actually is equal to 0. So m is equal to 1, then this is m square, m is equal to minus b plus or minus root of b square minus 4ac by 2a. So this gives you 1 by 2 plus or minus I root 3 by 2. Okay, so these are the roots. So basically m is equal to 1, m is equal to half plus or minus I times of root 3 2 by 2. These are the solutions actually. Okay, so if these are the solutions, then you have your y is equal to c1 e power z, sorry, c1 into e power alpha x. Okay, so e power z actually plus, now this is imaginary parts, so e power z by 2, e power z by 2 into c1 cos root 3 by 2 z plus c2 sin root 3 by 2 z actually. Okay, c2 sin root 3 by 2 z is what you have. Okay, so c2 sin root 3 by 2 z actually. Now you know e power z is equal to x and z is equal to ln x. Now this solution, if you want to replace in terms of x, your solution is going to be c1 e power z is x plus e power z by 2. This can be written as e power z whole power 1 by 2. Then this can be written as e power x by e power z. So this can be written as square root of x actually. Okay, so square root of x, of course, because e power z, if I use both sides to the power 1 by 2, this becomes square root of x actually. X into c1 cos root 3 by 2 ln x plus c2 sin root 3 by 2 ln x actually. Okay, so this is the solution, that's all. Clear? So that's the solution of this differential equation. Clear? So c1x plus square root of x, c1x, so c1 e power x is wrong first of all. So c1x plus x power minus 1 by 2 is also wrong. Okay, because there is no minus sign actually in that. So x is equal to root x. So this is the correct option, x power 1 by 2 into c2 cos root 3 by 2 log x root 3 by 2 ln x. Okay, this is c1. So let's make this c2 and c3, because c1 we have already used here. So maybe c2 and c3 you can use. So c2 and c3. So c2 cos root 3 by 2 ln x plus c3 sin root 3 by 2 log x. You can see this is the solution, correct answer of this equation. Yeah, did you understand? Hi Vijay. So did you understand how to solve this Euler-Cauchy equations basically? So once you substitute this x is equal to e power z, and if you operate the differentials, then your equation turns to higher order equations with constant coefficients. Okay, and if you can solve this basically using our classical techniques, then you will get things in terms of z, then you replace z back as log x, then you will end up with the function in terms of y and x actually here. Clear to all? Yes. Now let's go to the next question. So please solve this question, Ronskian question. I'm setting up the poll again. Okay, so where is the poll, by the way? We have set up the poll, right? Yeah, the poll should be somewhere here. For previous question it's D. Let's see how many of you have done it correct. Oh, so one of you has plotted B actually. Fine, it's okay. So I'm creating one more poll actually. So integer type. So what is the question? They have given you again some Euler-Cauchy equation, but this time it's only of second order. So W y1 y2 denotes the Wronskian at x. If y1 the Wronskian of y1 comma y2 of 1 is equal to 1, then Wronskian of y1 y2 of 2 is equal to dash. Okay, so let's see. I would give you 2 minutes, okay, to solve this. Come on, enter the answer. faster. So fine, you please finish it off. Meanwhile, I'll try to solve this. So clearly, you can write this x square into d square y by dx square as d into d minus 1 minus 2 times of d plus 2 operating on y is equal to 0. So if you simplify this, d square minus d minus 2d, so minus 3d plus 2 operating on y is equal to 0. So if you write the solution, y is equal to c1, this is z square, sorry, not z square actually, so d is equal to m square minus 3m plus 1, so m is equal to 2, so c1 e power 2z plus c2 e power 3z actually, okay. So which implies e power z is equal to x, so c1 x square plus c2 x cube actually here, okay. So c1 x square plus c2 x cube actually, okay. So let's see, in this case, if you take this functions, okay, c1 x square and of course c2 x cube actually. Now the solutions y1 of x and y2 of x are such that this x square and x cube are the functions. So let's say y1 of x is equal to x square and y2 of x is equal to x cube actually, clear. So if this is x cube, then we can write Wronskian is equal to x square x cube 2x 3x square, okay. So this gives you 3x power 4 minus 2x power 4 gives you an x power 4. So this is the Wronskian, which depends only on this x power 4 actually, okay. So at x is equal to 1, okay. So at x is equal to 1, clearly this Wronskian value x power 4 is also 1, which is given actually, okay. So at x is equal to, how much they are asking? At x is equal to 2, okay. So at x is equal to 2, your Wronskian is equal to 2 power 4, which is 16 actually in this case, clear. So sorry, so this value is basically 16 in this case, okay. So 16 is the correct answer that we can have it, okay. So 16 is basically the correct answer. Oh, is it? How did you get 4? E power 2z and e power z is that we have? Let us see. Z minus 1 and z minus 2, correct. So we have e power z of course, okay. So here we get e to the power z, so that means x you have, so x and this derivative is 1 then in that case, so this is 1. So x square minus 2x square is actually x square, okay, maybe they have taken the modulus, because even if I can consider this as the first function, so x and x square I can take. So if I take x and x square, then this will change a minus sign. So anyway, this is modulus of my x power x square in this case. So this is x square, yeah, 4 is correct then of course. So if this is x square, then of course here it is the square, so this is 1 and 2 square is of course 4 in this case, yeah, because of this one it changed. So this is 2 square, which is equal to 4, yeah. So 4 is the correct answer, yes, because yeah, you can see roots on, yes, correct. Here it should be 1, okay. 2 comma 1 are the roots of this equation, so it should be only 1, so there should be only x actually. So this value is equal to 4, okay. So this is the Wronskian. Let's solve one more question. So please solve this. Let the transformation y of x is equal to e power x into v of x reduces the ordinary differential equation x into d square by dx square plus 2 times of 1 minus x dy by dx plus x minus 2 times of y where x greater than 0 to alpha x d square v by dx square. I think this is a second order derivative. X square is there here, okay. So x square should be, if square is not there, anyway, let's see, plus 2 times of 1 minus x into dy by dx plus x minus 2y is equal to 0 to this equation where alpha, beta, gamma are real constants. Then the arithmetic mean of alpha plus beta plus gamma is dash actually, okay. I have kept this question to tell you one important thing actually, okay. Should be in variable x, yeah, we have converted in terms of x only now, you see, c1x square plus c2x, okay, and Wronskian we have calculated only in terms of x, okay, Ashik. So let's see here in this case, if you solve this question, let's see, this is a question basically from 2021 as far as I remember, yeah, 2021 question, okay. In this question, normally if you simply solve this, it's a simple question actually. Y of x is equal to e power x into v of x, so this implies dy by dx is equal to e power x times of v dash plus v is what you will get, okay. V dash of x plus v is what you will get, and if you calculate d square y by dx square, you will end up with e power x times of v double dash plus v dash plus v dash plus v, so 2v dash plus v again into e power x. This is what you will get. Now if you replace these two quantities basically in this equation, like x into d square y by dx square I can replace with e power x times of v double dash plus 2v dash plus v, okay, plus 2 times of 1 minus x into dy by dx, which is e power x into v dash plus v plus x minus 2 times of y, x minus 2 times of y e power x into v is equal to 0. So if you simplify this, what they're telling you, if you simplify this equation, of course e power x can be eliminated all over, okay, e power x can be eliminated. So if e power x is actually eliminated, okay, then just what you'll get is something in terms of this format, okay. So you will have this format. So let's see, x times of v double dash plus 2 times of x and 2 times of 1 minus x, okay. So 2x plus 2 minus 2x, so you have 2 times v dash is what we have, then plus x into v plus 2 times of 1 minus x into v actually. So this gives you plus 2 minus x times v plus x minus 2 times of v, okay. Then this term actually gets cancelled, okay. So this term actually gets cancelled, plus 0 is equal to 0 actually, that's all, okay. Yeah, now they have given you this thing, of course. Now they have given you alpha, arithmetic mean of alpha, beta and gamma. So if you compare this equation with this equation, you will have something like this. Implies alpha is equal to 1 because you see alpha x d square v by dx square, you have x into v double dash, so the constant value here is 1. Now 2 beta dv by dx, so 2 times of v dash is there, so 2 beta is equal to 2, so 2 beta is equal to 2, so beta is equal to 1, and gamma is 0 because there is no term of v individually, okay. So alpha is 1, beta is 1, gamma is 0 actually. So if you take the arithmetic mean plus beta plus gamma by 3, okay, so this value divided by 3, which is 1 plus 0 divided by 3, which is 2/3, and many people have solved this question till here because it's an easy question. Straight away you just make the substitution, finally you'll get the answer 2/3. Now few people entered 0.67 in this case, okay. So 0.67 is what they have entered, because normally 2/3 when you round off to 2 decimals, they have entered 0.67. In this question it was asked round off to 3 decimal places, okay. So if you round off to 3 decimal places, this value should be actually written as 0.667, correct. So this is actually 0.667, and of course you see 0.67 is reasonably good if they don't ask about number of decimal places, okay. And question is very simple, just you substitute, don't take any calculation mistakes, you will end up with alpha 1, beta 1, gamma 0. When you calculate mean, you get 0.667. I want to show you one important thing actually, which is important for you. See, this is a GATE website, official website, okay. And if you go for downloads, then let's have this 2021 papers, 2021, okay, engineering sciences. If you have this 2021 engineering sciences paper, then let's see, I want to show you. In maths this question was asked, of course, 8, 9, 10, these are the 10 questions, okay. So maths, you see this is the 6th question, okay. I hope you all can see here, this is the question basically, okay. So this is the question which came here, and if you see the answer key of the 6th question, you will find something interesting here, okay. Fine, the answer key is not in this document, I guess. So let's see, if I click, yeah, let's see in this paper if I have the answer key, for example, okay. Okay, answer key is not here, but anyway you can just see the answer key should be there here, no? Yeah, answer key is here, okay. So these are aptitude, first 10 are aptitude. Then in the maths, the 6th question, you see this is the 6th question in maths actually. If you see the answer, the range given by IIT 2021 Bombay is 0.665 to 0.668. Can you see this? Yes or no? Clear? Can you see 0.665 to 0.668 is the range which is given as the final key, okay. And obviously if you round off to 3 decimal places, you would have got 0.67, and if you enter 0.67, 0.67 is not in this range, okay. So even after doing these calculations, just because of this little guy here, many people lost marks, okay. So that's why you have to be a little careful when you're doing the things. Clear? So this is 2/3, which is 0.667 actually in this case, okay. Then okay, so these are the questions basically. Now quickly we'll jump onto the excess parts of ordinary differential equations. Are you all clear till this point? Yes or no? So please type in the chat box. Are you all clear till this point? Okay. Now, yes or no, guys? So please type in the chat box. It's clear, right? So let's move to power series solutions actually. Okay, so that's a bit important things to take a note. Power series solutions, especially for gate 𝐂𝐸. Power series solutions. Okay, and of course we don't have Legenders or Bessel functions exactly, but we have. So it says up to 3 decimal places, so 0.667. Yes. So you told that I should tell something after first question. Just story. Fine. But actually, you know, I have this problem of short-term memory, so I forgot what I'm planning to say. Someone asked, doubt actually. Without 𝐂𝐸, can't we go to IITs and NITs? And with a smiley. I understand your intention, because to be honest, there's a lot of things going on YouTube as of now. Not only in our channel, but in, you know, if you see various platforms, okay, you know the names better than me. So if you see various platforms, they all tell you like 𝐂𝐸 is this, that, and all. Yeah, 𝐂𝐸 is definitely a way to enter into IITs and NITs. I think not NITs, but majority of the IITs. In IITs also not 100%, but in all the old IITs and also in all the new IITs, you have entry into the core branches. But there are few restrictions in few places. Okay. Actually, when gate examination happens, gate organizing committee, like for example this year IISc Bangalore, it never thinks about whether Vinay has attended coaching at PW or some other platform, and whether those tutors has told the shortcut, this thing and that. You know, they never think of this. They just wanted you to test. Let's say for example, I know a guy, you know, one of my colleagues actually, he was from Jammu and Kashmir. In Jammu and Kashmir, you know, there's literally no awareness about gate examination. Okay, so I'll just tell you, there's a guy from Jammu and Kashmir. In Jammu and Kashmir, there's no much awareness of gate examination, to be honest. Okay, if you even segregate students, okay, even if you segregate students, the number of aspirants are less actually. Okay, in Jammu and Kashmir, that guy know there is something called gate examination only in the final year. But the thing is, this guy has studied very good in his BTech, like good in the sense not for exam point of view and semester point of view. He has actually gained some knowledge. Okay. So what he did, he came to know that there is something called gate examination when he entered final year. So he entered final year in July. So gate application comes out in September. He entered, you know, gate in. He filled the form for gate 2023 last year. So what he did was, he just with his knowledge he went and gave the exam. He's from ECE, of course. Okay, his all India rank was below 50. Okay, 38 or something, I guess. Okay, so yeah, something around 30-40 within that domain. So he got into the place where he wanted. Okay, so I'm telling you, it doesn't matter. See, it doesn't matter how much talks happen on YouTube's, to be honest, guys. At the end of the day, your selection depends only on your hard work and your efforts. That's it. Okay, it doesn't matter whether if I am king of Dharmal or I am king of maths. Nothing. First of all, this word king is a very funny thing, to be honest, to say. Okay, so I never believed in those things, to be honest. So I just want to tell you, if your efforts are strong and if you have a sincere, you know, mind, then definitely you can, despite of all the coaching stuffs and all these things, you'll be easily able to make it. But the problem with today's college going students is 95, I would say, whether out of 100, 95 students never study BTech as BTech. They just study BTech as one more exam, one more certificate, one more, you know, just college going thing. That's it. Okay, they never attend BTech as BTech, and they never learn the concepts that is supposed to be learned actually. Okay, they just take a book out the night before the exam. Okay, this question has come 3 times, this question has come 4 times, this question has come 10 times in exam, so we'll study this. Even if that's not possible, then, you know, people take micro Xerox silently, then they'll go to exam hall and, you know, they get the certificate. You know, many times I find it funny when people, you know, say engineers don't have jobs in this country. Fine, we all have done engineering, we have got some jobs. Okay, and number of jobs we got, rejected few of them, then doing few of them. Okay, I'm telling you, if when people say engineers don't have jobs in India, you ask them how many quality engineers are there in India. Okay, like for example, you take mechanical. Okay, if suddenly if I ask you one random, if I call you and say, better draw the diagram of nut and bolt as per machine drawing requirements, I know many of you cannot actually. Okay, if I ask you to for example, if I give you a heat exchanger and if I tell you design just do this design of heat exchanger, for example. Okay, plenty of people don't know. Okay, even I'm sure even you might have seen people in college, they might have got the BTech degree. Okay, but if you take them to a mechanical workshop and ask them to show which is lathe machine and which is drilling machine, they face issues. Yes or no? Tell honestly, have you all met these kind of people or not? Correct? In your Viva voice, I'll ask you, out of these machines, which is milling machine? Then people start looking all over the lab. Yes or no? Have you all seen these people in your life? Correct? So it's not like because they don't have intelligence or things, they don't want to put the efforts. Okay, they don't want to do hard work. That's it. Okay, people always tell this saying that you know, it's not hard work, you should do smart work, all these things. Okay, but actually your mind becomes smart only if you work hard first. Okay, your mind becomes smart. See how you actually say mind is a smart mind. Okay, let's say for example there's a of course thinking IQ levels are different, but if you put on efforts, okay, let's say for example there's some problem in this smart board when I'm using, let's say for example something is not working. When I'm worked hard, if I had experience that in before, if I have seen something of such problem, then immediately I'll fix it. Okay, within 1 second or 2 seconds I'll fix it, and people think I'm smart. I'm not actually smart. Maybe I've done so much hard work and I might have got some experience in dealing this kind of stuff. Okay, that's what that actually keeps you. If intelligence and IQ is the only thing that drives you, then definitely many of the people in India might not have gone to IITs, might not have got some jobs, might not have been doing well in their lives. Okay, so IQ is just a thing which actually differs to some extent. Maybe an IQ of 10-20 could be different, but majority your hard work and your experience and your experience is not counted in years. Again, I'm telling you, people say that I'm 30 years experience, 20 years experience. No, that's not the case. It depends on how much time you qualitatively spent. Experience should always be counted on number of hours qualitatively spent on doing something. Okay, it's not I'm sitting in this chair for past 15 years, so I'm 15 years experienced. No, that's not the case. Okay, I mean just old because of sitting 15 years in that chair, but experience depends upon how much time you qualitatively put on the task. Got it? And if you can increase this positivity, things go better for you. Definitely they go better. Okay, fine. And also I just want to tell one thing openly. Other than content, okay, other than this content, what I'm not only me, any faculty is teaching, don't try to look much into the personal talks, emotional talks, all these things. Okay, they're good for nothing. Okay, I've seen people who are just doing these things, but I'm just telling you, just focus on the knowledge. Okay, if you undoubtedly when people are teaching you, you will just get some connectivity with the teacher, some bonding with the teacher, but it's not like knowing personally what he does, what he don't, in which platform, how he's or how she's doing the things. Okay, these things are none of your business. Okay, clear? So just focus on content and move on. Okay, because that makes you take you from the place where you are to your IITs or IISs or PSUs, whatever. Okay, not the emotional talks or entertainment in the sessions. That never helps you. Okay, in technical way, of course some good points has to be discussed, I do agree, but majority of the time has to be spent for qualitative discussion of the content actually. Okay, so does 𝐂𝐸𝐴 is limited to old IIT Samtech? Intake only for this 𝐂𝐸𝐴 is also used for JRF positions. JRFs don't take. Yeah, normally in R&D organizations, in DRDO, I think in DRD and ISO they don't take. Even in BRC they don't take 𝐂𝐸𝐴. But if your aim is to get into IITs and IISc, then definitely 𝐂𝐸𝐴 is a very powerful tool. Okay, that's all I want to say. Clear? Yeah, that's why in majority of my lectures I never do Gyan sessions. Okay, Gyan sessions are separate. We do like one day, for example, if I'm fine, I'll come up what Vinay sir did when he's in +2, +1. These kind of things I can do. But when a lecture is dedicated for content, please try to utilize it, because I have learned it from professors at IITs, IISc, and also like as some of you are telling in Stanford Online or basically MIT Open Courseware. I've seen a lot of people doing these things. Okay, yeah, clear? So let's continue. Power series solutions. So what is this power series solutions actually? Okay, now whenever you have these equations like P naught of x plus the things like this, plus P1 of x n minus 1 plus p2 of x okay. So this is equal to q of x actually. Clear? So in this case of equations, we do the power series techniques only when under certain circumstances. It depends purely on this polynomial. Okay, it depends on this polynomial actually. Okay, p naught of x into this, and this p naught of x, if you see carefully here, p naught of x actually, if a point x is equal to a, normally there are 2 points discussions which are singular point and also ordinary points. At x equal to a, if p naught of x is equal to 0, is not equal to 0, first of all, is not equal to 0, then a is called ordinary point. A is called ordinary point actually. Clear? So a is called ordinary point. Okay, and let's see, at x is equal to a, if p naught of x is equal to 0, means basically if p naught of a is equal to 0, then a is called singular point. Singular point actually. Okay, now the techniques for writing the power series solutions is actually different for these two. Okay, so one is the ordinary point and one is the singular point. In this singular points, we have a set of classes which is a regular singular point and the other is irregular singular point. Okay, and normally all your advanced maths starts dealing with this irregular. Okay, but in this lecture I would like to give some discussion on this ordinary points and also a regular singular points actually. Okay, so let's see, first of all, in the case of ordinary singular points. So first of all, when you call it a regular and irregular, first of all, p naught of x, if you see this equation, d power n by dx power n plus p1 of x by p naught of x by p naught of x actually plus into n minus 1th derivative by dx power n minus 1 and so on, plus nth derivative of x by p naught of x is equal to q of x, sorry, into y actually. Okay, so you also have y here, so this y is equal to q of x divided by p naught of x actually in this case. Okay, so once you have these equations, then you can write this p naught of x as, let p naught of x, because in case of a singular point, definitely x equal to a is a factor of this, so you can write as x minus a into some polynomial pa of x, for example. Okay, so let's write it pa of x. Okay, so because whenever p naught of x is equal to 0 at x equal to a, that means p naught of a is equal to 0, so x equal to a is x minus a is one factor of this polynomial p naught of x. So for example, if I write this equation as plus p1 of x divided by x minus a into pa of x, you call this for example q1 of x. Okay, I think I have taken q, so okay, fine. So this is a term d n minus 1 the derivative of y by x power n minus 1 and so on, pn of x minus a into pa of x operating on y is equal to q of x divided by x minus a into maybe some something like pa of x. Okay, now if you have this equation, for example, it is also included with Legendre polynomial. Legendre polynomials are not there in this syllabus as of now, but we'll see what is the standard classical technique in writing the power series solutions. Okay, because actually if you see the syllabus, since this is opened, I would like to show you papers on syllabus. You'll see that in engineering sciences, okay, so in engineering sciences you'll see in differential equations, okay, in differential equations you see first order equations, linear first order, second order with constant coefficients, Cauchy-Euler equations, second order linear differential equations with variable coefficients, which is basically the these equations which I am showing you. Wronskian, method of variation of parameters, eigenvalue problems is what we will see later. with constant coefficients. Power series solution only for ordinary points. Okay, so power series solutions only for ordinary points is there in the syllabus. It's not for the variable coefficients case. Okay, and here second order linear differential equations with variable coefficients is basically in the Euler-Cauchy of that form. Okay, so that's what we have. Clear? So I'll show you for the singular, and also for safe side I'll also, because one question is there based on regular. I think in 2021 syllabus it's got eliminated, but I'll show you for regular also. Okay, now basically when we call it a regular singular point is actually, if you take this function, you call this as r1 of x for example. Okay, and you take this function which is rn of x, because you have r2 of x similarly, and this is maybe some q, some function, you call it, maybe some pq r is then t of x, let's say, if these are the functions. Now apart, if you take this x minus a out, then if these functions are differentiable continuously, okay, if these functions are differentiable at x equal to a, then we call that singular point as a regular singular point. Otherwise it's called irregular singular point actually. Okay, now let's see if r1 of x, r2 of x, and so on, rn of x, comma t of x are differentiable at x is equal to a. Okay, are differentiable at x is equal to a, are differentiable at x equal to a, then are differentiable at x equal to a, then then x equal to a is a regular singular point, actually. Okay, and if these guys are not at differentiable even after taking this x minus a out, then we call that as irregular singular points actually. But anyway, we will see the solutions for singular power series solutions of ordinary points, and also regular singular points also. I'll just give you the idea. So power series solutions of regular points. Power series solutions of regular points, sorry, of ordinary points. Okay, so first we'll just discuss ordinary points. Okay, so let's see what we'll do actually. If you have this equation, nice, yeah. So let's see power series solutions of this ordinary points. So let's see if you have this p naught of a not equal to 0, then step 1, assume y is basically some series. So power series is basically like this: a naught plus a1x plus a2x square and so on actually. Okay, infinity, it's an infinite series actually. So this is sigma n is equal to 1 to infinity a n x power n, of course. Okay, so this is sigma n equal to 1 to infinity a n x power n. So once you get this 2, then in the equation, so calculate y dash, y double dash, y table dash, and so on, and substitute in given differential equation. Actually. Okay, so let's say for example I've given you the equation something like d square y by dx square minus 5x dy by dx plus 6y is equal to 0. Okay, so let's say this is a differential equation for example. Okay, if this is a differential equation that you have, then what you're gonna do is, clearly this polynomial is 1, so at x equal to 0, for example, about x equal to 0, at x equal to 0, this is just an ordinary point. Okay, it's not a singular point. So at x equal to 0, it's an ordinary point. So what we're gonna do is, we'll take y is equal to this function and we will substitute that. So if you substitute, then equate coefficients of x power m, of coefficients of powers of x to 0 and relate the constants. That's it. And relate the constants. This is what we basically do in when we are talking about power series solutions about the ordinary points. Okay, like for example, I'll work out with this equation and will show you how we can actually adopt this technique. Okay, so at x equal to 0, that's the equation. Basically, you know, x equal to 0 is just an ordinary point, you don't have any x there. Okay, so 1 is what you have. So let's see, your equation is d square y by dx square. Okay, so d square y by dx square minus 5 times of x into dy by dx plus 6y is equal to 0. Okay, now clearly x equal to 0 is ordinary point, they can ask you about any point. Okay, so they can ask you about any point. So generally this expression I have written x equal to 0, but normally if they ask you about x equal to a, you can write x minus a whole square, things like that. Okay, so let's see, in this case, if x equal to 0 is the ordinary point, then y is equal to a0 plus a1x plus a2x square and so on. Okay, let me write 2 more terms because it could be helpful. a3x cube plus a power x power 4 and so on. Okay, it turns up to infinity. Now what you do is you calculate y dash. So what's y dash actually in this case? Differentiation of a0 is 0. Y dash is nothing but dy by dx. Okay, so a1 plus 2a2x plus 3a3x square plus 4 a power a4 x cube and so on, infinity. Y double dash, this gives you y double dash is equal to, then what happens, you differentiate it once again. So 2a2 plus 6a3x plus 12a4x square and so on, infinity. Okay, now clearly this is the solution. If y is the solution in this form, then y dash, y double dash are there. If y is the solution, then definitely y dash and y double dash should satisfy this equation, yes or no? So if they want to satisfy this equation, then let's see, therefore considering y dash, y double dash, or you can say, instead of considering, replacing y dash, y double dash in 1. Let's say you call this equation 1, for example. Okay, so you call this equation 1. So you replace these guys in 1 actually. Okay, so when you replace these guys in 1, then let's see, yeah, if you replace this in 1, we have the terms like this. This implies d square y by dx square. Okay, so d square y by dx square gives this term. So 2a2 plus 6a3x plus 12a4 x square and so on, plus this term minus 5 times of x into dy by dx. Okay, so this is y dash. So if you multiply x, you multiply this equation with x actually, then you have x into y dash. So minus 5 times of x into y dash. So you have a1x plus 2a2x square plus 3a3x cube and so on, plus 6 times of y. So 6 times of a0 plus a1x plus a2x square and so on, okay, is equal to 0, of course. Okay, so this is the equation actually. So if this is the equation, then what you have to do is, this equation is solution of this for any value of x, correct? Because it's not like x is equal to 0, because if x is equal to 0, it gives a trivial solution, yes or no? If you put x equal to 0, then definitely y equal to a0. If y equal to a0, then definitely a0 has to be 0 because of this equation. So clearly it's a trivial solution. So this equation should be valid at any value of x. So if this equation has to be valid at any value of x, what happens is, you segregate the coefficients. See, this is a constant, this is a constant, 6a0. So 6a0 plus a2 plus, then coefficient of x, 6a1 minus 5a1 plus 6a3. This is coefficient of x, plus coming to a2 coefficient, 6a2 minus 2 into 5, 10 times of a2, plus here we have coefficient of x square is 12a power 4, 12a4 operating on x square, okay, plus and so on. This will be equal to 0. Now try to understand one thing. I have given you one point here, relate the coefficients, okay, relate the constants. How to relate the constants actually? See, if this expression is 0 at any given value of x, that means all these coefficients should be zeros, okay. So this has to be 0, this has to be 0, this has to be 0, of course, okay. If you make these things zeros, then let's see what you will get. If you make these things zeros, this gives you 6a0 plus a2 is equal to 0. So a2 is equal to minus 6a0, okay. This is one equation. Now here 6a1 minus 5a1, a1 plus 6a3, a1 plus 6a3 is equal to 0. So A3 is equal to minus A1 minus 6 times of A1 actually, okay, minus A1 by 6, sorry, minus A1 by 6 of course, okay. Now let me tell you one important thing here. If you keep integrating this, look what we can get here is, I'll write some intermediate term in between plus and so on an x power n and so on infinity. So this gives you n into a power n into x power n minus 1 plus n plus 1 into an x power n plus and so on infinity. Similarly here if you see plus n into n minus 1 into an x power n minus 2 plus n plus 1 into n into an x power n minus 1 plus n plus 2 into n minus 1 into this is a n plus 1 actually, a n plus 1, then this is a n plus 1 of course, okay, a n plus 1, and yeah, this is the second derivative, right? So this is a n plus 2 x power n minus 2 plus and so on infinity, okay. This is how you get the solutions. So when you actually correct the terms corresponding to x power n minus 2 and all, you can get the relation between an minus 1 and an, or basically an plus 1 and an plus 2 actually here, okay. Like for example you see here we'll end up somewhere with x power n minus 2 coefficient for example, okay. So if you end up with x power n minus 2 coefficient, okay, so if you multiply this equation with x actually, if you look at x power n coefficient for example, okay, so this is x power n actually, so you have x power n of course, a n plus 2 into x power n. Now when you collect the x power n coefficient part, you will have n plus 2 into, in general, so this in general, just a minute, something happened, okay, fine, you have this, okay. So in general you can see x power n coefficient here, okay, x power n coefficient here is n into n plus 1 into n minus 1, n plus 2 into n minus 1, n minus 1 or n plus 1, n plus 1, it should be n minus 2. So here if you see, what is the next term, n plus 2 into a n plus 2 into x power n plus 1 actually, okay. So that's the next term, yeah, basically if you are differentiating once, then you will get this. So into x is what you have. So if you take out the x power n terms, okay, so we get n plus 2 into n plus 1, yeah, this should be n plus 1, correct. So this should be n plus 1, n plus 2 into n plus 1 into a n plus 2 x power n, a n plus 2 actually, okay. So this is a n plus 2, then x power n term in this equation, because if you are multiplying an x to this equation, then this n times of an gives you the x power n coefficient there, so plus n into an actually, okay, so plus n into an and plus an actually, okay, so plus an is has to be 0. This is the general nth term actually, okay. So if this is the general nth term, then you can see n plus 2 times n plus 1, n plus 2 times n plus 1 times a n plus 2 is equal to plus n plus 1 of a n is equal to 0 in this case, okay. So this is equal to 0 of course. Then let's see, if you cancel this n plus 1 and n plus 1, then a n plus 2 is equal to minus a n by n plus 2 is what it's coming here, correct. So roughly that's what it's coming, I guess. Yeah, something we missed actually, just do this coefficients very carefully, a n power n, then this becomes n into a power n into a n x power n minus 1. So when you multiply with x, you have minus 5 times is there, so minus 5 times is also there here, so minus 5 times, so here 5 should be there, sorry, plus 5 times, so this is plus 5n plus 1, 5n plus 1, so this is 5n, because 5 is also there as the coefficient here, so you can see this minus 5 is there, okay. So minus 5n is what you can have, minus 5n, the coefficient of x power n, minus 5n is what you have, so this is minus 5n, so this is something like by 1 minus 5n, but I think it should be plus actually somewhere. So just check it out. The main thing is, I hope you got the idea. You have to calculate the, like how I am taking segregating coefficient of x square, coefficient of x cube. So in such way, if you aggregate the coefficient of x power n, you can get the relation between 3 consecutive terms. Okay, so what we'll do because of that, you got the relation a0 is a2 is equal to 6 times of a0, a3 is equal to minus a1 by 6. So finally you will end up everything a4, a5, all these things in functions of only a0 and a1 actually. Okay, so if you can write that, what you can do is y is equal to a0 times of a0 is some constant, so a0 times of, so you can see a0 into 6 a0 plus a2 is there. So yeah, if you aggregate this, what happens here? Just a minute. Yeah, give me a moment. So once you simplify this, you get this expression. So you can generate some function plus a1 into some function actually here. Okay, so these are the two arbitrary constants what you have taken, c1 and c2, and this is basically your y1 and this is actually your y2, because see in this expression, for example, if this is the expression, you got the relation between a0, a1, a2, everything. If I am writing, for example, y is equal to a0 plus a1 x plus a2 x square, see this is my solution. Okay, a3 x cube and so on. So let's say, for example, if this is function of, like you see, a2 is replaced with minus 6 a0. Okay, minus 6 a0, a3 is replaced with minus a1 by 6. So when you are doing this and so on, a4 is again in terms of a0, a5 is again in terms of a1. If you do this, you will end up with a0 into 1 minus 6x square plus something, and a1 into x minus x cube by 6 plus and so on into something. Okay, so like this you will end up with a0 into some function plus a1 into some other function. So these are two arbitrary constants for this differential equation which is of second order. Okay, so that's how we generate the concepts, the functions y1 and y2 actually. Clear? This is how the power series solution technique is used normally. Got the idea? Okay, so we calculate the general expression for the coefficient of x power n, like how we are calculating coefficient of x square, like this, using this technique. So similarly, using these terms, we'll also calculate the coefficient of x power n in general and equate it to 0. Okay, so when you equate that to 0, you'll get a relation actually which gives you these constants. Clear? Yes or no? So please type in the chat box. It should be 5n minus 1, I guess, because again you have shifted that. Okay, so anyway, just do a bit of calculations clearly. So n power 2 gives you n plus 2 into n plus 1 into a n plus 2, n plus 2 into n plus 1 into a n plus 2. Then after minus 5 times of x coefficient will be x power n minus 1 is coefficient is what you used to have here. So n into a n, fine, 5 times of n into a n is what you have, plus a n, correct. This equation is actually correct. So you can, then you cannot cancel this n plus 1 actually. Okay, you just see in this what you can have, the generalized expression a n plus 2 is equal to 1 or 5n minus 1 divided by n plus 1 into n plus 2 times a n, of course. Okay, so this is the generalized expression. Clear? Fine. Why trivial solution? Because see, if these are not zeros, let's say if x is only 0, then y equal to a0 is what you will get. Okay, if you put y equal to a0 here, derivative of a0 0, derivative of a0 0, 6 times of a0 is equal to 0. So this term 6y is equal to 0 will be left. So 6 times of a0 is equal to 0, that gives you a0 equal to 0. If I take x equal to 0 and a0 is also equal to 0, then y equal to 0 is the solution, but y equal to 0 will in general satisfy any differential equation. Okay, it's not a non-trivial solution, it's a trivial case. Clear? Got it? Is it clear to you or not? So please type in the chat box. Is that clear? Okay, watch. Pawan Ahmed, Fun Gaming, Abdullah, Devesh, every one of you. Did you understand basically how we are generating the results? And did you understand why it's a trivial if x is equal to only 0? Okay, so x should not be equal to 0, which means this all coefficient should be 0 in return. That's how. Okay, now let us do one more thing. Let us do the case of eigenvalue problems. Okay, so guys, regular points I'm just skipping as of now. Okay, because anyhow that's not in the syllabus. You see, power series solutions only for ordinary points is there. For regular points you don't have, but in 2018, I think long back when the syllabus is something different, there came one question which I have kept it here. Okay, so which I have kept it, I think I haven't kept it because I have eliminated that in the syllabus, but normally you will see yeah, fine. So okay, so in case of regular points, what we do is only one small correction we do. Instead of doing this as a solution, in regular points, for regular points, y is taken as x power m into a0 plus a1x plus a2x square and so on actually. Okay, so this is what you get actually. Clear? So this is the expression for y, which is x power m times of this value a0 plus a1x and so on actually. Clear? So this is the value which you have. Then so obviously again the same process, calculate y, y dash, y double dash and so on, and substitute in given d, in substitute in given d. Now the equation coefficient of least power of x, least power of x, coefficient of least power of x is equal to 0. This equation is called indicial equation. This equation is called the indicial equation. Okay, okay, please guide me for some topics so I can advance them in 2 days. Yeah, as we go Lakshya we'll see. Okay, so let's see coefficient of indicial, coefficient of least power of x, because see here you have a constant term. Okay, so you see here you have a constant term because you started with this solution having a constant, but in this case when you have this x power m, you won't have a constant term, rather you will have some term into some power of x plus some other constant into some other power of x and so on. Okay, difficulty level in 𝐂𝐸 increases compared to maths. Yes, of course, compared to other branches you can see the questions are slightly of advanced level. So this is the indicial equations. That's why you also need an advanced faculty. Okay, I'm just kidding, anyone does the job better. Okay, so let's see if you have this indicial equation. Now the solutions of this equation, like how in case of complementary function the roots of auxiliary equation are deciding the nature of the complementary function, similarly by the roots of this indicial equation we decide the stability, or basically we decide the solution of the differential equation actually. Clear? So these are the things that we have. So let's solve some questions so that we can close differential equations. This is a partial differential equation question. We'll delete a bit moment later. Yeah, so this is one question which I thought of solving, which is not in syllabus now, but still, the largest interval in which the initial value problem e power x d square y by dx square plus 1 by x minus 5 dy by dx plus square root of x y is equal to ln x, where y of 1 is equal to 0 and dy by dx of 1 equal to 1 has a unique solution is dash. Okay, now try to understand something. First of all, e power x is equal, e power x, you don't have e power x is not equal to 0 for finite x. Yes or no? For finite value of x actually. So it's basically it's a ordinary point. Okay, but in ordinary point there is one exclusion here, this x minus 5. Okay, so whenever it's an ordinary point, the syllabus the solution is obviously a unique solution, but this x minus 5 is actually eliminating or creating certain disturbance. Okay, so and this root x and ln x are also there. So first of all, the value of x should be in such a way that it should satisfy all these violations. Okay, like it should not fall into any of these pits actually. Okay, so first of all, for this dE to have a solution, to have unique solution, x minus 5 is not equal to 0, correct? So x should not be equal to 5 first of all. Whatever the interval you choose for the solution, that interval should not contain 5, because if it contains 5, this denominator goes to 0 and the complete equation blows up. Okay, so that should not be there. And since you have root x and log x, these two guys, of course, we are dealing with real calculus, so things should be defined only for positive numbers. Okay, because log x is defined only when x is greater than 0, and root x is also defined when x is greater than or equal to 0. So definitely x should be greater than 0 in this case, because this log x should not be violated. So we should choose for that interval where it is more than 0, x contains positive values, but at the same time 5 is not included in that. Okay, so let's see. In this equation, negative numbers are included, so we cannot take this. In this equation, 5 and negative numbers are again included in this, so we cannot take this. Okay, 0 to infinity, but 5 is included in this interval, so that also don't lead to single solution, but 0 to 5 is actually present. Okay, so that's why D is actually the correct answer in this case. Clear? Because one of the students has posted this some time back, whether this equations are what do I say, whether this question is in syllabus or not. It's not directly, but actually to solve this question you don't need any knowledge of complete differential equations. Okay, D is the correct answer. Clear to all of you? Okay, I hope it's clear, right? So let's go to a bit of partial differential equations now, because differential equations is such a huge module. Okay, so if I've continued yesterday, it would have been 1 o'clock or 2 o'clock, and you guys might have lost complete interest. Okay, so that's what. So just a minute, let me have some water. So is accelerated vessels important for XC? Yeah, maybe. Till now I think, see in XC I'll tell you one thing. Normally when you are preparing for mechanical, like for example you see mechanical fluid mechanics this year, there's one question from piping, okay, one question from divergence or somewhere, yeah, incompressible and irrotationality, some condition is given, okay, and one question is from Nusselt number, no, dimensional analysis, okay, dimensional analysis. So what about hydrostatics, buoyancy, dynamics, fluid dynamics? Nothing is mentioned. Okay, so when it is not written in latest syllabus at 𝐂𝐚𝐿, but actually see as long as kinematics is written, all these parts come under fluid kinematics. Okay, so that's why fluid kinematics, that one word is sufficient to put hundreds of things into it. Okay, and in XC exam definitely questions will be from every topic, because even if I say that I am predicting that question will come from buoyancy, definitely there will be at least one question from buoyancy. Okay, because predicting in XC is very obvious, because you have hardly like 10 to 12 chapters, they have to give you 22 questions. Okay, so it's quite obvious that at least from each chapter at least 1-2 questions turns up. Okay, so that should be there. Yeah, I hope this equation which is in doubt for so many days now got cleared. Okay, so is it good to go with DUM and FM choice? Yeah, Aniket, because I've been writing XC for past 3 times. All 3 times I went with FM and XC. FM and DUM only. Okay. Okay, fine. Yeah, DUM and SOM is also fine. Yeah, basically you can choose any two. Okay, but choosing can happen only during the during the examination point of time. I think in one of the videos I made on YouTube also I have told this. You can choose what 2 subjects you are deciding. You can decide, and you can click only during the examination time. Okay, so anyway, let's see. So partial differential equations. Partial differential equations. Okay, so again the syllabus is vast, but of course for GATE exam, for XC part, hey guys, I'm very sorry, I forgot one thing. Before we go to this thing, we'll see something called eigenvalue problems of ordinary differential equations. Because this is also in syllabus, and last day also one question came actually. So value problems of ordinary differential equations. Okay, today cover remaining topics. Yeah, I'll try to close that. Okay, today itself. Okay, Krishna. So see, well, eigenvalue problems of ordinary differential equations. So we have only one special type, I guess, in the syllabus. What is there in the syllabus? I'll teach only that. Eigenvalue problem for second order equation with constant coefficients. Okay, fine. So let's see second order equation with constant coefficients. Normally we see d square y by dx square plus lambda y is equal to 0 actually. So this is the equation which is much familiar. And can anyone tell me what is this equation? What is this equation? D square y by dx square plus lambda y, maybe t square sometimes, or d square x by dt square plus lambda x, anything. Can anyone tell me what is this equation? No idea? You know, many of you don't know the power of eigenvalues actually. Okay, I have written of course eigenvalues. Using eigenvalues you can calculate principal stresses, principal strains. Using eigenvalues you can calculate frequency of vibrations. Okay, using eigenvalues you can calculate this eigenfunctions. Okay, so there are a lot of advantages actually by knowing the eigenvalues of a matrix. Okay, so anyway, this is a simple harmonic motion. So let's see, this is a simple harmonic motion, of course, SHM in this case. Clear? So simple harmonic motion, clearly x double dot plus some constant into x is equal to 0. Okay, now let's see if this is SHM. If you want to solve this equation, for example, auxiliary equation, m square plus lambda is equal to 0. So m is equal to plus or minus out minus lambda actually. Okay, plus or minus out minus lambda. Now let's give some solution. Let's say for example if this is a sine wave, okay, then let me give you some initial conditions. Y of 0 is equal to 0 and y of 2 pi, let's say it's a periodic function, so period 2 pi for example, so y of 2 pi is also 0. I have given you some boundary conditions like this. Y of 0 is 0 and y of 2 pi is also 0 actually. Okay, now let's see if you want to get this solution, it depends whether the lambda is positive or negative or 0. Okay, so first let us consider the case of lambda being positive, lambda being positive. Okay, so lambda being negative, first of all let us do case by case. Negative equal to 0, positive. So 1, if lambda is negative. Okay, so if lambda is negative, then what happens? Okay, lambda is basically called the eigenvalue. Right now we are not getting into the details of vibrations and all, but just this is a constant for example. Okay, so lambda is actually a constant which is the eigenvalue. Okay, normally what we do with the help of this lambdas and all eigenfunctions we don't discuss in this particular module, but I would just give you the technique to solve this equation. Okay, and what are practically the eigenvalues of course. Okay, so let's see if lambda is less than 0 actually, if lambda is less than 0. Okay, so if lambda is less than 0 in this case, then m is equal to this less than 0, and let's also write lambda is equal to minus k square for example. Okay, so lambda is equal to minus k square because k square is always positive, so I have put a minus sign, so that this term comes negative, so lambda is negative of course. Okay, so m is equal to plus or minus k, so this implies y is equal to c1 e power kx plus c2 e power minus kx is what you have. Okay, so these are real numbers of course, so c1 e power kx plus c2 e power minus kx actually in this case. Now let us substitute these boundary conditions. You understand something, x of 0 or sorry y of 0 is equal to 0, this implies 0 is equal to c1 plus c2, so c2 is equal to minus c1. Okay, so c2 is equal to minus c1 is what you have, c2 is equal to minus c1. Okay, and y of 2 pi is equal to 0, this implies 0 is equal to, for example if I take c2 as minus c1, c1 times of e power 2 pi minus e power minus 2 pi, this is what you have, and clearly this quantity is not 0. Okay, so this expression is not 0. Okay, because it's a constant, e power 2 pi minus e power minus 2 pi gives you a constant. So if possible please conduct sessions on FM also on tomorrow. Yeah, tomorrow is the session on fluid mechanics, I myself will take. Okay, 6 p.m. Be sharp, I'll start with fluid and properties, of course not the complete details, only the extra topics part and some details on some important topics. Okay, so anyway this is not equal to 0, so this gives you c1 is equal to 0 actually. Now tell me, if c1 is equal to 0 then definitely c2 also 0. If c1 is 0 and c2 is 0, this y is actually 0, which is actually a trivial solution of this. Even without solving we can say if we put y equal to 0, this equation gets satisfied. Okay, we all know this. So clearly you can see this implies y equal to 0, and this is actually a trivial solution. Trivial solution. Okay, but this trivial solution is not the thing which we are interested in. So lambda less than 0 is not of much importance for us. Okay, now let us take the case 2, lambda is equal to 0. So if you take this lambda is equal to 0, of course, then in this case, let's see, m is directly 0 comma 0, because if you put the same story, k equal, if lambda equal to 0, k equal to 0, 0. So this expression becomes y equal to c1x into e power 0x plus c2 into e power 0x. That's all. Okay, c1x plus c2 into e power 0x. E power 0x is 1 actually. So RTT, in RTT only steady case comes, no? Yeah, generally it comes only in steady case. Okay, so but of course better to know the expression for the general expression, then you can apply it only for the steady case. Okay, Lakshya, fine. So let's see in this case. So again we got certain boundary conditions. At x is equal to 0, y equal to 0. So this implies c2 is straight away 0, of course. Okay, so c2 is straight away 0. And at x is equal to 2 pi, y is equal to 0. So this tells you 0 is equal to c1 times 2 pi. So this again gives you c1 is equal to 0. So c1 is 0, c2 is 0. This also gives you trivial solution. So this also gives you a trivial solution actually here. Okay, so this also gives you a trivial solution which you cannot take. So this is also not a very good choice. Case 2 is also not a very good choice. Okay, so let's go to the case 3, lambda being positive. Okay, so if lambda is positive, then let's see what happens. Lambda greater than 0, of course. So if lambda is positive, this implies m is equal to plus or minus I k. Okay, so this is what you get, because and lambda is positive and lambda is equal to k square, for example. Okay, so lambda you put it as k square, then you just see this guy here. Okay, yeah, here if you put this lambda is equal to k square, then you have minus k square, which gives you plus or minus I times of k actually. Okay, so if you have plus or minus I times of k, this implies your y is equal to e power alpha x. There is no alpha, 0. So c1 cos kx plus c2 sin kx actually. Okay, so this is plus c2 sin kx actually in this case. Okay, so c1 cos kx plus c2 sin kx. Now let us see the boundary conditions. Y of 0 is equal to 0. So 0 is equal to c1 into 1 plus c2 into 0. So this gives you c1 is equal to 0 actually. Okay, so c1 is equal to 0, because when you put x equal to 0, cos 0 is 1 and sin 0 is 0. So this term anyhow goes off. So c1 is actually 0. Okay, and let's see your y of 2 pi is equal to 0. So this gives you 0 is equal to c2 sin kx. Okay, so this is what you have. C2 0 is equal to c2 sin kx actually here. Now if this is c2 sin kx, then observe carefully. If this c2 is 0, then again this is also trivial solution, and it looks like this equation doesn't have any solution. Okay, so therefore this c2 is not equal to 0, rather sin kx is equal to 0, of course. Okay, so sin kx is equal to 0, of course. So this actually tells you your kx is equal to n pi, of course. Okay, so kx is equal to n pi. And let's see, so here you can also keep one more thing. You can put your x as 2 pi, because this is done at x equal to 2 pi. So sin kx or sin 2 pi x actually. Okay, sin 2 pi, so 2 pi into k. Okay, sin 2 pi into k, of course, because this is 2 pi. So you have sin kx actually. So if you put x equal to 2 pi, you have k into 2 pi. So sin 2 pi k is equal to 0. So this implies your 2 pi k is equal to n times of pi, of course. Okay, because if this 2 pi k is equal to n times of pi, then definitely what you get, you will end up with you actually ends up with this solution, non-trivial solution. Okay, so you can see if you cancel pi and pi, your k is equal to n by 2, of course. Okay, so k is equal to n by 2, but what is k actually? You see, k is equal to square root of lambda. So lambda is equal to k square, which is n square by 4, where n starts from 1, 2, 3 and so on. Okay, so clear? So n starts from 1, 2, 3 and so on actually here. So therefore you can see these are different eigenvalues of this particular system. Okay, so lambda 1 is equal to, when you put n equal to 1, 1 by 4. lambda 2, when you put n equal to 2, this is 1, lambda 3, 9/4. So all these are eigenvalues. So last session, last year, they asked you what is the second least eigenvalue. So if you put n equal to 2, then what is the second least eigenvalue is what you will get out of this, okay? Because this is the least, this is the second least, and here onwards they increase because n square keeps increasing, okay? So these are the eigenvalues basically, and eigenvalues, of course, okay? So can I ask you one important thing here? Let's see, these are lambda values, of course. If you take lambda here, okay, square root of this lambda is nothing but the frequency of this system, yes or no? Because you can see d square y by dx square plus omega n square x or omega n square y is equal to 0. This is the solution, and square root of this is what we have. And using this simple analysis, we are finding what are the values of lambda which are possible. So when you have a multi-degree freedom of system, then we can get it. Clear? So, but anyway, let's see. Lambda 1 is equal to 1/4. So these are the eigenvalues of this particular system. Okay. So we calculate eigenvalues for a matrix. What is the matrix here? See, this is basically only in single degree of freedom. Normally, if you take your vibration systems in multi degrees of freedom can be written in this, and the frequencies of different systems are nothing but eigenvalues of this coefficient matrix. Okay. So like this is only a single equation, no? X double dot plus some constant k1 x is equal to 0. Okay. Normally what we'll do is we generate something like a1 x double dot plus b1 x dot x2 double dot, then x2 dot plus c1 x2 is equal to 0 when you have damping and all these things. So we can calculate the natural frequencies of this case. Okay. So please solve some problems of this topic. Here I'll solve one problem which came in last year 2023 XE, which I'll take it from here directly. So I'll take from 2023. Okay, question papers of 2023 engineering sciences. Yeah. Okay, so we'll make it short and let's see. Yeah, in this. Okay, so you can see the second smallest eigenvalue of the problem, d square by dx square plus lambda minus 3 on y is equal to 0. Y of 0 is equal to y of pi is equal to 0 actually in this case. Okay. Similar method in second Laplace equations. Yeah. Okay. So let's see. If this is the equation, then what is the second smallest eigenvalue? Okay. 7 I think is the answer last time when I have solved on live, I remember. So let's see. This is the equation. Okay. So if you solve this question, firstly, example, this is 2023. Okay, XE it came. So d square y by dx square plus, what about this guy? Plus, oh sorry, yeah, just a minute, plus lambda minus 3 on y is equal to 0. Okay, and the conditions they have given you is y of 0 is equal to y of pi is equal to 0. That's the conditions actually. Okay, so let's see if these are the conditions, then obviously the auxiliary equation is m square plus lambda minus 3 is equal to 0. So m is equal to plus or minus I times of square root of lambda minus 3. Okay, that's what you have, because by this time you know this has to be negative, all these things. Okay, so because you see if lambda is negative or lambda equal to 0, then you will end up with trivial solutions, they don't do anything. So if lambda is greater than 0, then you have certain eigenvalues which are getting generated. Okay, so here if I take lambda minus 3 is positive and all, then we'll end up with this solution. So you can see this implies your y of x is c1 cos root lambda minus 3 x plus c2 sin root lambda minus 3 on x actually here. Okay, now let's see if you put this boundary conditions, y of 0 is equal to 0. So this implies c1 is 0 straight away. Okay, because 0 is equal to c1 cos 0 plus c2 sin 0. So c2 term completely gets eliminated. So you will have y of x is equal to c2 sin root lambda minus 3 x actually. Okay, so this is the function finally. Now they have given you y of pi is equal to 0. Okay, so what is y of pi is equal to 0? Y of pi is equal to 0. So 0 is equal to c2 sin root lambda minus 3 times pi is what you have here. Okay, so this term is equal to 0. So C1 is already 0 because of this boundary condition, but if you put C2 equal to 0, then it has a trivial solution. That should not happen. So square root of, therefore root lambda minus 3 times pi should be equal to n pi, of course. Okay, so this should be equal to n pi. So pi gets cancelled. So lambda is equal to 3 plus n square for n is equal to 1, 2 and so on. Okay, so lambda is equal to 3 plus n square. So this is the classic form for the generation of eigenvalues in this problem. Okay, so lambda is equal to 3 plus n square. Now if you put n equal to 1, lambda equal to 4, n equal to 2, lambda equal to 7. Okay, n equal to 3, you put lambda equal to 12 and so on. This list keeps increasing theoretically. So let's see, in this question what they are asking, they are asking you for the second smallest eigenvalue. Okay, so second smallest, you see the second smallest, this is the smallest, this is the second smallest. So this is second smallest eigenvalue. Clear? So this is the second smallest eigenvalue and you have lambda is equal to 7 in that case. Okay, so if lambda is equal to 7, then see in these options I'll tell you one thing, many people don't read this word, they feel like the smallest eigenvalue and 4 is the first option. You know why 4 is the first option? Because actually 4 is the smallest. Okay, if you don't read the question properly, second smallest, then just you will see the 4 and tick 4, you'll lose marks. And I think it's a 2 marks question. Okay, because many, yeah, 14th problem, so roughly I think it's a 2 marks question. So otherwise people, yeah, this is basically 7 is the correct answer. Okay, so in this case, okay, so is this clear to all of you? Did you understand? Someone has asked me now to solve a question. Where is this? So please solve the diagonalization problem in the same paper. Diagonalization problem in the same paper. Where is the diagonalization problem? There is some problem on diagonalization. Where it is? What is this? Identity matrix, eigenvalues. Some just easy question. Eigenvalues, this one, yeah, this one, right? Is this the question you're asking? I think because diagonalizable is there in this question. Okay, so let's see what is this question actually. P is a matrix. Okay, so Q is also a matrix. The eigenvalues of both P and Q are 1, 1 and 2. Which of the following statements is true? Fantastic. Okay, so first of all I want to tell you one thing, there are something called similar matrices. Okay, which I think maybe we skipped yesterday because this is a separate question based on, you know, diagonalization, but of course the concept is diagonalization, but the concept is based on similar matrices. Okay, so we'll see what is similar matrix. Look, I'll just, this question is clear, right? Lambda equal to 7 is the second eigenvalue. Yeah, 18th question, right? This is the 18th, I guess. Yeah, 18th question, fine. So let's see. First of all, we have something called similar matrices. Okay, I would like to spend some time here. Similar matrices. So what are the similar matrices? Let's see. A and B are said to be similar matrices if they have same eigenvalues. Same eigenvalues. Okay, so basically the eigenvalues has to be same in this case, and of course if eigenvalues are same, yes, the rank also will be same because algebraic multiplicity of 0 will be same. Okay, if the size is same and of course the number of zeros are same, then definitely rank will be same and all. Okay, because I told you in yesterday one point, you remember, rank of a matrix is equal to its dimension minus you know, algebraic multiplicity of 0 as eigenvalue. Algebraic multiplicity of 0 as eigenvalue. Now clearly, since we are calculating about eigenvalues, so we are taking only square matrices. So if you have the size n and if algebraic multiplicity of 0, if both the matrices have same eigenvalues, then definitely number of times 0 comes as eigenvalue will be same in both the matrices. Okay, so therefore this rank will be same clearly. Okay, no issues. Rank of A and rank of A, B will be same. Rank of A and rank of B will be same actually because of this simple understanding. Now let's see one important thing here. If A is diagonalizable, this implies B is also diagonalizable. We can actually prove this, but right now I'm not doing. Okay, you can just diagonalizable, diagonalizable. Okay, so if one is diagonalizable, then definitely other will be diagonalizable. If one is not, then definitely other is also not. Okay, so these two matrices will be diagonalizable together, or they're not diagonalizable. Both are not diagonalizable actually. Okay, so let's see how do we identify whether both matrices are diagonalizable or not. Let us find if one of the matrices is diagonalizable or not. Okay, if one is diagonalizable, then the other is also diagonalizable. If one is not, then other is also not. So let's check with A. A is equal to, so let's see the matrix what they're given you. Out of these two, which matrix is simple? Okay, anyway, anything they look same. So let's start with this. 4 minus 2 2, 4 minus 2 2 actually, 6 minus 3 4, 6 minus 3 4, and 3 minus 2 3, 3 minus 2 3 actually. Okay, so this is the matrix. So let us inspect whether this matrix is diagonalizable or not. Okay, so how do we find it? See, normally if this matrix is diagonalizable, we write this as PDP inverse, correct? Now for this P inverse to exist, this P should be non-singular. Okay, means P is formed by eigenvectors. In last class I was talking about this. P is formed by eigenvectors. Then if P is formed by eigenvectors, okay, so see carefully. If P is formed by eigenvectors, then definitely this what do you say, this vectors should be linearly independent. Okay, so these vectors should be linearly independent. Eigenvectors should be linearly independent, because if they are not independent, if they are dependent, then what happens? Independent. Okay, fine. So if they are dependent, then definitely one over becomes proportional to other, or maybe things like that happen and they cancel out. Okay, so that should not happen. Now how do we identify whether eigenvectors are linearly independent or not? Let us calculate. Eigenvalues are given here. In this case, eigenvalues are given. So what are the eigenvalues? 1 1 and 2. Guys, let me tell you one thing. Many of you have this misconception. If eigenvalue repeats, then definitely if eigenvalue repeats, then this is not this P inverse doesn't exist, but actually it's wrong. Okay, even if eigenvalues, look, if this is diagonalizable, then matrix can have n distinct eigenvalues. Fine. If all the eigenvalues are distinct, then definitely it is diagonalizable. But it's not like if it is repetitive, then it's not diagonalizable. Clear? Even in case of repeating, the matrices can be diagonalizable, which we do encounter sometimes. Okay. So let's see. First of all, how to calculate these eigenvectors. Ax is equal to lambda x. Now first of all, let us find the eigenvalues corresponding to eigenvalue lambda is equal to 1. Okay. So this implies 4x1 minus 2x2 plus 2x3, 6x1 minus 3x2 plus 4x3, 3x1 minus 2x2 plus 3x3. These guys should be equal to x1, x2, x3. Okay. Now let us simplify this. If you simplify these equations, what you will get? 1 is the repeating eigenvalue. Okay. So let us calculate. So if you simplify 3x1 minus 2x2, 3x1 minus 2x2 plus 2x3 is equal to 0. This is one equation. Then coming here, 6x1 minus 3x2 plus 4x3 is equal to x2. So if you pull it here, 6x1 minus 4x2, 6x1 minus 4x2 plus 4x3 is equal to 0. And the last one, if you see 3x1, if you put this x3 here, so we have 3x1 minus 2x2 plus 3x2 minus 2x2. If this comes here, we have plus 2x3 is equal to 0. Plus 2x3 is equal to 0, of course. Now clearly one thing that we can understand here is, you clearly understand one thing. All these represent same equations. Represent same equation actually. Okay, so they all represent same equation. So up to what time class will be, maybe let's see. Okay, so let's continue first. So this represents the same equation. So if this is representing same equation, then how do you write the things? Look, for example, from the any of the, you take any equation because all are same. Okay, so all the equations are same clearly. So it's a 2 parameter system clearly. So it's a 2 parameters system because you have only one equation. Effectively you got only one equation but with 3 unknowns. Okay, so if you have only one equation with 3 unknowns, you'll see x1 is equal to minus 2/3 x2 plus 2/3 x3 actually. Okay, and you keep maybe x2 and x3 as usual. Okay, so you keep x2 and x3 as usual. So if you split this, we will get the eigenvector x1, x2, x3 is equal to, so x1 is written in this form, so minus 2/3 x2, x2, x3. Okay, you can see by 2 plus 2/3 x3. Just a minute, we'll slightly convert this. So you can see minus 2/3 x2 plus 2/3 x3 x2, and you have x3 actually here. Okay, so what you can do is maybe you can pull minus 2/3 x2, x2, x3. Okay, and the other one being maybe 2/3 x3. Okay, so 2/3 x3 actually. So 2/3 x3. We'll put one thing here. We'll do 0, and we'll put x3 here, and we'll put 0 here. Okay, so that it can be framed. Now you can understand if I take this x2 out. Okay, 1 dependent and 2 independent, of course, yes. Okay, so you find geometric multiplicity of 2, both matrices, will it come to both cases they are to be diagonalizable? Yeah, but even in that case, even see this process is quite simple because you see just multiplication of 2 matrices is involved. Again, if you go for calculating geometric multiplicities, okay, arithmetic multiplicity and geometric multiplicity has to be same if the matrix is diagonalizable. But rather than that, I think solution could be easily got in this case. So if you take x2 out, this becomes minus 2/3 1 0, and if you take x3 out, you'll get 2/3 0 1 actually. So 2 eigenvectors are actually minus 2/3 1 0, then 2/3 0 1. Then let's also see the third eigenvector. What could be the third eigenvector? Ax is equal to lambda x. So what you will do is, I'll just tell you the process. So please calculate the second eigenvector because this is a repeating case, so I have told you this. But normally if you have lambda equal to 2, so lambda is equal to 2 is only one eigenvalue, so you'll get one eigenvector like this. Okay, you put that eigenvector here, you calculate this determinant. Okay, if this determinant is not 0, then definitely P inverse can exist and this matrix is diagonalizable. If A is diagonalizable, B is also diagonalizable. Okay, if this determinant is non-zero, then definitely both are, sorry, if that determinant is 0, then both are non-diagonalizable. Clear? Okay, fine. Did you understand how to do this? Fine. Okay, so checking whether diagonalizable or not depends just on this calculation. Okay, so here since it's a repeating eigenvalue, I have adjusted according to this because I have to put a summation so that I should take x2 as common. So I have adjusted this x2 and x3 in this particular forms. Okay, so when the eigenvalue is being repeated, then this is how you get the eigenvectors. If eigenvalue is not repeated, you just put the values and solve, you will get one eigenvector actually. So keep that eigenvector here, take the determinant. If that's 0, then non-diagonalizable. If that determinant is not 0, then it's diagonalizable. That's all. Clear? Fine. So let's see. So now let's go to the partial differential equations. Okay, so in partial, so I think I have covered each and everything in our syllabus. First order, second order, coefficients, method of variation of parameters, on skin, eigenvalue problem, power series solutions. Yeah, done. Okay, in partial you will see method of separation of variables, basically one dimensional heat and two dimensional Laplace equations. Okay, so classification of second order linear partial equations. So first of all we'll look into classifications. Classification, which many of you might have already seen. So second order linear. So normally if you take any second order linear partial differential equation, the things turns out to be something like a into dou square u by dou x square plus b into dou square u by dou x dou y plus c times of dou square u by dou y square plus d dou u by dou x e dou u by dou y plus f times of u plus some constant, okay, is equal to 0. So this is the function. Now normally there is something called canonical form, okay. So we take the characteristics of this x and y and we will do something, but right now what I just want to give you is, in this equation, if b square minus 4ac is less than 0, is negative, then this equation is elliptic in nature, okay. So this equation is basically elliptic in nature, okay. And b square minus 4ac is equal to 0, then we call this as parabolic, okay. We call this parabolic in nature. And if b square minus 4ac is greater than 0, then this is hyperbolic in nature, okay. So these are the three things. I'm not proving this as of now, but still you can just take this hyperbolic in nature. Clear? So we have thanks drawing with Prema. So sorry, what is the one more comment? Key is P is diagonalizable and Q is not. But actually, if you know both are diagonalizable or both are not, okay, if they are similar matrices, we can prove this mathematically. Clear? Maybe you are seeing the old key, but the updated one has what do you say? Depends. Both could be diagonalizable and both are not, maybe. Okay. Yeah, because it's a standard theorem in linear algebra that similar matrices will be diagonalizable together or non-diagonalizable together. Yeah, this is basically something called discriminant actually. So this is how we actually classify the partial differential equations. Okay, so there is a question on this which we will see now. So please solve this question. If the partial differential equation x plus 2 dou square y by dou x square plus 2x plus y dou square u by dou x dou y plus this minus 3y square dou u by dou y is equal to 0 is parabolic on the circle x minus a whole square plus y minus b whole square is equal to r square, then the value of a, b, r is dash. Come on, solve this question. I'm setting up some poll, maybe 90 seconds. 90 could be short. Okay, 120. Solve. What does it mean to be elliptic? The solution profiles. Okay, normally if we solve, the solution profiles are elliptic. That's it. Okay. Normally see conic sections. Okay, so the general equation of the conic section ax square plus 2hxy plus by square and all. Basically, whenever the partial differential equation is linear things can be superimposed, and these linear equations yield a linear solutions. So the nature of the equation is same as the solution. Okay, so basically the solutions, if you calculate for that equations, the solutions will resemble ellipses, parabolas, and hyperbolas. Okay. B is the answer. Maybe you can enter in the chat box. Okay. Okay, so let's see. So if you solve this, for this equation to be parabolic, this is coefficient of x square. Sometimes guys they put y here and x here. Okay, you have to be careful when you are deciding. So 2 times of x plus y whole square minus 4ac. This term should be 0 because it is parabolic. Okay, so this has to be 0 actually in this case. So if that has to be 0, then first of all, this 2 square and this 4 cancels up. X square plus y square plus 2xy minus 2 times of xy plus 2y minus x minus 2 is equal to 0 in this case. Okay, then clearly this 2xy term and this 2 times of xy gets cancelled. So you have x square minus 2 into minus x plus 2x y square, then that's it. Okay, so no y square term, no y square term is not there. Then after minus 2 into minus 2y, minus 2 into plus 2y, so minus 4y minus 2 into minus 2 plus 4 is equal to 0. So you can do this as x square plus 2x. You can adjust this as x plus 1 whole square plus y minus 2 whole square. Then this 4 is already added in this, so minus is equal to 1 of course. Okay, so this is the equation, correct? Because if you adjust that in terms of perfect squares, x plus 1 whole square plus y minus 2 whole square, so this term completely itself is y minus 2 whole square. So plus 1 which is missing, you add plus 1 on both sides, so that you can round up as square here. So if you compare this equation with this equation, you will have a is equal to minus 1, b is equal to 2 and r is equal to 1 of course. Okay, so this is the term. So basically this equation is parabolic at any point. Any values of x comma y which satisfies this will definitely make this equation parabolic, and the locus of points satisfies all this equation. This is nothing but cycle with center minus 1 comma 2 and radius is 1. Okay, so that's what a equal to minus 1, b equal to 2 and r is equal to 1. So let's see, minus 1 2 1, yeah, b is the correct answer, right? Yeah, because these two don't have a equal to minus 1 and this don't have b equal to 2. Yeah, this is wrong. Correct. B is the correct answer. Yes. One of you have done it. Hayat Abdullah. 80 seconds. Yeah. Good. Okay. So just this is the equation. You have to fit it in the form of a circle. That's all. Clear? So let's see what is the variable separable form and how do we apply it for the equations. Okay. So fine. So let's see. Variable separable form actually. Variable separable form. Okay, so basically whenever you have any partial differential equation, you have the solution u of x comma t as some function in terms of x into some function in terms of t of course. Okay, so this is how you can actually split. Okay, so u of x comma t is equal to x of x into t of t actually here. Okay, so this is called variable separable form. You can split the solution into variables. Okay, and if you calculate for the heat equation, guys, I'll basically tell you for the heat equation. Okay, for wave equation, for this Laplace equation, I'll tell you in complex numbers because it's quite easy there. Okay, so let's see, u of x comma t is equal to this. For 1D wave equation, heat equation is actually there. So 1D heat equation or basically diffusion equation, you take anything. The equation is of the form dou square t by dou x square. Okay, if you are familiar with the u, because in thermal we write this temperature is equal to 1 by alpha, which we are writing c square dou t by dou t actually. Okay, normally the c square is called 1 by alpha. Alpha is the thermal diffusivity, you might have seen. Okay, so this is the 1D wave equation with no heat generation. Okay, so if you solve this by taking this system and you have some boundary conditions, let's say temperature at x equal to 0 is some quantity a, then temperature at some other location at, let's say for example, there's a slab of length L, one dimensional rod. Okay, so there's a rod where there is no heat generation but transient state. Okay, so this is how we analyze the things, and let's say both ends of the rod are maintained at some particular case, and initially you have some temperature profile. X of 0 is equal to maybe some function f of x. So let's say the temperature of the initial temperatures of the rod at different locations is following this, and these are the boundary conditions. Okay, now when you have this solution, if you see, assuming this actually, okay, So this is the assumption. So basically we are assuming that we can split up the boundary conditions into these two parts. So if you split up, then you can have the final solution as u of x comma t. Normally this derivation I'm not doing. If you want, I'll post it, okay, in the Telegram channel, because I have the document. I've done it in many paid batch classes. So I'll show you. Is the wave equation and heat equation same? No. In wave equation, you also have a square here, dou square t by dou x square. Okay, it's a second order times and second order space and time. Okay, but heat equation is only second order space and first order time. Clear? Wave equation and heat is not same. In wave equation, you also, this is the second order derivative. Okay. Fine. So let's see. In this case, if you solve this, you will end up with C1 cos px plus C2 sin px into e power minus c square p square time t. This is what you will get actually here in this case. Okay. So I'm not showing the derivation because I think we have it in book in our notes somewhere. If let me open my classes. I've talked about this roughly around April, I guess. Yeah, March, April, during these times. Heat interactions, basic concepts, matrix algebra 2, probability, complex calculus, vector calculus, ODEs 5. So let's see. If this is ODE is 5, PD is 1. Yeah, maybe somewhere here I think I have taught. So let's see. In this case, yeah, this maybe I'll just show you. This is a partial differential equations 1 document. So PD is okay. So solving some basic PDEs and all. So these are all the first order. So let's say, yeah, here I think no, we are starting variable separable form introduction I have given. That's it. Okay. So some introduction, solutions, solving examples. Then no, not here. Because I'd like to show you, because otherwise, you know, many of you don't understand how it comes and why it comes. Okay, so second lecture of this. So PD is by direct integration, again solving techniques. So this is basically classification, conic sections. This is what I'm explaining the solutions. Okay, at that point. So wave equation. Okay, so if you see wave equation, the general wave equation in one dimensional is this. Okay, and here if you see the nature of the equations, heat equation is parabolic in nature. Okay, so you just calculate the nature of the equations. Laplace is elliptic. So solving of wave equation, you see basically this is a string. Okay, and if you do a bit of analysis, you will find out this is the equation. Now solving that equation, how we actually solve that. So this is the solving procedure which I have actually. So finally you will see at different conditions we get different solutions, and the one which physically fits the wave equation is this type of solution. Okay, so basically it's a Fourier expansion. So this is the actual solution. So in general, we have the summation where this constant Bn is got from the Fourier series solutions. And if you go for the heat equation, okay, yeah, this is D'Alembert solution. Fine. D'Alembert solution. Okay, I think here we have the wave equation maybe. So here if you have the wave equation, yeah, I'll show you here maybe. So solving of heat and Laplace. Okay, basically I've done in this. So heat equation, if you see, this is some example of wave equation which you are solving. Yeah, solving of heat equation. So you take the one dimensional rod. Okay, this is x equal to 0 and you go till x equal to L. So this is the one dimensional steady state heat, the unsteady heat equation. So we will assume this solution. Okay, so this is called the variable separable solution. Then you calculate dou u by dou t, and also you calculate dou square u by dou x square. Then you put in, and if you start simplifying things, you will eventually end up that the solution which actually fits is C1 cos, why these eliminations are there, further explanation is on the top, but C1 cos px plus C2 sin px into e power minus c square p square t, that is basically the solution of the heat equation. Okay, so heat transfer of 1D, you can see. So this is what we have done. So basically this is u of x comma t actually. So that's the solution which actually fits. Now C1, C2 constants and value of p. So there are 3 unknowns here, C1, C2 and also p is there. So to get this 3, we need the equations which we have. Of course, you see 1, 2 and also 3 actually. Okay, so because see, it's very simple guys. It's a second order space and first order time. Okay, so if you want to solve this equation, you need 2 boundary conditions because it's second order in space and 1 initial condition. Okay, because it's a first order in time. This is the initial condition, these 2 are the boundary conditions. Okay, so you can solve. That's it. Okay, so 3 equations, 3 unknowns, you can solve straight away. Clear? Did you understand? That's the solution actually, and these are the equations. Clear? They'll give you three conditions. Okay, 2 boundary conditions and 1 initial condition to solve. It can be initial condition maybe in terms of u, or maybe in case of wave equation it's velocity or the partial derivatives of u. Anything can be given, but the equations they'll give you for solving these 3 unknowns. Okay, so you have to solve. When do we use a Fourier series solutions? If the distribution is continuous. Okay, that's it. These are lengthy. Yeah, these are lengthy, but I think one question came last time. Not sure last time whether it's come or not. Yeah, this question. You see, they have given you this. Initial conditions are given, and u of x comma 0 is also given. This is the equation. C value is 1 in this case. That's it. Okay. So length of the rod is 0 to 2. So this is the equation where c equal to 1 and 0 equal to c equal to 1 and c is equal to 1. And okay, we'll solve this question. Fine. So shall we solve this question now? Enter the answer in integer e power pi square into this. So we'll solve this question. Anyway, people are asking. So let us solve this. Dou square. What is this temperature or velocity? What is given? Sorry, not this. Here, dou square u by dou x square, dou u by dou t. Okay, so the constant value is 1. Okay, so c is equal to 1 and the interval is 0 to 2, of course. So the solution that is with you, u of x comma t is c1 cos px plus c2 sin px into e to the power minus c square p square t is what you get. Okay, so e power minus c square p square t. So what are the conditions actually? Of course, x is 0 to 2. The initial conditions is u of the boundary conditions. First of all, u of 0 comma t is equal to u of 2 comma t is 0. So the boundaries are at these conditions. This is 0. Okay, and one initial condition, u of x comma 0 sin pi x. Okay, u of x comma 0 is sin pi x actually. Okay, so this is sin pi x actually in this case. So these are the 3 equations we have to solve. So this is one 3 equations and 3 constants. So let us start putting this u of 0 comma t equal to 0. So this implies if you put t, you put x is equal to 0 in these equations, it gives you 0 is equal to c1 plus, if you put x equal to 0, c2 term is 0 actually, into e power minus c square, c square is 1 anyway, c square is 1. So c square is, okay fine, let us leave that. So c square is 1 actually. So p square into time t, of course. Okay, now time t is not infinity actually, so that's why this is always some constant, but c1 is into 0 is actually 0. So this equation gives you c1 is equal to 0. Okay, this c1 is equal to 0 because this is, if this is 0, then definitely this is 0. C square is equal to 1 now. So e power minus p square t is 0 by default, then this solution is 0. It's a trivial solution. Okay, so that cannot happen. So e power minus p square t is not 0. So c1 is actually 0. Now coming to here, u of 2 comma t. So you substitute this is equal to 0. Then again the same story, 0 is equal to, c1 is 0 anyhow. So c2 sin px. Okay, so sin 2p, because x is equal to 2. So sin 2p into e power minus p square t again. Okay, so this is e power minus p square t, of course. So if e power minus p square t is not 0, then definitely I cannot say c2 is equal to 0, because if c1 is 0 and c2 is 0, then again it's a trivial solution. So sin 2p actually is equal to 0. So np is equal to n times of p is equal to, of course, 2p. Okay, so sin 2p is equal to 0. 2p is equal to 0. So 2p is going to be n pi. So p value is n pi by 2, of course. Okay, so p value is n pi by 2 in this case. Clear? So p value is n pi by 2 in this case. Okay, and also they have given one more question, u of x comma 0 is equal to sin pi x. Okay, so let's see, u of x comma 0 is equal to sin pi x. I think these two gives the same conditions. So this is sin pi x. So if you keep u of x comma 0 in this, when you put time t equal to 0, initial condition in this solution, if you put time t equal to 0, then definitely this value is 1. Okay, e power 0 is 1. So 1 into sin pi x is equal to, okay, so sin c2 sin px sin 2p. So sin 2p is n pi, of course. Okay, so sin 2 pi, sorry, just a minute, I have already substituted this here. So c1 is actually 0. So c2 of x comma 0, so c2 into sin px. So sin px n pi x by 2 into 1 actually. Okay, so this e power 0 is actually 1, so this is 1. So if you compare these two equations, clearly this c2 is 1 and n is equal to 2. Okay, so n is equal to 2, so this is the node where we are calculating n is equal to 2 and c2 is equal to 1, c1 is equal to 0 and p is equal to n pi by 2, so p is equal to pi, that's all. Okay, so p is equal to pi because if you put n equal to 2, this p turns out to be pi, of course. Okay, so the solution in this case is the diffusion equation or the wave heat equation u of x comma t. So c1 is 0, c2 is 1, of course, sin px, sin p. So p is actually, if you put n equal to 2, so this is pi x into e to the power minus c square. C square value is 1 in this equation, c is 1, so c square is 1, minus p square t. So p square is actually pi square t. This is what is the solution finally, because n is equal to 2, you have got it here. So if you put n equal to 2, then p is equal to pi, so p square t gives you e power minus pi square t actually here. Okay, so this is basically the solution, e power minus p square t minus pi square t. This is the solution. Okay, so final solution of this wave heat equation. Okay, so you got three boundary conditions and this is the solution actually. How the solution comes, that's basically from this notes which I have shown you just now. Okay, so anyway, this is the solution. Now let's see what they were asking in the question. U of 1 by 2 comma 1, then the value of e power pi square times u of 1 by 2 comma 1 minus u of 3 by 2 comma 1. So first of all, let's see, if you calculate u of, you calculate u of 1 by 2 comma 1. So if you calculate u of 1 by 2 comma 1, this gives you sin pi by 2, because x is equal to 1 by 2 gives sin pi by 2 into e power minus pi square. Okay, so this is e power minus pi square, because you put t equal to 1, this pi square t becomes just pi square. Okay, and you calculate u of 3 by 2 comma 1, sin 3 pi by 2 into e power minus pi square again. Okay, now clearly if you shift this minus pi square to the right hand side, this expression, if you do first equation minus second equation, you will get e power pi square into, okay, e power pi square into u of half comma 1 minus u of 3 by 2 comma 1 actually. Okay, so this value is nothing but sin pi by 2 minus sin 3 pi by 2, of course. Okay, so this is sin 3 pi by 2, so this value is 2 and 2 is the answer actually. Okay, I think entire integer is given now, so entire integer, so 2 is the correct answer because of this simple thing. Okay, see, it's not a lengthy problem actually. C1, C2, P values are calculated, then just calculate the functions, that's it. Okay, clear to all of you? Okay, so this is basically the solution of heat equation, and depending on the conditions, see, it's a second order spatial and first order time. Okay, so you need two boundaries and one initial to solve this. That's what they have given you, you can solve. Okay, clear? No need of calculate also, simple question, right? But anyway, yeah, nice question. Okay, okay, so if wave equation is given, sorry, heat equation is given, this is how you solve. Wave I think not is in the syllabus, because when I've seen this, I think wave I is not. Okay, 1D heat equation and 2D Laplace, that's it. Okay, but Laplace equations are very easy to solve. Okay, which why you will come to know. Okay, any real part or imaginary part of a analytic function solves Laplace equation. Okay, which is very useful result in potential flows also, so which we will see next in complex numbers. Okay guys, yep. Okay, fine. So this is a solution actually for this wave equation, sorry, heat equation. Okay, so let's see. So Laplace, again I told you I'll deal it in the, I think this is heat equation, the same story. Okay, you can calculate u of x comma 0 is given, u of 0 and 0 is pi, so c square is equal to 2 this time, You please solve this question. Okay, I'm giving you as homework. Maybe you can try this question. Same story again. Okay, homework. They have given you u of x comma 0, okay, and 0 comma t and pi of comma t is there. So u of pi by 2 comma ln 5. That's it. Okay, so you can just solve this question as your homework. This is a case with c square is equal to 2. Conditions are same, obviously 0 to pi, and at some value of x comma t you want what is the temperature, or basically what is u. U is some function, so what is the value of u. Okay, so solvable, right? So let's go to the next module, which is complex calculus. Okay, so till now we have finished only one module, which is differential equations, but all the extra syllabus and partial differential equations with much clarity. Okay, fine. Clear? So now let's see complex calculus. Complex syllabus is slightly less, okay, because you see, even if you open the syllabus sheet, you'll see only this part is there. Complex numbers, argand plane, polar representation of complex numbers, then de Moivre's theorem, analytic functions, and 𝐂𝐤𝐬 equations. You know from complex numbers to representation on polar plane, correct? You know up to this. You need 5 minutes break, okay? 5 minutes break actually. So fine, I'm happy to give breaks. 5 minutes break actually, okay? Five minutes break, okay? So it's 9:47. At 9:47, okay? So 48, 49, 50, 51, 52 plus 1, 9:53. Okay, yeah. Why are you laughing here? I'm little weak in maths, so counting. Okay, don't laugh, please. Bye. Join back at 5 minutes, huh? back. Okay. So shall we start? Fed up with so much maths. Yeah, okay. So we shall start, continue. Chalo. Let's start on time. Yeah, I'll always be on time. Okay. Only for official things, not for unofficial things. You call me for a party, I'll be late by half an hour, 45 minutes, 1 hour. Depends. Okay. Fine. So yeah, complex calculus we are starting. So firstly, you know, this okay. So you know, if you have xy axis, okay, so let's see, if you have your x and y axis, clear? So horizon x y axis, for example. Then if you have any point, okay, so x comma y is somewhere here, then you know that fine. So if this distance is r, for example, and this distance is theta, then you know we can write this as r sin theta, r cos theta, of course. Okay, and this is x and this is y. Now if you want to write any complex number, this I actually performs rotation by 90 degrees. Okay, like for example, you see 5 will be on this axis. If you multiply I to that, I times of 5 will be somewhere here, it rotates by 90. Okay, and we'll see what is the significance of I in much detail in today's class. Okay, do you want me to teach kinematics for 5 minutes using complex numbers? Complex numbers are very powerful. Okay, anyhow, potential flows I'll teach you tomorrow, but for the time being I'll teach you some part of kinematics. Okay, so just for 5 minutes. Okay, so anyway, let's see, this is by 90 degrees. So you know x is equal to r cos theta and y is equal to r sin theta. So if you want to replace z is equal to r times of cos theta plus I into sin theta, because this z is replaced with I multiplication to y actually. So plus I times of sin theta. So r into e to the power I theta actually. Okay, so r into e to the power I theta. How this cos sin theta plus, do anyone of you know why this is equal? Do anyone of you know why these two are equal? What is the connection between exponential and trigonometric? What is the relation between these two functions? Okay, so very simple thing actually. In last class, when I am defining Taylor series, I have given you sin x and cos x expressions. Okay, you remember cos x is 1 minus x squared by 2 factorial plus x power 4 by 4 factorial and so on. Sin theta is x minus x cubed by 3 factorial plus x power 5 by 5 factorial and so on. Okay, if you expand this Taylor series of e power x, 1 plus I theta by 1 factorial plus I theta whole square by 2 factorial cube by 3 factorial and so on. Okay, so what is I square? Minus 1, correct? I cube minus I power 4 1, I power 1 I, and this loop again repeats. If you multiply I power 4 I power 5, this can be written as I power 4 into I, which is I again, because I power 4 is 1. So if you apply I twice, it rotates by 180, correct? You know, if you have x equal to 1, for example, if you apply 1 I, it rotates by 90. if you apply one more I into I square, this turns 1 more 90 and this 0.1 becomes -1. Okay, that's why I square is equal to -1 actually. If you simplify this, you know, let me collect all real terms. 1, then this has imaginary part, this don't have imaginary part because I square can be written as -1. So minus theta square by 2 factorial plus, again this don't have imaginary part, so theta power 4 by 4 factorial and so on, this goes on, plus if you take I common from other parts, here we have theta by 1 factorial which is theta, I cube is minus I, so if you have taken I already, then this is minus theta cube by 3 factorial plus and so on. Then you can clearly sense this is basically your sin x. This fellow don't want to move from here, yeah, good boy. So this is actually called sin theta, Taylor series expression, and this is of course cos theta. Okay, so that's how this e power I theta can be expressed as cos theta plus I times of sin theta like this. So this cos plus I sin can be replaced as z is equal to r into e power I theta. Clear? Z is equal to r into e power I theta actually. Okay, so this is how basically we use this e power I theta form. So this is how basically you represent a complex number on a modulus plane. This plane is normally called the complex plane, or it's also called argand plane. So it's also called argand plane or complex plane actually. So this is how basically we represent complex numbers on a basically this argand plane actually. Now let's see, if you have complex numbers, the two complex numbers, then we define this r and theta. We have got this complex number r is equal to z equal to r into e power I theta. This r is called modulus of the complex number. Modulus of complex number, and it's denoted with r is equal to mod z. Okay, so this is how we denote this. Okay, and this you can see this is equal to r e power I theta of course. So yeah, that's it. Okay, so we can see r value is equal to, so what is r? Of course r is the distance from the pole, this is called pole. Okay, so if that's called pole, then from that point, this point is the distance of r, and from triangles, right angle triangle, you can calculate this r is equal to root of x square plus y square. Okay, so this square root of r is equal to x square plus y square. And what about theta? Tan inverse y by x, and this is normally denoted with argument of z. Okay, argument of z actually here. Now when you have two complex numbers, okay, so you have two complex numbers, let's see. You have two complex numbers, z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. Then you can write this as z1 plus z2 is equal to, you add the real parts plus I times of, you add the imaginary parts, which is quite often very simple, because if you take vectors, two vectors, okay, let's say for example, if you have xy plane, then if you have two vectors, okay, so let's say this is a complex number, first complex number, and maybe this is the second complex number. Now since this complex numbers are free, I can shift this here, so the vector closing will actually give you the resultant. Okay, so it's like the vector addition. So this is z1 and this is z2 of course. Okay, and this is r1 r2, which are the distances. So 0 real part of z and imaginary part of z actually here. Okay, so imaginary part of z of course. Now let's see, if this is plus I times of y1 plus y2 actually, then z1 into z2, if you take z1 into z2, we get r1 e power I theta 1, r2 e power I theta 2. So this can be written as r1 into r2 into e power I times of theta 1 plus theta 2, because product of a power m into a power n is a power m plus n. So when you multiply two complex numbers, the argument of the two complex numbers is equal to sum of the arguments, and modulus is equal to product of the modulus values. Okay, and z1 by z2. So let's see, if you have z1 divided by z2 actually in this case, okay, so this gives you r1 by r2 e to the power I times of theta 1 minus theta 2. So all this is some basic stuff which you might have seen n number of times in your college and all. So also certain properties like mod z1 plus z2 and so on zn is less than or equal to mod z1 plus mod z2 and so on plus mod Zn clearly, because here each quantity is positive, but here some part of the imaginary part or some part of the real part can get cancelled actually. Okay, so because of this, and also mod Z1 minus Z2 is actually always greater than or equal to mod Z1 minus mod Z2, of course. Okay, so this is always greater or than equal to normally. So these are some basic fundamental operations. Now if you go for one important thing, which is the de Moivre's theorem, which is basically in the syllabus. Okay, so you see complex numbers, argument plane, polar representation of complex numbers. Till here you know this. Okay, so let's go to the de Moivre's theorem. De Moivre's theorem. So what does this de Moivre's theorem tells you? Normally if Z is equal to cos theta plus I sin theta, which normally called cis theta. Okay, so you call this cis theta. Then for n belongs to n, if n is an integer, okay, so if n is an integer, let's say n is an integer, positive integer, then cis theta whole power n is actually equal to cis n theta, because anyhow you know e power I theta whole power n is equal to e power I n theta, that's all. Okay, so you see which is cis theta, of course. Okay, so that's it. Secondly, cis theta power p by q is equal to one of the values of this. Okay, so in this case this is equal to cis 2n plus 1 theta into p by q actually. Okay, so cis, because you have 2n, cis theta is also same as cis n pi plus theta. So let's just a minute. If you have this cis theta, then cis of, because cis theta is same as cis 2 pi theta plus theta, so 2 pi plus 1 into p by q. Yeah, this is what you have actually, cis 2 pi plus 1 into theta into p by q, where q is equal to 0, sorry not 0, 1, 2, 3 and so on till p minus 1, of course. Okay, so this is the values of q actually. So these are the de Moivre's theorem. Normally you might have seen something sometimes it's called cube root of unity. Okay, so cube root of unity, cube root of unity. Okay, like for example you see x is equal to cube root of 1. If I want this cube root of unity, I can frame this equation as x cube minus 1 is equal to 0. Okay, so x cube minus 1 is equal to 0. So if you start searching roots of this equation, you have 1 real and 2 imaginary roots, because total this equation would have 3 roots. Okay, you cannot keep on writing 1 comma 1 comma 1. Okay, so basically in real axis you'll get x equal to 1 as one root and 2 imaginary roots. The roots are something like z is equal to 1 is, sorry, x is equal to 1, let's say x is equal to 1, and x is equal to minus 1 by 2 plus I times square root of 3 by 2. Normally this is mentioned with omega, and x another root is going to be minus I root 3 by 2, which is omega square. I think all of you might have seen all this stuff, so I'm just going quickly. Okay, so this one omega and omega square cube roots. Now clearly you know if you do the product sum of these two, okay, 1 plus omega square is equal to, there is no x square term, so definitely it could be 0. Even if you check, if complex parts gets cancelled, and this 1 minus half also gets cancelled, so definitely this sum of cube roots of unity is 0 clearly. Okay, and product of the roots is 1, omega cube is equal to 1, of course. Okay, you know normally for any polynomial the sum of the roots is minus of coefficient, second coefficient by first coefficient, and product is last coefficient by first coefficient depending on the minus sign. Okay, so these are the things which we talk about in de Moivre's theorem. Now coming to complex functions, see, which is also important for our potential flow tomorrow. Let's see here. Complex functions. So you have a function f of z is equal to u of x comma y plus I times of v of x comma y actually. Okay, so if you have this complex function, then 0, what is 0? This one, that's 0. Okay, so let's see if you have this function, for example. Okay, so what are these analytic functions? Okay, so let's see. If you take these functions u of x comma y and v of x comma y at z is equal to z0 at some point, practically analyticity means you have this complex plane And if you are talking about a function at this point z0, so this is a point z0, then if you want to say whether a function is analytic at this point, okay, so analytic at that point, the function should be differentiable at this point, means these two functions should be differentiable at this point and also at every point in some neighborhood. Okay, so you take some small neighborhood, so within that neighborhood at every point this function should hold actually. Okay, so let's see, we'll talk one thing here, but practically checking whether the function is differentiable or not at all these points is not very easy game. Okay, so it's slightly a tougher game actually. So let's see what we can have at z is equal to z0. If dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y are continuous. Second, dou u by dou y or dou u by dou x is equal to dou v by dou y and dou u by dou y is equal to minus dou v by dou x actually here. Clear? So these are called the Ch-Riemann conditions actually, which are very powerful and very useful actually. Okay, now let's see what we take the advantage of these things. Okay, so if these two are happening, then we say f of z is analytic at z is equal to z0 of course. Okay, so at the point z equal to z0, if all these equations are getting satisfied and if these functions are continuous, then definitely we say that this function is actually analytic. Now let's see, if you see these equations in polar form, normally these are called CR equations. So CR equations in polar form. So u is function of r comma theta. So first thing is dou u by dou r is equal to 1 by r times dou v by dou theta, and dou u by dou theta is equal to minus r times dou v by dou r actually. Okay, so these are the Cauchy-Riemann equations in polar form actually. Okay, so all these things can be derived. Okay, there's nothing complicated, but just it takes some time, that's all. Okay, so because we have cost some good time, so I'm just giving you that. Okay, then u and v are complex conjugates to each other. Yes, not complex conjugates, but I'll say harmonic conjugates. Okay, then both u and v, properties of analytic functions. Let's see properties of analytic functions. I would like to give this properties of analytic functions. Okay, so if you have these properties of analytic functions, then the first property is both u and v are harmonic functions. Harmonic functions. What is the meaning of this? Harmonic functions, they satisfy Laplace equations. Equal to 0 actually. Okay, so both these are harmonics to each other, and that's why one is called the harmonic conjugate of another. Clear? So is this clear to all of you till this point? Yes or no? I can actually prove these things, but right now I'm not doing it because it's just a revision, so I'm just going through the things quickly. Okay, fine. U and v are complex harmonic conjugates to each other. Okay, so is this fine? So type in the chat box. Is this clear to all of you? Okay, fine. Now let's see one more thing. The curves of u of x comma y is equal to constant and v of x comma y is equal to constant cut each other or intersect orthogonally. So what does this mean? If you have, for example, lines of constant u, so these are lines of u is equal to c1, u of x comma y is equal to c2, things like this. Okay, and if you have I mean, okay, v. Okay, so if you have v like this, v of x comma y is equal to some constant a1, v of x comma y is equal to a2, so v is equal to a3, a4, a5, things like this. Then you see at any point of intersection, this angle of intersection will be 90, of course. Okay, you take any point of intersection, this point of at this point of intersections, the curves cut each other perpendicularly. Clear? Okay, so these curves actually cut each other perpendicularly. Okay, then let's see, v of x comma y is equal to constant, and these are the things that we have. Okay, now one thing that people ask you generally is, when you have u, how to calculate v, or maybe when you have v, how to calculate u actually. Okay, so that's the important point. One last thing, finding harmonic conjugates. So how do we do this? Okay, so finding harmonic conjugate. Okay, so how we do this? So let's see, if u is given, how we calculate v? Or maybe v is given, how we calculate u? Okay, so let's see, first of all, f of z is equal to u plus iv. Okay, now if you partially differentiate this with respect to x, you'll get f dash of z into dou z by dou x is equal to dou u by dou x plus I times of dou v by dou x actually here. Okay, then this term is 1 anyhow, because z is equal to x plus iy. If you differentiate partially, you'll get 1. So f dash of z is equal to dou u by dou x plus I times of dou v by dou x. Now let's see, this function is analytic. Okay, that's why you're calling harmonic conjugates. Okay, so if this function is analytic, then this dou v by dou x can be replaced with minus dou u by dou y. Okay, dou u by dou x minus I times of dou u by dou y. If v is given, then you will replace this dou u by dou x with dou v by dou y, such that finally you will be able to calculate what is this expression. Okay, let's say for example, if I have given you u, then you can calculate this complete this expression. Okay, if v is given, you will replace this dou u by dou x with dou u by dou y, and you will calculate that. So we apply something called Milne-Thomson method. Milne-Thomson method. So we place x by z and y by 0 actually. Okay, so in this Milne-Thomson method, what we do is, we'll replace x with z and we'll replace y with 0. Then you will end up with f dash of z is equal to some function of z actually. You'll multiply dz on both sides and you will integrate. That's it. Okay, we'll solve one example. So this gives you the function. So this gives you some function f of z is equal to some constant, complex constant. So this is how you get the function. So once you get the function, you can even compare the real part and imaginary part. Clear? Okay, so these are the things. Basically it's a short module, actually the module in which marks are generally easily obtained, but anyway, so this is the module. Okay, so representation of complex numbers actually, then after de Moivre's, then complex functions, analytic functions, and properties of analytic functions. Okay, so let's see. So I'll give you some time. So solve this integration. Given that I is equal to square root of minus 1, the value of limit z tends to e power pi I by 3, z cube plus 1 by z power 4 plus z square plus 1 actually. Come on, do this. I'm giving you poll, single choice. I'll give you 150 seconds. Start. Fine. So meanwhile you please try to solve. I'll also continue with this. Okay. So let's see. Limit z tends to e power I pi I by 3, of course. Okay. So this e power pi I by 3 z cube plus 1 by z power 4 plus z square plus 1 actually. Okay. Now if you substitute this directly, we have e power pi I by 3 whole cube gives you e power pi I, because de Moivre's theorem tells you cis theta power n. For n is an integer, this is cis n theta actually. Okay. So e power pi I plus 1 divided by e power 4 pi I by 3 plus e power 2 pi I by 3 plus 1 actually. Okay. So clearly e power 2 pi by 3 is cos 120 plus I sin 120, 1 by minus 1 by 2 plus I root 3 by 2. This is minus 1 by 2 minus I root 3 by 2, and this is plus 1. So this gives you a 0 by 0 form directly. Okay. So this gives you a 0 by 0 form. Now let's apply L'Hospital. E power pi I by 3 3z square divided by 4z cube plus 2z actually. Okay. So we can cancel 1z because z is non-zero. So this is square and this is z. So limit z tends to e power pi I by 3 3z divided by 4z square plus 2. So if you simplify this, let's see what we'll get. 3z, so 3 times of e power pi I by 3. So e power pi I by 3 pi I by 3 divided by 4 times of e power 2 pi I by 3 plus 2 actually. Okay. So let us simplify the values. 3 into e power pi I by 3 cos 60 1 by 2 plus I times of sin 60 root 3 by 2 divided by 4 times of, this is 120, so cos 120 minus 1 by 2 plus I times root 3 by 2 plus 2 clearly. Okay. Then of course you can see this cancels 2 times, and then 2 into minus 1 and plus 2, this 2 and this minus 1 cancels actually. Then we have 2 times of root 3, so this root 3 can cancel this square root of 3 times, and then we have root 3 by 4 times of 1 by 2 plus I times root 3 by 2 of course. Okay. So root 3 by 4 times of I think 1 2 is getting eliminated, right? So let's see, 1 2 is also getting eliminated here of course. So let's see, 4 into, so we have 4 times, so we have 4 into I root 3 by 2, but anyway this minus 2 and this 2 gets eliminated. So 2 root 3 is what you have actually in this case. Okay. So 2 root 3, yes, then 2 into 2 is 4, correct. So root 3 by 4, then root 3 by 4, then you have an I of course. Okay. So this I is also there, so 1 by I gives you minus I plus I gets cancelled, root 3 into root 3 is 3 by 4. Okay. So this is what you get, 3 by 4 minus I root 3 by 4, option B. Okay. So B is the correct answer in this case, right? Because you see this minus I comes out, so minus I times root 3 by 4. Yeah, definitely this is not plus root 3 by 4. Okay. Because root 3 there is an I in the denominator. Okay. So that I will actually change this. So B is of course the correct answer. Yeah, some of you have answered it, unknown. Okay, 122 seconds, good. Let's see one more question before we go to the next chapter. So let us solve this question. I'm giving again time, some time I'll give you. So 150 seconds again, start. Z equal to x plus I y are real numbers, B be the set of complex numbers, then the function f of z is equal to this, where u of x comma y is equal to xy cube minus yx cube, and v of x comma y is equal to this. If f dash of z denotes the derivative of z, then what is this functions actually? So let's solve. Whenever they give you modulus of z and all, don't get panicked, just apply x comma y. You can get the answers easily. Okay. So just try with xy, because limits, you know how to calculate the 2-dimensional limits. It's simple. Okay, so anyway, I'll also start solving. So let's see. So first of all, you know, f of z is equal to u plus iv. If you differentiate this partially with respect to x, f dash of z into dou z by dou x is equal to dou u by dou x plus I times of dou v by dou x actually. Okay, so let's see. Anyway, you know, this value is 1. So your f dash of z is equal to dou u by dou x. So dou u by dou x in this case gives you y cube minus 3x square y. Okay, so 3x square y plus I into dou v by dou x. So dou v by dou x gives you x cube plus this dou v by dou x, this term goes to 0. So we have plus minus, of course, so minus 3 by 2 y square into 2x actually. Okay, so 3 by 2 into y square 2x. So 2 and 2 gets cancelled, of course. Okay, because if you are differentiating with respect to x partially, this is what you will get. If you differentiate with respect to x partially, 3x square y is what you are getting. Okay, so this gives you y cube minus 3x square y plus ix cube minus I times of 3xy square minus I times of 3xy square actually here. So this expression is nothing but, okay, so you can understand carefully, y cube is a real number and plus ix cube. So this is of the form x cube plus y cube of that kind. So f dash of z is equal to, if you replace x with z and y with 0 in this case, because partially things are same, so all these 3 terms will go actually. So all these 3 terms will go. So if you have, we have I times of z cube actually, that's it. Okay, so f dash of z is equal to I times of z cube actually. Now let's see, if you for example replace any of these constants, minus 1 plus I. Okay, so if z is equal to minus 1 plus I whole cube, then let's see, I times of a cube plus b cube plus 3ab square. Okay, so plus 3ab square, so this is 3 plus 3ab square minus 3ab. Okay, so minus 3ab is 3a square b is what you have. So this becomes 3I in that case, I guess, right? Just a minute, we want to take the modulus, right? Yeah, fine. So this is the case. Then if you simplify, I into a cube plus b cube is actually plus I cube, so which is minus I, plus 3a square b, so 3a square b, so plus 3a square b plus 3ab square, so this becomes plus 3 actually. Okay, so this becomes plus 3 in this case. So this becomes plus 3. Okay, now let's see, 3i minus 2i, we have 2i, and 3 minus 1, 2 of course. Okay, so I times of 2 plus 2i, 2 plus 2i actually, so 2 into I plus I minus 1 actually. Okay, so 2 into I minus 1, so square root of 2 square plus 2 square, which is 8 root 8. Okay, so f dash of z is equal to modulus of this f dash of z is equal to modulus of all these things. So mod of all these things is root 8. So if you put a square, f dash of minus 1 plus I modulus square is equal to 8. That's it. Okay, so 8 is the correct answer in this case. Okay, so C, yeah, of course C is the correct answer. Let's see how many of you have done it. Yeah, some of you have done it. Unknown 132.08 seconds. Okay, so these are basically the things. Now let's move on to sequences and series, the most important part of the case. Okay, so sequences and series. So in the syllabus again we have only the positive term series, so series of non-negative terms, I guess that's what they have given you. So let's see, all this is done. Yeah, sequence and series is somewhere here basically in the calculus, this part. Convergence of sequences and series, basically tests of convergence. Okay, so in that we'll see tests of convergence, ratio, root and integral test. Then power series is basically what we have seen. Taylor series is already done. Fourier series of functions with period 2 pi. Okay, so let's see, if you have a sequence, for example this is sequence. Okay, so this is convergence of sequences and series. Okay, fine. So let's see, you have convergence of sequence actually here. So this is sequence. Now coming to series, these are connected by some plus or minus signs and so on. This is actually a series. Okay, so in sequence we have only certain numbers. Okay, so data khatam ho gaya tha. Fine. Okay, only this is the major module. After this probability we have the same syllabus. Of course I'll just show you 1-2 important examples, and then in numerical methods, everything is same as mechanical, but only Lagrange's interpolation and Newton's interpolation are there, so that we will discuss. Okay, so let's see, if you have these sequences and series of course here, then series of non-negative terms. Series of non-negative terms. So if you have the positive terms like u1, u2 and so on, un plus 1 and so on. Now when we say a series is actually convergent, okay, so first of all, if you go for the root test, it's normally called D'Alembert's ratio test. First we'll go for D'Alembert's ratio test. D'Alembert's ratio test actually. So in this, what we'll do is limit n tends to infinity mod un plus 1 by un. This is what we'll calculate actually in this case. Okay, so limit n tends to infinity un plus 1 by un. This value is actually lambda. Okay, so if this lambda is unique, okay, so if lambda is less than 1, series converges. Series converges. Okay, and if lambda is greater than 1, then definitely series diverges actually in this case. Okay, so series will actually diverge. So series diverges, and here you can see if lambda equal to 1, exactly 1, we say test fails. We say ratio test fails. This ratio test is the most important out of all the things. Okay, so ratio test fails actually. Clear? So this ratio test is basically decided by these terms, and majority of the PYQs in sequence and series is based on D'Alembert's ratio test actually. Okay, now coming to Cauchy's root test. Cauchy's root test, then again you see if you have limit n tends to infinity un nth term power 1 by n. Okay, if you calculate this, if this is lambda, then if this lambda is actually finite, okay, finite, okay, then we say series is convergent. Series is convergent. Okay, and if this lambda is not finite, like for example you see this can have terms like it can go to something like maybe you know, infinity and all few times. Okay, so in such cases lambda is greater than 1, let's say here lambda is less than 1, series converges, and lambda greater than 1, again this series diverges. Okay, series actually diverges, and again for lambda equal to 1, this root test fails. So these two are just based on the nth term. Okay, but this is basically depending on the ratio of both the terms, and we also have the integral test. Okay, so if you have this integral test for the sequence of, for the series of positive terms, then what we do is we calculate integral 1 to infinity 1 by un dx. Okay, this in place of n will replace x actually, and we will start solving the question. Okay, so un dx, so replace n with x actually. Okay, to solve with x. Now if this is finite, then series u1 plus u2 and so on plus un, this will actually converge in this case. Okay, so this will of course converge in this case here. Clear? So this will actually converge. So based on that only we have all the things. Okay, so let's see this question. Solution. Let's see. F of t be a real valued function, differentiable function on -1, 1 such that f of 0 is equal to 0. Okay, so you have this function f of 0 is equal to 0. Now let's see modulus of df by dt less than 1 for 0 less than t less than 1 actually. Okay, so let's see here, mod df by dt is actually less than 1, and whenever 0 is less than t less than 1 of course. Okay, now if you split this modulus, we have -1 less than df by dt less than 1 actually. So minus dt less than okay, so minus dt less than df less than dt actually. Okay, so if you integrate this on all sides, okay, and t is positive, so minus t less than minus t plus constant less than f is less than t of course. Okay, so let's say minus t less than f less than minus t less than f less than t, of course. Okay, so this is what you get. Now t is changing only from 0 to 1. That means you can see the maximum whenever this t is positive, so negative of that number is also equal to positive number. So f of t is basically t. That's what. Okay, so this is what you can observe from here. So f of t, since it is normally called the sandwich theorem, okay, it's called the sandwich theorem, where a value is in between these two minus signs, but this value t and minus t is same because this t is defined only between 0 and 1 actually here. Okay, okay, thank you Naveen, yeah. Okay, so f of t is equal to t. Now let's see if you have this series sigma n equal to 1 to infinity, 0 to infinity, of course, f of 0.5 power n. Okay, so 0.5 power n, you see f of t is basically equal to t. Okay, so it's less than t actually. Okay, so sorry, this should be less than t. Okay, so this should be less than t. Yeah, it is less than t, of course. Okay, because less than sign is there. So sigma n equal to 0 to infinity, equal to's are not there. Okay, that's why f of 0.5 power n. So this gives you 1 plus 0.5. It is less than. Okay, so this expression is actually less than 1 plus 0.5 plus 0.5 whole square and so on. Now this is a geometric progression clearly, and if you calculate this value is nothing but 2. Okay, so this value is 2. A by 1 minus r, if you do, then this is just 2, of course. Okay, so clearly this sequence or this is sigma n is equal to 0 to infinity, f of 0.5 power n is actually less than 2. So this series is actually something which is less than 2, and whenever t is positive, this series is definitely greater than 0 also. So that means this series is bounded between 0 and 2. It also will have some finite value. Okay, so series is convergent, it's also bounded. Clear? So converges absolutely. Yeah, it converges absolutely, of course. Okay, so let's see one more question based on the root test. I think we have, yeah, the radius of convergence. The radius of convergence of the following power series. Okay, so what is the power series convergence actually? Now you see, if you calculate this ratio test, limit n tends to infinity, un plus 1 by un. So this has to be less than 1 for the convergence. Okay, so for convergence of the test, series, actually this value should be less than 1. Now if you simplify this, modulus of un plus 1, x minus 3 power n plus 1 by 3 power n plus 1 into n plus 1 factorial into un will turn out to be 3n n factorial by x minus 3 power n. So this term should be less than 1 for convergent. For convergent actually. Okay, so let's see if you simplify this 3 power n will make a 3 here. This n factorial will eliminate this as n plus 1, and this x minus 3 power n will eliminate this and will have x minus 3 actually. Okay, so this is what you get. Now if you see limit n tends to infinity, so this limit is with respect to x, so x minus 3 into limit n tends to infinity 1 by this 3 is also here, maybe 3 you pull out, by 1 by n plus 1. So we have to observe for which values of x this equation is actually finite. Okay, so this equation is this inequality is satisfied. So here if you see, this term is actually 0, yes or no? So this term is equal to 0. If this term is equal to 0, whatever might be the value of x, then definitely this value is always less than 1. Okay, so this 0 less than 1 is always valid, So whatever the value of x you take, this is always converges, so it has infinite convergence. So how to find which test to apply for a problem is if it's a positive series. Okay, like say for example you have a power n. Okay, then if you have this factorials and all, just go with the ratio test. Okay, so D'Alembert's ratio test could be good enough. Clear? And normally in case of power series, you can always go with ratio. I mean this, ratio test, D'Alembert's ratio test. Okay, so this is infinite in this case. So let's go to one more question if possible. Fourier series. Okay, so Fourier series, you know, normally if we have an interval, f of x is periodic, and if the things are defined in the interval alpha plus 2c. Okay, so in this interval of 2c actually, then this value f of x can be expanded in series as a0 by 2 n equal to 1 to infinity an cos n pi x by c plus n equal to 1 to infinity bn sin n pi x by c actually here. Okay, so sin n pi x by c, where a0 is equal to 1 by c times of alpha to alpha plus 2c f of x dx, an is 1 by c alpha to alpha plus 2c f of x cos n pi x by c dx, and bn is 1 by c integral alpha to alpha plus 2c f of x sin n pi x by c dx. This is what we have actually. Okay, now if it's a interval of 2 pi, that means if, for example, if alpha is 0, c should be pi. Okay, the gap between 2c value is equal to 2 pi, that's it. Okay, so in an interval of 2 pi, so c is equal to pi, that's it. Okay, so if you put c equal to pi in this, then this pi and c gets cancelled, a1 cos n x, bn sin n x, then all these values become alpha to alpha plus 2 pi, alpha to alpha plus 2 pi, f of x cos n x, and these terms. Okay, so let's see this question. If you see, for the Fourier series expansion, for the Fourier series of the periodic function, f of x is equal to mod x minus 1 less than x less than 1, where f of x plus 2 is equal to f of 2, because period is 2, of course. Okay, so in this range, in the range of minus 1 to 1, f of minus 1 is same as f of 1, so it's a period of 2 actually, period of 2 in this interval. Okay, so period of 2 anyway, minus 1 to 1, so we can write this as minus 1 to 1 plus 1, of course. Okay, so minus 1 to minus 1 plus 2 times of 1, that's what. Okay, so it's an interval of 2 actually. So this Fourier series expansion is given by this expression. So let's see, f of x, which is mod x, is equal to half minus 1 by 2 minus, because mod x is the function, so mod x is expressed as 1 by 2 times of summation 4, you take out pi square, also you take out 4 by pi square times 4 by pi square times, okay, 1 by 2 minus 4 by pi square times, then cos 2n minus 1 pi x divided by 2n minus 1 whole square. Okay, so if you put n equal to 1, this is cos pi x, which is minus 1, divided by, if you put n equal to 1, this is 1, of course. Okay, plus when you put n equal to 2 here, this is cos 3 pi. Okay, so cos 3 pi is there, cos 3 pi divided by, when you put n equal to 2 here, 4 minus 1 3 square, so cos 3 pi is again cos 2 pi is 1, so cos 3 pi is minus 1 divided by 3 square plus minus 1 divided by 5 square, and so on. This series actually goes on. If you keep n equal to 0, 1, 2, 3 and values like that, then this is the value. Okay, now let's see at this point. Okay, using the above sum, actually, cos 2 pi into x is also there. Okay, so this complete thing multiplied with x, I guess. Okay, yeah, x is there in each and every term. So if you put x equal to 1, because you just want to get this expression, so you put x equal to 1, so put x equal to 1 on both sides of this equation, then you will end up with half, if you shift 1 minus half. Okay, so 1 minus half is half, is equal to minus 4 by pi square, so you can cancel this minus with all the minus signs, so 4 by pi square times 1 plus 1 by 3 square plus 1 by 5 square, and so on, things like this. Okay, then this summation is equal to pi square by 8, summation 1 by n square 1 by 2n minus 1 square, n equal to 1 to infinity is equal to pi square by 8, of course. Okay, so this is pi square by 8 in this case. Okay, so which is given in option C, pi square by 8 is the correct answer. Okay, yeah, pi square by 8 is the correct answer actually in this case. Fine, so let's see, one more question is there, 2 more questions are there actually. So let us solve this question. You have power 2n and factorial, so let's solve this. Solution, so summation n equal to 0 to infinity z power 2n by 2n factorial here. Okay, so again it's a positive series, so definitely we can go with the ratio test. Let us see the ratio test, D'Alembert's ratio test. This tells you limit n tends to infinity z power 2n plus 1 by 2 times of n plus 1 factorial, okay, 2 times of n plus 1 factorial into 2n factorial divided by z power 2n actually. So this limit has to be less than 1 for convergence, okay. So for convergence this has to be less than 1 for convergence, okay. So this has to be less than 1 for convergence. So if you simplify this, let's see, this is 2n plus 2 factorial, okay. So this is 2n plus 2. If I simplify this, you know, 2 times of n plus 1 is nothing but 2n plus 2 factorial. 2n plus 2 factorial. Now you can understand something. Let's see, this will actually keeps this z square, okay. Now if you pull the z square out, z square into mod z square, of course, or mod z whole square, limit n tends to infinity, 2n factorial by 2n plus 2 factorial. If you simplify this, we get 2n plus 2 into 2n plus 1 into 2n factorial. This should be less than 1, of course, okay. And clearly, like in the previous case, these two terms gets cancelled and this limit will go to 0. So definitely this mod z square into 0 should be less than 1, which is 2 for all values of z actually here, okay. So this is basically converges for all values of z, okay. So whatever you take for z, this is always converges. Clear? So let's go to the next question. Yeah, this is one more question. So let's see. For the series sigma n equal to 1 to infinity x plus 1 whole power n by n into 2 power n, which of the following statements is not correct? Okay, not correct. So let's see. So again apply root test. So if you apply, consider limit n tends to infinity u n plus 1, which is x plus 1 power n plus 1 by n plus 1 into 2 power n plus 1 into n into 2 power n divided by x plus 1 power n. So this term has to be less than 1, of course, okay. So if that term has to be less than 1, yeah, 1 is the previous correct answer for the previous question. So let's see, this 2 power n and this cancels 2 times and this becomes x plus 1, of course, okay. So what we'll do, we'll pull out this x plus 1 out, x plus 1 by 2 into limit n tends to infinity, okay. So mod x plus 1 by 2, okay. So if you pull it out into limit n tends to infinity n by n plus 1, this value should be less than 1 actually, okay. Now clearly you know one thing, that this expression is 1 because limit n tends to infinity, both the fractions are of same power. So mod x plus 1, anyhow 2 is positive, so this should be less than 2. So minus 2 less than x plus 1 less than 2, of course. So minus 3 less than x less than 1. So series actually converges only within this region, okay. So series actually converges only in this range. Series converges only in this range, okay, only in this range. So let's see what happens at x equal to minus 3 and 1. Basically you cannot decide at x equal to minus 3 and 1, but actually x equal to minus 3 and 1 are within this range, okay. So one thing, the series actually converges. This statement is true at minus 1 and this series converges at x equal to 0. These two are also correct statements, okay, because minus 1 and 0 falls within that interval, okay. But exactly at minus 3 and 1 we don't know what happens. So what we'll do, we'll put x equal to minus 3 in this equation, then you will end up with at x equal to minus 3, at x equal to minus 3, minus 3 plus 1. So this is minus 1 whole power n into 2 power n divided by n into 2 power n, of course, okay. So n into 2 power n, so 2 power n and 2 power n gets cancelled. Since this power on the top of n is 1 and there is this expression power n, so you know, can anyone tell me, if you have this series 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 and so on, this series will actually diverge, okay. This is not a convergent series. You can keep grouping up some number of terms such that this series keeps diverging actually here, okay. And this series is not convergent. Basically you can see this minus 1 whole power n is actually a fluctuating thing. So this statement is actually a wrong statement. At x equal to 1, this is 1 by n, then also it diverges. So A and D are the correct answers in this case, okay. They are not correct, okay, like correct options but the not correct statements, okay, they actually diverge. So depending on this root test and this ratio test, we decide whether the series actually converge or diverge actually. Okay, and last year and also in 2022 there is no questions basically on sequence and series, so we are expecting one question this year. Okay, fine. So let's go to the next chapter then, probability and statistics. Yeah, so basically we have basic fundamentals of probability and all, axioms and theorems, addition theorem of probability, multiplication theorem, all these things we have seen. Addition theorem, multiplication theorem of probability. Okay, divergent point ones. Yeah, in this case if you see this series basically, okay, so this series is a divergent series. Okay, normally I'll just tell you one thing. Yeah, it's an MSQ. If you have this series, okay, I'll just tell you one thing. If you have 1 by n power p, of course, okay, so 1 by n power p, so which is basically 1 by 1 plus 1 by 2 power p plus 1 by 3 power p and so on, this series actually converges for p greater than 1 and diverges for p less than or equal to 1 actually. Okay, so diverges for p less than or equal to 1. You can prove this using integral test. Okay, in case of integral test you will see, if you integrate this 1 to infinity 1 by x power p dx, this gives you integration of x power minus p dx. So x power minus p plus 1 divided by minus p plus 1 within the limits 1 to infinity actually here. Okay, this is what you get actually in this case. Now let's see, this 1 by 1 minus p is constant, of course, so 1 by 1 minus p is constant into x power 1 minus p is what you have. Okay, 1 to infinity. So let's see, when you are putting infinity here, if this has to be a finite sequence, for finite value, if this expression want to have a finite value, when you are putting infinity here, this expression power has to be negative, yes or no? So if this power is negative, only in that case this gives you some finite value. So 1 minus p has to be negative, this means 1 less than p, so p should be greater than 1. Okay, so if this is finite, then this series is convergent. That's what I given you here, converges for p greater than 1. And obviously if p is less than 1, then clearly you can understand this will diverge. At exactly equal to 1, this becomes 1 by 0, it goes to infinity and clearly diverges at x equal to 1. Okay, that's all. This is based on the integral test. Okay, fine. Okay, yeah, so based on that I have used the points here and decided. Okay, so let's see probability. So you know these theorems, basically conditional probability, Bayes theorem, all these things are known to you. Okay, so the only thing which I would like to tell here is, so basically these are the things which we have finished already. So in probability and statistics we have the mean variance calculations, deviation of random variables, correlation and linear regressions. Yeah, so basically if you see regressions, okay, when you have a set of points, okay, so let's suppose you have some set of points, this is an experimental data, this is x and y, the technique that we use for regression, least square regression, the powerful technique one we use is least square regression. So what is this least square regression actually here? Okay, so let's see, the least square regression here in this case is, for example, if you have points like this, okay, so let's say you got some points like this. Now clearly all these points are not passing through the same straight line. Okay, so what we do is we try to fit a line like this. Okay, so we try to fit a line, see, because you know you guys know about these variances. Okay, so you see binomial, Poisson distribution, normal distribution, then after calculation of variance, standard deviations, mean, median, base theorem. Okay, all these things are known to you, correct? The only thing is about the correlation and regression. So if you see, in this case, if you fit a curve, let's say for example, if you are doing a linear fit, y equal to a plus bx is the fit which you want. So you will fit the line in such a way that the squares of the errors is minimum. Like for example, you take this point x1, y1, you take this point x2, y2, then definitely there is a small difference between this line, this the interpolated value, and this value. Okay, similarly this is a small variation. Similarly, at every point you will end up with certain variations. Okay, so at every point the errors are e1, e2, e3 and so on. What we'll do is we'll calculate this error as yi minus axi plus b actually. Okay, xi and yi are basically at that point. So ei square is equal to yi minus axi plus b whole square actually. So this is squares of the errors. Okay, so at a given point, if this is the square of error, we take sum of this errors is equal to summation yi minus axi plus b whole square. So this is the value actually here. Okay, now this is a function of x and y, of course. So what we'll do is we do this summation, let's you call is s for example, then dou s by dou x is equal to 0 and dou s by dou y is also equal to 0 actually in this case. So if you do, then we can generate two equations for two unknowns a and b, that's it. Okay, so you know basically those values are normally in gate examination and all, they'll give you with 3 points, so that when they give you, you can do this very easily and get the values of a comma b. But normally when you have n points, okay, normally in Excel sheet and all will generate this n points. Okay, so I would like to just show you the correlation coefficients for correlation coefficients for least square regression. Yeah, okay, so you see images I would like to show better. So okay, better I'll show you the formulas actually somewhere. So normally when you have n by n points, you can have the general expression. So let's see, we'll see here. Yeah, this is the least square technique. So you see, first of all we'll define a line actually here. Okay, so when you define a line, y star is equal to mx plus b, so this has least square regression line. Okay, this is called the LSRL, of course, the least square regression line. So the slope of this line is actually r into standard deviation of y divided by standard deviation of x actually here. Okay, so this r is basically called the correlation coefficient, and this m is nothing but the slope of this line. Like for example, let me tell you, if you have this line, for example, you get the value of a, okay, a plus bx, okay, let's call this ax plus b because I have taken it accordingly. So if you take ax plus b, of course, then this a is actually written as some coefficient into standard deviation of y divided by standard deviation of x. Because you have n number of x points, then you can calculate standard deviation of x. Sigma x is equal to root of 1 by n minus 1 into xi minus mu whole square. Okay, so this is basically the expression for the standard deviation. So similarly you have yi points, so you calculate yi and then you can calculate sigma y. So that a is basically the fit of this line. Okay, so this a is actually the slope of this line normally here. Okay, so a is equal to r into sigma y by sigma x. This correlation coefficient talks about the variation of these two. Okay, means if this is the value, then if this, depending on these two values, we can speak how much by what amount these two variables are actually related. Okay, so this coefficient in general, in physical sense, when you're doing experimentation and if you're trying to fit data points, then this r talks about the relation between these two variables actually. Okay, so but anyway, majority the questions from probability and statistics are always from Bayes theorem, you know, Bayes theorem and also this distributions and all, because practically doing this in exams is slightly hectic. Even though if they give you, they'll just give you 2-3 points. Okay, so that first you'll generate this expression, then differentiate this partially with respect to x and y and equate it to 0, then you will get the values of a and b. That's it. Okay, so that's what I'm giving you some questions, so please solve these questions. Okay, so these are some classical questions from PYQs which I have already solved in the last year's thing. But here, yeah, one important point I want to tell you, if you have two variables, for example, independent. Okay, so first let us see what are these cases. If you have a variable x which is normally distributed having mean mu x and variance sigma x square, guys, if you see something like n bracket of 0 comma 9, this means this y is normally distributed with mean 0 and variance 9. Okay, this is not standard deviation, square of standard deviation, which is variance, and y is normally distributed again with mu y and sigma y square. Then if you take z is equal to ax plus by, for example, this is any linear combination, like I have given you x plus y by 2, then z is also normally distributed with mean a mu x plus b mu y, this is one term, and a square sigma x square plus 2ab times covariance of x comma y plus b square sigma y square, actually in this case. Okay, so this is the expression. And now if you try to understand something, if variables are independent, okay, so normally they'll give you independent variables to make this covariance 0. Covariance is actually given by expectation of xy combined minus expectation of x into expectation of y, and when things are independent, this can be written as product and those can be cancelled. Okay, so in this case, this normal distribution is given by this expression, z is normally distributed with a times of mu x plus b times of mu y. If you have a minus sign here, then minus here. Okay, these two will be pluses, this will be minus. Okay, and comma a square sigma x square plus b square sigma y square. This is the case if independent. Okay, so covariance is basically 0 if variables are independent. If variables are independent, okay, so then you can use this basically. Clear? So let's walk through a bit of numerical methods. Okay, so in numerical methods, so the syllabus is again same, the only one thing that changes is interpolations. Okay, so you have the interpolating techniques which I would like to give you. Newton's second order interpolation, Newton's second order interpolation, and Lagrange's interpolation is what I'll give you. So if you see, we have, if you have an example 3 points x1 x2 y1 y2 and sorry x1 y1 x2 y2 and x3 y3, and x3 y3 for example. Okay, so if you have this, then the function f of x which is generated is something like f of x1 plus f of x2 minus f of x1 by x2 minus x1, so this is one term, plus f of x3 minus f of x2, this is basically the second derivative in finite differences, so x3 minus x2 minus f of x2 minus f of x1, this function, divided by x2 minus x1, this whole value divided by x3 minus x1 actually here. Okay, into x minus x1. Okay, here also there is x minus x1, sorry, so here we have x minus x1, okay, into x minus x2. So this is basically the expression for the Newton's second order polynomial. You can clearly understand this is nothing but slope between 3 points. Like for example, you have the system, you see this is x and this is y, of course. Okay, so if this is x and y, then you understand here there are 2 points like this, for example 3 points, let's say, if there is a function which is passing like this, okay, and you don't know what is the value at this point, for example. Okay, so you know the x but you don't know what is the value of y, then you can use this technique to interpolate any value between these 3 points. Okay, so this is nothing but the slope between these 2 points. If you connect these 2 points with a straight line, and if you connect these 2 points with this straight line, then we take the help of the slopes between those 2 points, like how effectively y is increasing after it crosses point 1. Okay, similarly after point 2 how effectively it crosses, and after 3 how it crosses. Okay, so we'll use this expression to calculate the effective value f of x at any point basically. Okay, and Lagrange's interpolation gives you things like Lagrange's interpolation. Lagrange's interpolation. If you have n number of points, for example, this function f of x is given by summation. For example, for the ith point, if I am writing, then this gives you x minus x naught or x minus x1, let's say first point, x minus x2, and so on, x minus xi minus 1, x minus xi plus 1, and so on, x minus xn, divided by this expression divided with xi minus x1, xi minus x2, and so on, xi minus xi minus 1, xi minus xi plus 1, and so on. This goes up to xn multiplied with yi actually here. Okay, so this is where I is running from 1 to n. So right, starting from the first point, the Lagrange's interpolation is generated by this expression. Okay, and in this expression we'll actually calculate values. Okay, so sometimes in exams what they give you, they'll directly give you the polynomial, interpolating polynomial, which I would like to show. So for example, you see this question. Okay, so you see this question, suppose alpha, beta, gamma and delta are constants such that this p of x is basically generated by an interpolating polynomial which is given by delta plus gamma of x plus 1 and so on. The interpolating polynomial data is given these 4 points. So basically you have 4 constants here, delta, gamma, beta and alpha. So 4 points are given so that this polynomial which is fitted is passing through the 4 points. If these are passing through the 4 points, value of gamma minus beta is dash. Okay, so let's see, p of x is equal to delta plus gamma of x plus 1 plus beta times x into x plus 1 plus alpha x, x plus 1, x minus 1. Okay, so this is what we have, and we also have points. The data fits minus 1 comma minus 3, 0 comma 1, 1 comma minus 1 and 2 comma minus 3 actually here. Okay, so first of all let us put x equal to 0 because there is x multiplication, or x equal to minus 1 let us keep. Okay, let's keep the first point. So if you keep the first point, this implies minus 1 comma minus 3. So if you put minus 1 comma minus 3 in this polynomial, this value of p of x is minus 3 when if you put x equal to minus 1. If you put x equal to minus 1, these 3 terms will go to 0. Okay, because there is x plus 1 each and every term, so these 3 terms will go to 0. So delta, so that's it. So delta is actually minus 3 in this case. Okay, then 0 comma 1 implies, so this value is 1, delta which is minus 3 plus gamma times of, when you put x equal to 0, this is 1, so this implies gamma is equal to 4. That's all. Okay, so gamma is equal to 4 because when you put x equal to 0, these 2 terms will go to 0 because there is x equal to 0 and all. So one potential float, where can I ask you? You can ask me today or tomorrow. I'm taking extra topics for XC, so there you can ask, no issues. Okay, now coming up to the third point, 1 comma minus 1. So this implies minus 1 is equal to, when you put x equal to 1, this third term will go. Okay, we have already value of gamma, we need beta, so which we will get now. So let's see, delta minus 3 plus gamma times 1 plus 1, so this is 2, plus beta times of x is 1, so this is x plus 1 is 2 actually here. Okay, so this tells you 2 is equal to 4 times of 2 plus beta times of 2 actually. So this gets cancelled, this is 1, so beta is equal to minus 3 again in this case. Okay, gamma is equal to 4, so this implies your beta or gamma minus beta is equal to, gamma is 4 minus beta is minus 3, so this value is 7 actually in this case. Okay, so basically when you have interpolating polynomials, just substitute the conditions what they have. Okay, if you just substitute, then you can get the values. Otherwise sometimes this polynomial they won't give, they'll give you something like this maybe, then also you can work out. Okay, yeah, anything could be fine. Clear? Okay, so basically interpolating things are the only things which which is additional in syllabus other than mechanical. So that's the case. Rest all you have in the syllabus. Okay, like you take the LU decompositions or Gauss-Seidel or basically numerical integrations, numerical differentiations, all things you have in the syllabus. Okay, so anyway, whatever I told you, that 3 videos what we have done in the last, PDF milegi pakka. Okay, I'll share the PDF to you today itself. Okay, so once you have 3 sessions of that last year abhyas, so please go through them. Okay, they will definitely benefit you. Clear? So with that we close this Maha revision for maths. PDF will be in the Telegram group. Okay, so PDF, if you see, PDF notes will be in PW app. Okay, and basically in free batches you can find it, or else in the Telegram group also I'll upload. Clear? Fine. Okay, so definitely after writing the exam you will tell these 2 lectures yesterday and today will definitely help you in getting good marks. Okay, so don't worry, just be yourself, stay calm and appear in the exam. That's it. Okay, so I hope things are fine then. Thank you. Okay, yeah, so thank you all. We'll meet tomorrow again at 6 p.m. again for doing some bit of extra topics of 𝐂𝐸 FM fluid mechanics. Okay, thank you.